Hi, I'm Sam Nielsen and welcome to my class on advanced lighting. In this class we're going to talk about everything from how to set up a lighting scheme to how the human eye and brain react to light. So for this course I'm going to assume that you have a basic understanding of painting, digital painting. I'm going to move quickly. Not going to talk a whole lot about the programs. I'm going to demonstrate mostly in Painter, maybe a little bit in Photoshop. But for your assignments, the program that you want to use doesn't really matter that much. I mean, even if you want to do things traditionally and find a way to transfer the files, that'll work too. So most of the learning in this class will happen with the assignments, but the lectures are important because they'll set kind of the basis for the things that you'll need to be paying attention to in the assignments. So first, we're going to talk about the properties of light, just some basic properties of light, and Lambertian reflection. We're also going to talk about basic lighting scheme information in this lesson. But first, let's talk a little bit about light. Light is something that we don't know a whole lot about. Scientists have some, a bunch of equations for predicting the behavior of light, and they understand some things about it, but we don't even really have the terms in our language to describe what it is. It's got multiple attributes and multiple ways of behaving. Sometimes it behaves like a wave, sometimes it behaves like a particle, and mostly as an artist, it's important to understand the principles that light runs by, but you don't need to understand everything. You don't need to understand all of the equations, but it is good to understand at least some foundational things, and there's quite a few complex things in how light interacts with the world that we're going to learn about in this course. So just talking quickly about some terms as far as this lesson is concerned. First, I'll talk sometimes about quantum physics or quantum probability. Quantum basically means that it's something that is unpredictable at a microscopic level. So a little particle of light zipping along, how it's going to interact with, say, an atom, we don't really know what's going to happen with any given atom. But there are probability fields surrounding these atoms that say how much probability it is that the light is going to be deflected that way, how much probability is that it's going to be this color, and so forth. And when you have particles and light in large masses, those probabilities become predictable fields. You can expect a certain result over a large area. So when I talk about quantum this or that, I'm usually just referring to something that's dictated by probability, but that we can expect to see a consistent result on a larger scale. So another term is photon. I talked about the particle of light. So we have both the wave and particle versions of light, or attributes of light. For this lesson, we want to talk just about the particle. If you want to imagine a photon just being like a billiard ball zipping along in a consistent direction at a really high speed, 186,000 miles per second, which is really fast. And when light hits something, let's say a surface, there's a predictable way that it's going to bounce off that surface depending on what that surface is. So for the sake of this lesson, where we're talking about Lambertian reflection, we're going to be talking about either a rough surface or a surface that is not conductive, and in both cases the light is going to ricochet in a random direction. We'll talk more about that in a second. Another thing that I'll talk about is a vector. So I'll try and describe it in this case as kind of something flying forward in space. A vector is a three-dimensional angle in space. And so when I talk about a vector of light, I'm talking about the angle that it is flying in a three-dimensional space. It's important for understanding light that you can think in 3 dimensions and kind of picture things in that way, and that will help you to work out the types of things that light is doing in your image. And like I said, with reflection, that's another one of the terms. It's the bouncing behavior of the photons that are not absorbed by what they hit. We'll talk more about absorption later. And when I talk about fall off, let's just switch out my brush real quick. So when I talk about fall off, what I'm referring to is what is the speed at which things go from light to dark. So does it stay light for a long time and then suddenly become dark? Is it a nice solid gradient? Or is it something that stays dark for a long time and suddenly gets light? Those are different rates of fall off. And usually that rate of fall off is going to be in reference to how light is, how a form is lit up as you go over the surface of the form. What is the rate of fall off, basically. Okay, and this is going to be an exciting subject. We're going to talk about a lot of different things with light, but as with most things, we have to talk about some of the basics first, so forgive me if this is a little bit of a review for some of you, but it's necessary that we cover this. Okay, so like we've talked about, when we're discussing form and Lambertian reflection, we want to think about light as being like a billiard ball that's flying out in a constant direction. And from a single light source, it's going to be flying out radiating out from that central position of that light source. So, and usually there are so many photons, even though I've represented it here as being just a few. Usually there's just trillions and trillions and trillions flying out over time from any light source, and you just have to assume, even though they're invisible, that there's enough there that you're not going to see the effects of any individual photon. This is a quantum effect again. So any surface is going to be invisible without light. The only way that we see something is when light comes from a light source, bounces off of the surface, and enters our eye, and then our brain is able to interpret the information that the light is giving our eyes. So with a Lambertian surface, the light will fly in a constant direction, and it'll bounce off of that surface, and it'll create for that surface, for a constant light source, it'll create a constant color on that surface. That surface basically becomes that value and color as a result of the light bouncing off of it and reaching our eyes. However, as the light, or as the plane turns away from the light, like you can see this plane and that plane are supposed to be the same size essentially. If you assume that the photons that are flying through space are distributed fairly evenly, which with most light sources they should be, at least to our eyes, that even distribution is going to cause, on a surface that is facing towards the light, that is, I'll use the term perpendicular to the light source. So if our light source is over here and it's flying this direction, perpendicular is like that relative to the light source. So, and if you can think of that as a right angle as well. So a surface that is perpendicular to the light source is going to be the brightest surface, and as it angles away, what happens with that even distribution? Look at this. 1, 2, 3, 4, 5, 6 photons hitting that surface, and in this case, not even 3 hitting that surface. I suppose if you shifted them a little bit, you might be able to get 3. So what this causes to happen is the surfaces get darker just because of the distribution of photons as they turn away from the light with Lambertian reflection. Another term for Lambertian reflection is just a matte surface, is another way to think of it. So I did just a quick 3D model here, and I included a specular highlight. Ignore that. What we want to look at now is the Lambertian diffuse or matte highlight. So when it's broken out into a bunch of chunky planes, it's pretty easy to see this effect happening. It's getting darker as it turns away from the light, and as you increase refinement, whichever way you want to do it, it's going to start to appear more and more like a rounded surface as those planes are turning progressively farther and farther away from the light. They're going to get darker and darker until they reach a point called the terminator or terminus, where if the light source is coming directly from one direction, that terminus is going to be at the halfway point on the ball, if it's a light source that's either far away or a single point light, well, for a distant light. So that 50% point on that surface is basically the point at which any photons flying toward this cannot land on any of the planes that are facing this direction past that terminus. So it's gonna, that rate of fall off from this point to that point is going to be consistent with the angle of the planes, and because this is a sphere, it's going to stay light for longer and then suddenly roll off fairly quickly in value towards that terminus. Usually you'll have a distinct terminus with a single light source like this, and that doesn't necessarily mean that it isn't a soft edge. It just means that there is a definite cutoff point. The light isn't going to go past that point, and it's not going to stop before it reaches that point either. So, whoops. If you're thinking in terms of planes, and you can break any surface up into planes, you can imagine, okay, this plane is facing that direction, this plane here is facing out that direction, this plane here is facing that direction, and if my light is coming in, I should be able to figure out, based on that, what the value of that plane should be relative to that light source. And this isn't something that's just going to come immediately and automatically. It's something that comes with experience over time, and sometimes it helps to actually render out a quick sphere. I actually had a sphere kind of as part of this, but let's just use the colors we've already got, because it's easier to tell with a sphere whether you're getting it right. And I imagine my light is coming from that same upper angle. And I'll find my diffuse or Lambertian highlight. It's going to be at that perpendicular point to the light. In this case, it happens to line up with the edge of the sphere. It won't always. And then I want a nice solid fall off from that point. I don't want to have any banding between those points. If I was using a different brush, I might get a little bit of artifacts just from the brush, or texture from that brush, and that's okay. In this case, I'm using a nice smooth brush so that it's not confusing what I'm trying to explain, but it's okay if a little bit of that texture shows up in your assignments and so forth. So now, if I wanted to render a shape that was kind of a unique shape, what I can do is, first of all, I can map out. That's what I did here. I figured out what the light angle, and I figured out where those diffuse highlights would be, and then I figured out where the terminus or terminator would be on each of these forms, and didn't draw any of my lighting past those points. Then what I can do is, for figuring out the lighting, if I'm not sure what the lighting is going to be on that plane right there, and in this case I put an extra light source in, so don't be too confused about that blue. If it's a single light source, what I can do which actually you can do multiple light sources with this method too. All I'd need to do is kind of figure out what I was going to do with that other light source, and I could mix it in there like that. So what I can do now is, if I'm confused about, say, that plane, all I have to do is visualize in 3 dimensions which angle that plane is on, and then compare whatever that angle is to, and find that position on the sphere that's angled out that way. Because it's pretty easy to visualize on a sphere which direction the planes would be facing. If it is hard for you to visualize, then I'd recommend, spending some time in some 3D programs so that you get a good sense of three-dimensionality. But then you can basically you can even use a color picker if you want, and find the plane that's facing that direction, and then color on your object, and work out your rendering accordingly. So, this is called, I've often referred to this as a sphere test. So you're testing out your lighting on the sphere, and then you're using the sphere and basing the rest of the lighting in your scene on that, or off of that. So there are a few standard, I guess, form types that once you've kind of mastered these type of form changes in any single type of lights, or once you've learned to master them in any type of lighting situation, you can basically handle any type of complex form. So these 5 different types, first is curves, and ignore the specular highlights again, but just any type of soft change from one form to another is going to be a little bit tricky. An intersection, it's essentially as if you just took the 2 different sphere tests, and just kind of cut them together. In fact, that's what I did in this case. I took 2 spheres, or I painted 2 separate sphere tests, and then I just kind of overlapped them and then erased away part of it. And then another thing you can see I did here is I put in some bevels, just tiny bevels, to kind of aid in that intersection, just because most things are not going to have a perfect, especially manufactured things aren't going to have like a perfectly machined seam between those 2 things. There'll be a little bit of a bevel as a result. And the cast shadows are a little bit tricky as well, but we'll talk a little bit about cast shadows when we do the demonstration at the end, so don't worry too much about that. There are corners and edges, as you can tell here. They're basically big flat shapes, flat colors, where you cut off the thing. You can see I also put in the bevels here. You've got holes. In order to get a hole to be rendered correctly, of course, you're going to need to be able to deal with cast shadows, but also something else we're going to talk about in a minute called occlusion, or dynamic occlusion it's also called. Then there's dimples. Dimples are a little bit tricky. It's almost like an intersection that closes all in at one point. It actually took a surprising amount of time to figure out and paint these so that they looked good. Dimples are kind of a challenging one. And of course there are all sorts of hybrid things in between, and once you're able to master those things, you should be able to deal with lights, or deal with just about any type of shape or form. Now let's talk quickly about... Nope, not that. Lights. So we talked initially, or just barely, about distant sources. This can work with sunlight, spotlights as well, kind of work the same way. Essentially what it is, it's a light that's a ways away, and it sends out light rays in kind of a parallel. All of the light rays are essentially parallel to each other. all of the photons streaming out. And this behaves in the way that we've already described. The cast shadow is going to be essentially the exact same shape and size as the object because the rays are parallel. A nearby light source, on the other hand, is going to have a much larger cast shadow because now those rays are no longer parallel to each other. And nearby can be a relative term depending on the size of the object. But the other thing that changes with a nearby source, here you can see the terminus is at the halfway point, whereas here the terminus is quite a bit higher. And so essentially the shadow area on the ball is growing as well as the source gets closer by. On the other hand, if you've got an oversized light source, something that is large, you're going to get light rays that are now, instead of kind of radiating outward from that source like we had in the previous example, you're going to have light sources or light rays that are going out in random directions from that light source and kind of filling in the shadows. So now your shadow is going to get very soft. And one way that you can approximate this is if you were to figure out a circle of lights or something like that, and how far would they go and where would they overlap, and then you could blend them all together. I've actually seen people do that with a 3D rendering program, but you can approximate it pretty well if you just look at your light source, figure out where those photons are going to be traveling, and that's going to be kind of the extent of the softness of your shadow. And of course, any part of the ball that is able to block out the majority, or underneath the ball that's blocking out the majority of the light, is going to be pretty dark. So this type of light source is a really important one. It's one that you're going to be painting with a lot, and it's something that dictates a lot of things, especially in shadows or in ambient light. So understanding and being able to paint a diffuse source is important. In fact, let's just talk quickly about ambient occlusion or dynamic occlusion. So when you've got an ambient light source filling in your shadows, you can see that the shadow of this ball isn't black, it's filled in with light from a color. And some of it is light bouncing off of this surface here. Some of it is going to be bouncing from the room around. There's going to be a point, well, backing up a little bit, every time that the light is coming in and bouncing off of this surface, or bouncing off of this surface onto the ball, it's going to be bouncing multiple times, but each time it's losing a lot of the energy, generally speaking around 90% of the brightness of the light is lost with each bounce. So because of that, it's very difficult for light to get down into the deepest cracks of things. And I didn't paint this very well because it should be dark both on the bottom of the ball and in the shadow as well. There should be this kind of soft fall off where light is no longer able to reach into those cracks. And we'll demonstrate how to paint occlusion a little bit later. So another thing to remember is that usually there is ambient light in almost every scene. And so because of that, when you've got a cast shadow, it's not black. So whatever your ambient light of the scene is, in fact, sometimes it's good to do a sphere test that is using your main light source, and then to do a sphere test of what I call the underlighting. So that's where you're painting what all of the reflected light and ambient light in the room is, so that you know what's going to happen when you're trying to calculate out in the shadows what's going to happen there. And there's a couple other things that are a little bit tricky about lights, and this can happen. This is something with nearby light sources, that when you've got a nearby light source and a flat plane, that flat plane isn't going to be a solid color anymore. Remember when I went through the forms here, I said that the flat planes are going to be a flat color. That's only if you have parallel light rays. But if in this case you've got a nearby light source where they're no longer parallel, that same type of distribution that we talked about where the plane turning away from the light is going to get darker. In this case, the plane isn't turning away from the light, but the rays are still getting spread out farther and farther with distance just because of the angle of the rays. So the part closest to the light source is going to be brightest, and it's going to get darker out from there if the light source is nearby. Another thing that's going to affect your lighting in a scene to remember is the perspective of the viewer. So even if you've got a parallel light source and a bunch of objects in the scene that are all the same, they're going to be lit differently depending on how the viewer is looking at that thing. So I imagine in this case a single light source looking down on kind of a chain of balls, which I moved them closer together. If you're actually looking at the scene, they'd probably be farther apart. But see how much the terminus changes in its position, and also the diffuse highlight is going to be changing to the point where here it's actually behind the ball and we can't see it anymore just because of our positioning in the room. And I mentioned briefly already about bounce light, but if you've got a sphere sitting on a table, you've got a light source that, even if you've got a single light source, you've actually got multiple light sources, because what happens is the table becomes a light source as well, and you've also got the ball, which becomes a light source of the table. So all of these interactions are going to affect how you paint the scenes, and we'll again demonstrate how to handle that later. So let's talk about lighting schemes, at least in basics. So, there's a couple different types of light that we'll use in a scheme, and the types of light, as far as whether they're area lights or nearby lights, any one of these lights can be, so like a key light could be a nearby light source, or it could be an oversized light source, or it could be a direct light source. Same type of thing with a fill light, same thing with a rim. So keep that in mind as well. A key light is, generally speaking, the strongest light source. It's going to be the one that defines the emotional impact of your scene, and it's going to do the biggest things as far as like the form and drama. A fill light is, generally speaking, not going to be as bright, and I'm drawing these in different positions, but they can be in all sorts of positions. A fill light is usually going to be a softer light, but not always, and usually it's a lot darker. It's not the dominant light in the scene, and it's usually just filling in the shadows and adding color, interest, and things like that. If it helps, you can think of a fill light as being kind of like the supporting actor in the film. Then a rim light is usually one that comes around the outer edges, and it's going to be one that helps to define shapes in the scene. It's going to add dramatic appeal, but it's not going to do nearly as much as far as describing the form. It's usually something that's a compositional and emotional thing to add. There are other types of lights, kick lights and things like that, that are used in film, but most of those lights are variations on these three basic types, so we won't talk too much about those in depth. So any lighting scheme is going to be a combination of these three things. You'll have a fill light, you'll have a key light, and you may have, in some cases, a rim light. I'm not being terribly careful about how I paint these things in right now, and you'll hear people talk about the 3-point lighting scheme. Usually that's using a rim, a key, and a fill. And I know a lot of people don't like it, but I think it's a good place to start if you're painting. And then you will expand outward from there. I don't think it's always necessary to use all three. And in some cases, having something that is maybe, say, a 2 fill light lighting scheme might actually be the appropriate thing for the scene, and so forth. So the key light, and this is going to be true of the fill light as well, even though I say here key light direction. The key light direction is going to be important in setting the emotional tone of your scene. It's also going to be important in defining the forms and kind of I guess just in general, telling the observers or the viewers how to react to what they're seeing. So in this case, I started with this little frog with just a fill light so that he wasn't just black. And in this case, we've got a direct overhead light. Generally speaking, direct overhead lights are... You may think that they are a natural light because we have the sun exactly overhead and stuff at noon, but really it doesn't read as being that natural of a light, maybe just because the sun isn't directly overhead very often, maybe only one time a year. And usually it's used in movies as kind of the, guy being grilled under the lights, or kind of to create a little bit of unrest in a scene. And it may have something to do with the same type of principle as when you center something in a composition, it feels a little bit unnatural. Maybe it's the same type of idea, that when the light is centered, it feels a little bit unnatural. And it's a good way to create just a little bit of tension in your scene without going overboard necessarily. And a angled light coming from the side is, if you push it too far behind the character, it's going to become a fill light. But if you have it more directly from the side so that it's defining the form, it's going to tend to be a little bit more of an active light source, something that adds a lot of drama to the scene. It's going to add dramatic tension to the scene and not necessarily that unnatural tension. This might have something to do with just, our reaction to seeing sunset lighting or early morning lighting, possibly lighting from doorways or whatever else. Stuff that we see all the time in films. And, realistically, the stuff that we're seeing in films is part of our psychology, as well as stuff that we've seen in illustration through the ages. It's kind of formed our cultural way of dealing with light. So these are good things to remember about what you're doing with your key light. You've also got a frontal light. This isn't a direct frontal light. If it's directly frontal, it starts to feel like a flash and it starts to feel very unnatural again. Probably that centering phenomenon again. But if you move it a little bit to one side and a little bit above, then it can start to feel a little bit more natural again. And this tends to be a very comfortable way to position your light. It's something that keeps the character from being in too much shadow. It's pretty good at defining forms on the character. It tends to be a little bit friendlier and softer, even if we've got a fairly, direct light here. This isn't necessarily a fill light, but it tends to feel like a fill light because of the way that the form turns, or because of the way that the light turns in the form. Then we've got underlighting. Underlighting is probably the most unnatural feeling of light, and this is again something that's kind of built into us both by cinema and just our natural way of responding to the world. When you've got light underneath something, it tends to feel very dramatic and very unnatural, and it in a lot of cases is used to make something feel like it's spooky. Then another thing to remember about the key light, and this again also applies to the fill light and rim lights, is the exposure of the light, how bright the light is. So if it is a softer light, I should have drawn that softer. It's a softer light, then it's going to tend to be a little bit friendlier, a little bit more approachable, whereas if it's a strong, harsh light, then it's going to add a lot more drama to the scene and tend to be a little bit less friendly. So all of these things, all of these light positions together they're things that can be used in conjunction with each other when you're combining your key and your fill lights. So, for example, if I do, let's go back to this oval. If I have maybe a more friendly key light, but then I've got underlighting coming from a fill light, that's going to tend to mix just a little bit of the two things that we've had here, where we have something that is, especially if we, sorry, trying to say two things at once, especially if I pull that light source so that it's a little bit farther behind, so that the more dominant light is that fill light, then that's going to start to feel, it's going to mix emotionally a little bit of both worlds, a little bit of the dramatic things that are going on the upper side, as well as the unnatural lighting coming from the underside. And so if you want to create something that feels, maybe it's not a horror scene, but you want people to get a sense of foreshadowing or foreboding, this might be a good thing to do. Same type of thing with, let's start over with this. Oops. If I want to do two lights from the sides, and in this case it looks like I'm putting two lights that are the same brightness, and I don't want to do that. Generally speaking, you want one light to be slightly more dominant than the other so that we know where to look. And this is going to be a pretty common lighting that you see. They use it in ballet to kind of lift the dancers. But it's also, in fact, usually what they're doing is they're doing the lighting a little bit more underneath in ballet. But it's also a type of lighting that you see in comic books all the time because it's kind of dramatic. You're getting that sort of active lighting, but you're getting it coming in from both sides. And so it just ends up feeling like just really interesting and dramatic. So there's a lot of different permutations. This is something that you can explore with a little bit. It's kind of fun to play with lighting and the emotional effects that you can have with various things. I think there are probably lots of schools of thought for more specific, like these are the rules that you go by. But I've found that there's a lot of people who once you understand the basic rules of how we respond to lights, it's okay to break those rules. You can mess around with a lot of different things and get some really interesting effects with it, and actually get some complex things that go into a scene. There's another added dimension to this in color that we'll talk about later. Oh, and before I move on from this subject, let's go back to this sheet, even though I've scratched around on it a little bit. So these different types of light sources also have different emotional effects, and so you'll want to take that into consideration when you're setting up your lighting scheme. So a sunlight, spotlight, distant sources, these tend to be fairly neutral lights, but when used on angles and stuff like that, then you can actually get a little bit more out of them. But they aren't necessarily more active and more energetic unless you're playing with the exposure, like we talked about before, when they're in more, I guess, like recognizable or more comfortable positions. Nearby sources, on the other hand, or anytime that you've got a point source, so if you've got multiple objects in a scene, like a bunch of people sitting around a campfire and they're all kind of lit by that same source, these nearby sources tend to be a lot more active. They tend to add tension to a scene. They're a little bit harder to paint because of the way that the light is changing from every angle, but it's that same light changing from every angle that makes them so interesting. It can actually go against you having a point light or a nearby source in a scene if you're not wanting to distract too much with the light source. The light source can actually become distracting if you're not careful with it. So make sure that whatever that light source is, essentially what it is this light source becomes a focal point of the scene because everything else is reacting to whatever that light source is. So just be careful when you're using a point light source, and probably same type of thing with a nearby source. If you have like a lamp shining on something, in most cases, people's eye is going to go to that thing in the scene. Then with oversized or diffuse sources, these tend to be very soft, friendly light sources. It's very hard to make these light sources be anything else. Again, like I said, this is the type of light that they use to make fashion models look good in magazines. And it's, in movies, they'll use, double fill lights that are kind of these oversized sources to just kind of make you feel a little bit of empathy for the character, or maybe not empathy, but to feel a little bit more warmly towards the character and so forth. So keep that in mind. One other thing about lighting schemes to keep in mind is that cast shadows are another element. So this type of thing for something that is off camera is going to affect the emotional tone of your scene. Generally speaking, it's going to add drama and mystery to your scene to have part of it covered in shadow, especially when it's something off camera that's casting that shadow. So when you're actually like setting up whatever it is, your picture with a guy standing there looking out the window, it's going to make a big difference if you have kind of a soft, diffuse source lighting the guy on this side. That's going to tend to make him look a little bit more friendly and make the scene in general feel a little bit more comfortable. Whereas if you have, slats of light coming in through the blinds or something like that, it's going to start to feel a little bit more like a mysterious scene, or, we're going to feel the tension in that scene because of that, because of the way the shadows are being used. Okay, so we're going to start a demonstration now on how to attack this assignment. And let's go to show you what your assignment is. I drew this diagram before. Basically what it means is the light is not coming directly from from that angle to the side. It's actually a little bit in front of the object and shining back in space towards it. Hopefully that makes sense. And what you're going to want to do with this assignment is render this scene as though it's lit by that light. If you want to add in a rim light or kind of fill in the ambient lights with fill lights, that's fine. But the main thing is I want to get the basic rendering of form down, and the way that light bounces off and interacts with this shape. Then the last thing is, and I'll demonstrate how to do this in a second, is take a section of this, either one of these larger sections probably, and add some texture to it. So now we're going to move on to our demonstration. And as I do this, pay attention to how I handle subtleties in the form that are only suggested by the line art, such as this little change here, and how I handle stuff like occlusion edges. All the stuff that I do on the assignment, even though it's going to be different line art, it is going to be a good suggestion or direction on how you attack this problem. First, we start with some line art. And if you want to just start with the flat lines and paint underneath them, what you can do is you can paste them up on a layer, just select everything, copy and paste. And now I'm just going to switch this layer type to multiply. I'm going to turn it down so that it's pretty light. Now I'll fill the background, oops, not that, fill the background with kind of a darker color, something like that. And there are multiple ways to attack this assignment, and you can do whatever way you feel most comfortable with. But what I'm going to show, and you know, when I say whatever you feel most comfortable with, don't feel like you need to get the exact same type of results that I'm getting, such as if you want to, you know, just take some brush that has a lot of texture to it and just work out your assignment just using that, and it ends up with a little bit more texture and a little bit more I don't know, brush stroke E-ness. I'm not sure if there's a word that describes what I'm looking for, or what I'm saying, but essentially, if you want to just paint it straight up and kind of take some of the artifacts that come from that, that's okay. Just as long as in the end what we get is something that feels like you understand what those forms are and that describes the subtleties of light that are going on. So the method and even the style of it doesn't matter that much, again, as long as we're getting the other results that we need. So, like I said, you can just pick up the lines, paint underneath it. I'd recommend strongly that you turn the lines down till they're pretty light as you paint this, and possibly even as you get it pretty well established, getting into those lines completely. In the file that I gave you, though, I gave you the lines kind of separated into shapes, and you can combine them all together just to make sort of a super shape. And I'm going to keep my lines on top of that so that I can just paint on top of this. Let's go ahead and fill the background again with that darker color. So I am painting against a darker color. I'd recommend doing that just because you'll have an easier time, not necessarily black, just kind of in the darker gray range, because you'll have an easier time seeing the subtleties in the shadows when you do it that way. And then there's a couple different ways that you can approach the painting process now. First one is, I talked a little bit before about the sphere test, and that is where you just kind of create a sphere. And I'm going to paint this sphere to look like the form that I'm trying to render, or to have the values that I'm wanting to render into this form. And since we're not painting in any specular highlights or anything, feel free to go all the way up the spectrum to white if you want. Just make sure that there's a natural fall off going from the lights to the darks on this. Because the sphere is rounded, it should stay light for a fairly long time before rolling off, but not too long. It shouldn't feel flat with this sudden fall off like that. It should have a nice gradient, but the gradient should be flatter at the top and gradiate slowly and drop off fairly quickly towards that terminus. Also make sure that that terminus is you know, that you've kind of mapped it out. You know exactly where it is. Don't just make this fuzzy edge there. You want something that feels pretty definite if you want it to feel true to life. And then once you've figured that out, I could probably spend more time with that trying to get it perfect, but that's good enough, at least just for demonstration purposes. Now if I want to go back to this, and I'll turn on preserve transparency, then I'll fill that background, and I'll just start looking at the planes on this. So you have to, in order to do this, be able to feel out in your mind or imagine in your mind's eye what the form of this object is. You have to be able to look at this and say, okay, I'm imagining that the planes on this are kind of angled towards me, and up a little this direction. I'm gesturing with my hands, which of course you can't see right now since you're looking at what I'm doing on the screen. And but you should be able to figure out stuff. So based on what I imagine that plane to be, I can find that exact same plane on the sphere using my color picker and then fill in that area or that angle of plane with that color. And I can get brighter colors for the brighter planes and work in the transitions. It looks like I didn't get that quite smooth enough going down. And then I'll find areas like towards the terminus. You can probably work out that plane. And then once you've worked out that stuff, then you can come in with any type of brush that does blending, like this, not the smear. Diffuse blur is pretty good, and just kind of fix those edges, soften them down a little bit. I'm not sure that this is the best blender for the job, but it could work. You could use it. Probably going to be easier to use something like, I used the loaded palette knife before. I think if you use the regular palette knife, you can actually blend stuff pretty well that way. Except for some reason it's not responding to the angle of my brush anymore. Oh, I know why. It's because I have to change the brush to do that. Angle, set that to bearing, and that's better. So this is a little bit of an awkward way of doing it. If you're using an older version of Photoshop, something like this is probably the only way to do this type of assignment. Either that or just paint it perfectly with your airbrush in the first place. Alright, so let's describe another way of doing this. And this is probably the fastest way of doing it. And let's change my brush. And if you're curious about this brush that I'm using, it's from Painter. If you pick the 2B pencil and then go to, well, let's just do it. Go to your brush controls and change under the general panel this from build up to cover on their method, and that'll give you the same type of airbrush effect that I'm using here. It's kind of like an airbrush that if you push hard enough you can get a harder edge with it, instead of if you actually use a regular airbrush. And anybody who's using Photoshop needs to pay attention to this. Oops, that's not the airbrush. The digital airbrush has a very soft edge, so no matter how hard you press, there's always going to be a very soft edge there, and it's very hard to get a painting like this to feel right if you don't have any edges. So I'd recommend using some kind of brush that has edges. Another one that I like that has a little bit of an edge to it is under acrylics, the captured bristle. So this one has a little bit more texture to it, but it should be fine for this assignment. You can work out all the forms and everything. It kind of has some airbrush-like qualities to it, but then if you need to get an edge, it's pretty good. But let's go back to my soft, squishy brush. And we'll start with a flat color. One thing that I didn't do in the sphere test before is I didn't work out my underlighting, so we'll do that right now. So the underlighting is basically what's going to happen in the shadows. So I don't want to paint with black, but maybe I want to figure out what is going on before I paint in my key lights. So I can work out the shape of this sphere. Just a general tip for painting stuff like this, especially if you're using something like an airbrush or a softer edge brush, make sure that you paint big to small. And this is going to be true with a lot of things. You're going to want to work big to small. It's true when you're designing something. But with your brush strokes, you just want to use the biggest brush you possibly can to get the job done. So I'll use large strokes and work the larger areas out. And then if I want to get into the nitty-gritties and work out details, I can do that with a smaller brush. But it's much easier to do that, to have your larger shape worked out and then go in with the smaller brush, than it is to try and do the smaller things and then work it into the larger shapes. So I'm not worried about cast shadows because this is an ambient light. It's going to be filling up the whole scene. It's probably a little bit too strong. Let me just darken this whole thing down a little bit more. One thing I didn't talk about with lighting schemes earlier is, we talked about the emotional component of a lighting scheme and the way that, lights can help define forms and things like that. But one important thing to keep in consideration when you're setting up your lighting scheme, deciding where to put your lights, is how do you want the shape and composition to work out. So when I'm and this is both with like the silhouette, if I really want this whole thing to stand out from the canvas and be interesting, then I'm probably going to want to have my general ambient lighting be brighter than this. So I might actually start off with something not that bright. We'll pull it back a little bit. That stands off, even in the shadow, it stands out from the canvas. So that's the type of consideration that you would look at in addition to the emotional components of your lighting, making sure that the important reads are happening because of the lighting. And in this case, I don't know if it matters whether I start light or dark, but I'm just going to stay with the lighter version of the ambient lighting. And it's okay for this to keep the lighting in general just a little bit softer. We're imagining a giant area light overhead that's kind of filling everything, making it a little bit lighter on the top side than it is on the bottom side. It's a fade function. It's just up here in undo. Sometimes if I do a brush stroke a little bit strong, I'll just use the hotkey Control Shift F to pull it back just a little bit. So everything's soft, no hard cast shadows or anything. I just want the overall impression of this thing to work, so that when I'm painting all of the other stuff on top of it, I can just cut away the shadows and it'll still look good. And I think that silhouette still reads against that background, so I might just darken it a little bit. Now what I'm going to do is I will duplicate my layer, and I guess I'll just leave it as is for now, because I don't need to do a whole lot more with it at the moment anyway. I'll get a brush with a little bit more of a hard edge. And now what I'm going to do is I'm just going to map out where my terminator is. And by the way, I'm working with the same assumption about the lighting as we had on your other. So I'm imagining a light that's coming from the upper left. I'm imagining that there's the ambient lighting in the scene, that even in the shadows it's not really black, and on the upper side of things it's a little bit lighter. That's why I did that under lighting layer. Now what I'm going to do is I'm going to map out where the terminators are. So each one of these shapes is going to have a different terminator. I might actually just do this sphere as a larger shape. Imagine that the terminator works about right there. And I'm just painting flat colors just like I would if I was cell shading. And I'm going to use darker colors to erase away stuff, because what I'm going to do is I'm going to switch this to a lighten layer. And a lighten layer, what it does is it only paints in colors that are brighter than what's on the layer beneath. So again, just thinking cell shading. And if you feel more comfortable dealing with each part of the shapes on separate layers, that's fine. Do it the way that you're most comfortable with. And I might actually do the bottom layer on a separate layer right here. And I'm not going to worry about if I got that value correct right now, because it's probably going to end up darker in the end. Oops. Started to break my rule a little bit that I just gave you. Just hard edges. Actually, it's probably okay in this case if I erase away the layer underneath. It's probably going to be a lot faster. Going to combine those layers together. Switch to a lighten layer. Alright. Now, I'm going to turn the preserve transparency off, and I'm just going to erase away the edges. Take my eraser. And I might, in this case, I might actually, oops. I might actually carry this lit part just a little bit higher, just so that I can get a nice transition there. And then if the overall trend of it needs to get darker, I'll just use a nice big brush to wash over it and pull back just a little bit. This is a fairly easy way to work out this type of stuff. Especially this eraser in Painter, it's kind of got a nice rounded shape to it, kind of like the that 2B pencil that I told you about. So if you need to cut off a harder edge, you can. But if you paint very softly using big, broad general strokes, then you can get a pretty soft edge with it. And I'd keep doing that. Then once I'd worked out stuff like those parts, I would also work in the cast shadows. And because I've already worked out my underlighting, the cast shadows should actually work pretty well. If you're wondering how it is that I'm thinking out those cast shadows, essentially what I do is I paint in my mind some kind of, if I've got my light coming in from this direction, then I work out these parallel lines corresponding to each part of this object. And then in fact, it's not going to hurt if you want to just do this literally, just literally paint in on a separate layer some of those lines. And then when you're working out your shadows, you just kind of follow those lines. If assuming that, which I think I got these at slightly the wrong angle, but the point should still work, that you can actually follow those lines to decide where your where everything's going to end up. So if I want to have that shape casting a shadow that goes outside of the sphere, then I know now that that's the point it's going to work. This is only going to work with a direct light source, but it works pretty well. You can actually do the same type of thing with a nearby light source. You just draw the lines radiating out from that source instead of parallel to each other. So once I've got that worked out, and I'll just go to another version that I've got here where I've done the same thing. In this version, I hadn't worked out the underlighting, and you can tell it actually goes a lot faster. You know, things work out much better when you've got that underlighting worked out. But that's fine. Oops, went forward in time too far. So in this version, the next thing that I would do is I would work out the occlusion. So when I'm doing something like this, trying to get a fairly realistic or close to realistic lighting, I will think in the same type of terms that I would if I was a 3D rendering program. Most of the time those rendering programs, they deal with each thing separately. They'll either do it in render passes or they're separate calculations, and you can do the same thing. Switch that to a multiply layer and turn it up just a little bit, or turn it down a little bit. So what I'm going to do is I'm going to start first with a new layer. I'm going to take my brush and I'm going to paint in black wherever I want the occlusion to be. And in this case, I'm just worrying about one of the two edges. Obviously, you're going to have occlusion on both of those edges, but for now I'm just going to worry about the one. Same type of thing here. And you want this black that you're painting in on this separate layer to match about the radius of fall off that you want on your occlusion. So if I do it under here, I may want a larger radius of fall off because this shape is so big that the ambient light is going to be casting a larger occlusion shadow. Like I said, don't worry about getting things perfect with this stuff because that's going to take all the joy out of painting for you. Just do the best you can and let the critiques worry about whether you're getting it perfect. That's what critiques are for. They're to help you see stuff that you don't see yourself. And it's good to scrutinize it, but not so far to the point where you're pulling your hair out or anything. So what I'm doing now that I've painted in that occlusion is I've switched back to my eraser and I'm just erasing away that black until it's the occlusion now. And I described before how it's light being lost as it bounces into those cracks, and because of that it's going to be darkest in the places where things are contacting each other or very close to contacting each other. But the fall off is going to be pretty rapid. Fall off meaning that it's going to, in this case, it's going to become light fairly quickly. That doesn't mean, when I say that it gets light very quickly, that doesn't mean that it's going to necessarily be close to the edge. We'll have a lot of area of the fall off, but it's going to get, I guess if I were to draw it as a graph from this being dark and this being light, doesn't move in a straight line. It's going to get dark fairly quickly towards the contact point, and then it's going to get light very quickly and roll out from there. So that little I thought that was an artifact, but it was. There it is. So hopefully that makes better sense as a graph. So I'll just kind of erase away gently so that I'm not, because I don't want to clear away all that stuff. I want a little bit of that darkening in general. And I'll use large brushes, again thinking big to small. On a crease like this, I don't want it to get nearly as dark as I would in a crack like that. So I'm going to let it get a lot lighter. And sometimes it's easy to overstate your occlusion and just take it too far. So if you've gone too far, just turn the layer down. That's the beauty about doing it with layers. And if you do occlusion right, you should be able to render your entire scene just using occlusion. Because occlusion is very good. In fact, lots of modelers will use just an occlusion render to show the way that they've modeled their characters with 3D. So, oh, it looks like in this version, I don't know why in the version that I started with I didn't have this, but I must have deleted it. But you can see that's the lighting that I'm starting with. In this case, it's a little bit lower angle than the one that I gave you. Okay, so once I've painted in all of the occlusion, and spend a little bit more time with it. It should look something like this. And what you can see I started to do here, which I hadn't done yet here, is start to worry about the bounce light. So in addition to the occlusion, you should start thinking about, you've got a single light source, you've got your ambient light source, but you've also got each surface now that's lit up becomes a light source in itself. And again, I'd recommend doing this on a layer till you get a better feel for it. You can actually take, when you're working in grayscale, which this assignment should just be grayscale, you can actually just take the full brightness of the color and kind of work out how you think the lighting would roll off or fade out as it goes away from that edge. And don't worry about if it's, accurate in brightness. You can even treat it like it's a mirror reflection as far as this initial layer goes. And then you just turn it down until it looks more accurate to, the type of matte reflection that you'd get. And of course, since it's on a layer, you can erase it till in the end what you should have. And in this case, I'm going to create a second layer because the stuff, it's just like the nearby light sources that I talked about. The brightest point is going to be the point that's closest to the light, just because this is angled away from the light. So this is a new layer, and I'm just going to pull it back a little bit. And you can see I'm not going right up against that edge. You probably could in this case, but in a lot of cases it's better just to leave a little bit of space there, just because the light right in the corner is going to have a harder time bouncing exactly into the corner anyway. So you can see that's starting to look pretty good. You'll want to pay attention to all sorts of areas like that. The light here is going to be bouncing back up under there. The light here is going to be bouncing up under the ball. And it's going to be brighter on this side of the ball than it is on this side of the ball because the light is farther away. Here you've got shadow and there's not as much light bouncing back up. You also get light bouncing back up there, and of course up there. So then, after I've worked out the bounce light, and just for the sake of moving quickly, I'm not going to do it for the whole thing. And you can see also I did a different method when I painted this. I didn't worry about the edges. And if you want to do it that way, that's really not a bad way to go. You can actually just erase away the edges after you've kind of scribbled in your big shapes. And that sometimes makes things go faster as well. Sometimes helps to start loose and then tighten up as you go on. Helps you see the big shapes a little bit better. But that's going to be a preference thing, just up to you. Okay, now let's talk a little bit about texture. We discussed texture and how it relates to form, but how do you paint it in? Oops, I meant to be doing that on a layer. Let's do it. And I'm just going to draw in something that just, I don't know, should have a little bit of interest, but not be too complex necessarily. So that will be basically my line art for the texture, and you can do whatever you want for the texture, and I'll show you a couple different methods for applying it here. So I can start working out highlights for the texture. Oops, should really do that on a new layer so that I can control it a little bit more. So in this case the highlights will be a lot smaller, and I want to think in terms of what is the shape of this texture, where is it going to be poking out the most, where is it going to be receding into the model, and so forth. Might actually want to do that one just a little bit differently. Okay, so again, I can be a little bit rough with this at the start because I can always throw on additional layers to work out the other stuff. Like in this case, I'm going to put on a separate layer, the cast and occlusion shadows. Like that. And that's more of a cast shadow. Let's put a new layer in and throw in the occlusion shadows. And I can do the occlusion the exact same way here if I want. You know, I can actually define all the shapes separately with separate layers and then erase away from them, create a new layer for the next layer or section of the texture. So I'm painting it all in black just for this section for now, and then I'm just going to erase away. And because it's occlusion, it's going to be everywhere a little bit, but it's going to be stronger on the shadow sides of things because there's less light to bounce around, and a little bit weaker on the highlight side. So I'm just going to pull it back just slightly on the sides where there's more light bouncing around, using that fade function again. So that's pretty good. And I just continue to do that for the whole texture. And that's usually a good way to start a texture, even if you're going to use other methods like overlays. It's a good, I guess, first couple things to just kind of like design the broad strokes of the texture. And then you can keep doing the same thing at smaller and smaller levels. And you can use those same methods, just working in finer and finer detail until your texture looks really good from any distance. In this case, of course, I was a little bit messier than maybe you would want to be, but if you're careful about it, you can do quite a bit with the texture. You can add in a lot of grit and grain, and have cracks and other things. This is something you can really use your creativity on. Scrapes and whatever else. But that can sometimes be really tedious. It's fun to do texturing, especially for people who love to do textures, but there are other ways to do it, which are a lot faster and can actually produce some interesting results as well. So let's just go to a photo that we took while we were in Arches National Park. I'm just going to select this rock face here. And there are other ways to do, where am I looking for? I think it's that one. Nope, it's not that one. It's that one. Which actually, I could go to this one so that you can see even better how it mixes together. So I'm just going to copy that in. I'm going to scale it down to, say, 50%. And in this case, since I'm just doing black and white, I'm going to take all the color out of it. And I'm going to switch the layer type to something called an overlay. You can actually do this with like a multiply layer if you use equalize or brightness and contrast to bring the whites way up. This method works pretty well for that. But you can also do an overlay layer. This is a good way to do things because what happens is it makes anything darker than gray darker and anything lighter than gray lighter on the image, on the layer. So let's just kind of put this in here. And in this case, we've got some kind of lines that aren't really working with the shape of the sphere. And so Photoshop has some great distortion tools. I'm not going to show those off necessarily. I'm going to use Painter's second-rate distortion tools. but they're good enough in this case, and I can just add a little bit of distortion to that texture. It's not going to be as good for moving things around, but it's okay for this. And obviously this is too dark. I don't want it to be darkening everything that I'm doing that much. And I told you earlier that you could paint with using the brightest part of the spectrum going all the way up to white. I'm going to take that back just a little bit. Don't go quite all the way to white, because if you are going, well, don't go all the way to white if you're going to use an overlay layer, because you want to have a little bit of extra room to push things around. In this case, I think I'm just a little bit bright overall. But that's close enough. And you can see it adds some texture to what I've done already, but it obviously doesn't fit in yet. And basically what I'm doing here is I'm going to use this as a template for what I'm trying to do. And I can probably just grab any side of this. And this is going to work a lot better if the lighting in the texture that you're throwing on matches the surface that you've got. But even if it doesn't, it's not bad as a kind of design template for your texture. It will save you a little bit of, I just created that. It'll save you just a little bit of work in the design department, and it'll allow you to avoid having to paint every single part of the rock. All you have to do now is just catch the areas that are most interesting, the areas that create the best textural result. And you can push it a little bit farther in some places if you want it to be really pitted. And this is the type of thing that you'll want to use your design sense for. If you've had any design classes, think big, medium, small. Think large to small. Think how the larger texture works first before the smaller texture. And the same tricks we learned about with occlusion and everything still apply. You can get deeper pits in some places. And this actually makes it a lot of fun to work out a texture when you do stuff this way. And this same method can be used in conjunction with the other method. Like if I wanted to go to this other one and do an overlay layer, you can see it adds the colors in there, so I'm going to turn that off, or turn the colors off. And so I could actually weave those two textures together if I wanted to. In this case, I think what I've already done is already strong enough that this is just kind of adding some additional grain and interest to the texture. If I go back to this one, and you want to be careful about how that texture is responding to the forms overall. Like up here, it's okay to have, bright highlights and things like that, but you probably don't want deep dark shadows. You might have occasional places where your pits go a little bit dark, but you want to, for the most part, keep your shadows a lot lighter. And same type of thing in the shadows. You don't want to be catching light clear down here. Maybe somewhere along the terminus you'll have occasional things that poke out far enough that they'll catch more light, but not very far past the terminus. Once you get past a certain point, you just want things to fall off into shadow again. And you can really just design this any way that you want for this assignment. If you want to make it, as long as the texture reads like a form, it fits with the form, and it reads like a real texture, not just a design on the surface, then I think whatever you want to do is fine. Although it would be good to look at reference for the type of texture that you're doing. If you want something that feels like rhinoceros skin, then you want to look up rhinoceros skin. Even if you're not using the overlay layer, you want to get it to feel right. So you can see how this would work pretty well with just a little bit more love and effort after a while. Sometimes though, when you're doing this type of thing, you're going to lose a little bit of that overall, the larger form, the big forms, and like maybe there's so many bumps going on here that we're losing the roundness of the sphere. And if that happens, you can just throw on a new layer and just make the layer type an overlay layer, and you can push the spherical nature of the ball just a little bit farther by painting a little bit of white in there. I'm going to throw it on top and then just turn that down just a little bit, and even that subtle change helps make that ball feel a little bit more round again. And here is when I was painting before, kind of the final result I came up with. And obviously this texture could use a little bit more work. If there's areas where you painted too soft originally, you can actually select those, stick them up on a layer, and use Painter's texture tools, this apply surface texture. Switch it to image luminance, and you can have something that is responding a little bit more closely to a little bit more closely to the pixel to pixel stuff that's going on. Of course, now that I did that, all my other stuff doesn't look detailed enough. And then at this stage, really you're just into polish and all the little things that really make the painting work. Like in this cast shadow, in this version I didn't work out my underlighting before, so I don't really have the type of overhead lighting coming in and influencing the shadows the way that it ought to. And you can see even just putting that little bit in makes that form feel a little bit better, feel a little bit more like it's living in the same world. And then of course I can change the shape of it if I want to really make this texture work. And same type of thing, if I want this texture to really work, I'm going to just mess a little bit with the silhouette, because the silhouette is just as important as the texture. And that'll end up in the end making us feel like we have a textured part of the sculpture and all the other parts as well. So that should be enough information for you to do your assignments, and I look forward to seeing what you turn out. Thank you. Welcome to Lesson 2. Today we're going to talk a little bit about light and surface color. Specifically, we've got light color, and we've also got surface color. And when the two of these things interact and meet our eye, which goes through a signal up into our brains, swirly brains. And our brains interpret the relationship that happens between those two things. And so we're going to talk actually about all three of those things a little bit today. So first off, we have wavelength. Wavelength is kind of a complicated thing, or I guess it's not necessarily complicated, but it's complicated to explain because it's just a special property. The photons, we talked about the particle attributes of light before and how they will bounce much like a billiard ball. Well, there's another attribute, which is the wavelength. The wavelength is kind of an energy or a quantum property to the photon of light, and there are different wavelengths for light, which is where we get the rainbow from. Each color in the rainbow is a different wavelength. So the wavelength, if you were to draw it in a graph, the wavelength would actually be a measurement. And they do in science, they measure it in nanometers or something like that, the different distance between the peaks in a wavelength. So you don't necessarily have to understand it, but you have to understand that there are different wavelengths, and that affects the attributes and properties of how light behaves. So if we have a photon, this is similar to the example that we had in the last lesson, except now it's a green photon. And it's hitting an object that isn't green. Let's say this is a black or a red object. Then what's going to happen is, when the light hits that atom or molecule that is green or that isn't green, it's going to cause that molecule to vibrate. And this is because when there's an absorption resonance frequency for each atom and for each molecule, that when a certain wavelength hits it, it just makes it kind of wiggle around. And essentially what's happening is that this wavelength, that energy to light, gets absorbed by the molecule and re-emitted as heat. And so we actually lose the light in that circumstance. We lose the energy of the light, and we lose the visible property of light. If, on the other hand, we have an atom that is green, or a molecule that's green, then what's really happening is all of the, let's say we've also got red shining in here and purple shining in here or whatever else. What's happening is the red and the purple are being absorbed and spit back out again as heat, just like we were talking about. But the green is actually repelled or reflected away, and that's what meets our eye in the end. And that's why we see green on an object. Another definition is local color and apparent color. So local color is what the true color of, we'll say, true color of a surface is. Now, I put true color because that's going to be very different depending on the light. And so if you have a sort of whitish light, then we'll get something that's more true to what we expect a skin color to be. Whereas if we have a reddish light or an orangish light, it's actually going to change the skin to be something that is more orange as opposed to the usual or original peach color. So this is important because we understand, our eyes, when we look at something, we understand naturally what the true color of something is. We can see somebody's blue shirt in this lighting, and we can see a blue shirt. In fact, there's a blue shirt right there. We can see it in this lighting, and we understand innately that it's blue in both cases. Same type of thing. We know that this skin tone is, even though it's actually orange, we know that it's supposed to be a skin tone. Same thing here. We see the orange of the thumb and the blue of the thumb, and yet our brains naturally interpret this as a continuous surface with a single color. It's just one of the things that our brains are very good at. So this is an important thing to remember when you're painting light. So keep in mind that our experience with light and color, it's not purely scientific. Our brains and our own interpretation of the world as we're seeing it is part of the process. And so there isn't really a right or a true way to interpret these things. But these are all good rules, and understanding what's going on physically and what's going on in our brains is a very handy thing in knowing how to interpret it. But you can interpret it a number of ways and still be true to people's experience. I'll probably use that phrase several times through this training. One other thing, just want to say, actually don't need to be up there, as I'm going through this training, you want to watch every time that you see the icon go to the color picker, you want your eyes to be kind of bouncing back and forth between the area that I'm picking the color from and the actual color wheel here, because it'll help you understand what's going on. Oh yeah, I remember why I was going back up here. I talked a little bit about the color of the molecules or the atoms. The most atoms or molecules or surfaces, materials, they aren't a pure color. So we've got a few that are, you know, maybe this purely saturated things, and those are going to behave in a very specific way. But most surfaces, you know, they're not emitting just a green wavelength or just a blue wavelength. We're getting surfaces that usually they've got a tiny bit of blue in there, and they've got quite a bit of green in there. Whoa, that's not green. They've got quite a bit of green in there, and they might even have like a tiny bit of red in there too. So everything might have just a little bit of the other colors in it, but it's got one dominant color. There are cases where you'll have a pure color, but just remember that in most cases we don't have completely pure colors. So just as a general rule to remember. Let's go to this one. So we've talked a little bit about this already. We have the order of the rainbow. You might all be familiar with that. If not, you may want to become familiar with it. Going from purple, blue, through green, to yellows, to the oranges, to the reds. So white light is made out of all of the colors of the rainbow. In fact, what happens with the rainbow is that the prism, or raindrops, actually split the light into its constituent parts. All of the different wavelengths that make it up become spread out. So, but when they're all together, we see it as white light. So as we've talked about before, as the white light is coming out from this object and it strikes this object, most of the wavelengths in that white light are absorbed and emitted as heat again. But some of them, the blues in particular, but even a little bit of the others, that's why I included them here as little things, they are not re-emitted but reflected out of that surface. And so we end up seeing the, I guess, apparent color of that surface. And it is dependent on the light. If it's pure white light, then what we're going to see is the local color of the object. But most light isn't pure white, and so we're going to be seeing a little bit of what the apparent color is. So I already talked about that. Okay, so I talked about this a little bit already, but essentially without any light, there isn't a color to the surface. Yes, 2 question marks because it's extra confusing. The light, or the surface properties that make us see that thing as red, it's all kind of built into the, I don't know, the DNA, I guess, if I can use that term, of the molecules or things that make up the surface. And so what color that surface actually is going to depend very strongly on the light. These two things are linked together. This does not exist without that, if that makes sense. I can't emphasize that enough because it's going to affect a lot of things later. So there's an example of a surface that is red, but it's red under a white light. As soon as we change the color of the light to something, let's say yellow, we actually lose a little bit of that red characteristic. And there's 2 things that happen, and you want to remember this. Maybe take a note if you need to. You see, under this white light, it's red, or, you know, mostly red. Under this light, we actually lose, watch what happens as I bounce back and forth between these. We're rolling a little bit towards the yellow between the two. And note, this surface, which was white before, is now pure yellow. The red is just trending towards the yellow. The value, see how we're losing value? We get full value on the red here, but as soon as we go to a different color light, we lose value. And you usually will lose or it will change a little bit of the saturation as well. Most of the time what you're going to do, what's going to happen, if the color of the light is fairly close on the spectrum to the color of the object, to the local color of the object, because you can see you have yellow here and red here, they're fairly close to each other. And because of that, we're not going to lose a whole lot of value, we're not going to lose a whole lot of saturation. In fact, in this case, we actually gained in saturation. I'm not sure if that is 100% accurate in this case. If you are ever really curious about this, you can just create a simple test in your garage or a bathroom or a dark place in your house using an LED or colored light through filters, if you're ever really baffled about what's going to happen with light. But there are some general rules that should handle most situations. Essentially what it is the further away on the spectrum it is, the less like the original color it looks, the more you're going to lose. And so with the red light, or the red object under the green light, you can see there's very little, if any, the white light, just like I was talking about with the molecules, they've got a little bit of the other colors in them. Most lights, it's the same thing. This light is actually emitting a little bit of orange, and it's emitting a little bit of red, even though, and it maybe even is emitting like a tiny bit of green and a tiny bit of blue. But the yellow is the strongest and most prominent thing under most lighting circumstances. There are exceptions, but usually you're not going to have to paint those exceptions. So with the green light, there's hardly any, if any, red light in here. And so there's just nothing for this surface to do with it. So what you're going to end up with here is a loss in saturation, and it's going to roll heavily towards the green. In fact, you may actually lose all the characteristics of it. If this was a pure green light and this was a pure red object, then this would be pure black. We would not get any light at all from that light. But again, like I said, that's kind of a rare circumstance. So just remember, you're going to be dropping down heavily in value. You're going to be rolling towards the color that you're changing to, and you will, in most cases, be losing a little bit of saturation as well, depending on the saturation of light. This is a very saturated light, and it's close to the color, so we may actually gain saturation. Whereas this light, even though it's saturated, is very different from the color of the object. So there are multiple ways that our eyes will see green on an object. One of them is put a white light in a scene that has a green object in it, or a glowing tree. Or put a white object under a green light. Or what you can do is you can put a yellow-green object, maybe something like this. That's what the original object was. And you get kind of a blue-green light, and you'll get something kind of similar to that. And this case where we're using the yellow-green object, which is probably going to be a lot brighter, with the blue-green light turning green, that's a result of what we were talking about earlier, where even though the object is yellow, it's going to trend towards the color, and it's going to lose a little bit of value, and so that's why we get kind of a green color. It is possible, I chose colors that were kind of close to each other. It is possible actually to do the same thing with colors that are farther away, like say if we had a slightly orangish, yellowish object, and we shined maybe a pure blue light on it. But in this case, we may actually get a green again, but probably what we're going to get is a much darker green, because of the distance, like I was talking about before, of the colors from each other on the spectrum. You can also get green by mixing colors. So similar to what we were talking about here, if you had a white sphere and you took, say, a red light and a green light, then what you would get in the place where those colors intersected is a yellow object. However, it's going to be very hard to get a green object, and this is because of to get a green object using that kind of light mixing, and this is because of the primary colors of light. And most people are probably familiar with the primary colors of light versus the primary colors of pigment. So red, green, blue, primary colors. Any of the colors in between those, you can kind of see how in this color spectrum, and part of this is because of the way that monitors mix color, but you can see how it gets brighter between. So green is darker, cyan is brighter, blue is darker, the magenta is lighter, red is darker. And that's because the yellow is a result of those two lights mixing. You're adding the light to each other. So as a result, it's going to be hard to add these two colors to get that one. It's possible to get kind of somewhere in that range, but it just becomes very difficult. I mean, you can see how this light's kind of a yellowish green, this one's kind of a blue, and what we're getting in between is kind of a grayish blue-green. It's kind of rolling into the greens there, but we're losing so much saturation there that it almost doesn't look right anymore. And that's important to remember if you're going to be painting a scene where you have a yellow light shining on, say, a blue object. What's going to happen to, or what's going to happen to the light in between? You're not just going to get an exact mixture between those two in the greens. You're going to get a much desaturated, even though the hue may roll into the greens, you're going to lose saturation because of that. Okay, so there's a variety of methods to use when you're trying to get lights to mix in this way. One way that I am a big fan of, if I can find my brush, is just using the canvas as a palette. So if I have, let's say, well, let's do the skin here, and I want to do blue light on the skin, then what I'm going to do, that's not the pencil I thought it was, is I'll do some blue. Let's do a little bit stronger blue light. So I'll just kind of color it on, but just a little bit softer, and then I'm going to pick that color again, just the same as if I was mixing those colors on a palette, but then I'm going to bring that color down in value, just like I said. And usually what happens when you mix this way is you're going to lose a little bit of saturation, so I'll usually just pull the saturation out in most cases. And so that's probably pretty close to the color we're going to get under this light, excusing of course the specular highlights, which are going to be closer to the actual light color, but we'll talk about that more in the next lesson, and I won't waste any more time painting it. So visual mixing is a good way to get this type of thing, just mixing on canvas. It takes a little bit of experience, but if you do it enough, you'll get the hang of it, and it generally works pretty well. If I mix a green and a purple, then what I get in between is going to roll across the spectrum, but you can see how it drops down in saturation there, which in this case, because they're on the opposite side of the spectrum, is actually kind of a good thing. That's what's going to happen if you mix those two lights together, and you're going to get it a lot darker, of course. But if the colors are a lot closer to each other, like if I'm mixing a yellow with, say, a kind of yellowish bluish green light, or a bluish green light, then we'll actually lose saturation in between the colors there, and that's less desirable. So I'll actually just punch that saturation up again so that we have a nice mixture between those two. It looks more natural now. Always, of course, depending on what the situation is, how you're going to be using that color So there are cases where, like I said, with the blue or the purple, it's good to lose a little saturation when the colors are on opposite sides of the spectrum. Another way to do it is using layers. So a multiplier, a gel layer, is really useful because what they do is, you can see here, we have these sort of blue-greens which are pretty far in the spectrum from the reds. If I put a gel or multiply layer over this image, it keeps all of these colors pretty well. The, you know, reds in the skin, the reds here, the whites are showing up nicely, and then all that stuff in the background goes into black. So the one thing that this doesn't do is the gel layers don't deal well with saturation. So, and they're not going to deal well with if you've got a bounce light on the other side or whatever. But if you just need to figure out what the color is, it's not a bad way to go. So you can see the same type of thing again. The reds drop out because they're kind of on the opposite side of the spectrum of the green, and we lose a little bit of value in the skin tones. Same type of thing in the blues. So we lose a lot here and in the skin, but not so much in the areas where there's blue or green, and that exists in the beard as well. So these cases are the extremes, you know, where you're using a very saturated color. Most cases it's going to be a lot softer than that, and in those cases it's actually going to be a lot more accurate using a gel layer. So you can see how effective that is in kind of tinting everything towards the color of light that I want. So remember what I talked about on this page with our ability to interpret these colors. So when we're looking at these colors, our eyes know immediately what to do. In the same way, when you're painting a scene and trying to get the light color and the surface colors to work well together, your brain needs to kind of reverse engineer what's going on here. You need to think in terms of, okay, if I've got, let's say I've got a scene that's got an orange object and a green object and a blue object, what happens if I put a red light over that? And some of that can be solved. There we go. Some of that can be solved with the multiplier gel layers. You know, we can see, alright, so it's the blue goes a little bit towards the purple because my light wasn't too saturated. It doesn't drop out completely, but it is quite a bit darker than these other two. The green actually loses a lot more value because it's a lot harder for the red and the green to reconcile each other. I think in a lot of cases you can just think in terms of what the complementary colors are, because the complementary colors will not respond well to each other. If you have a light that is green, it's not going to respond well to if you have a light that's green and an object that's red. But that's not the limit. You know, you'll see the same type of thing with a red and a blue object depending on how pure they are. So anyway, if I'm not using a gel layer or a multiply layer, I'm going to have to think it out. Okay, what happens if it goes to a red light? Well, it's going to trend towards the red, this orange. So, and I might be gaining saturation because of the saturation of the light. So that's probably pretty good. What about the green? What's going to happen? Probably going to trend towards the red again, and we're going to lose a ton of value. Maybe not quite that much. We'll probably end up somewhere in the yellow range, something like that. And the blue is going to trend towards the red, and we'll lose a lot of value again. Alright. Oh, also, it feels weird painting stuff in different colors than what you expect them to be, you know, to paint things to go there with a green when you've got kind of a reddish light, which is probably not even going far enough. You know, it's it's hard to kind of trust yourself and just go that far with it. But you have to remember, it's the same thing as we talked about with, our eyes are good at figuring those two things out. You just kind of have to trust that in the end you're going to get the right things. And if the colors that you're painting don't work, there's a number of ways to adjust those things in Photoshop or Painter after the fact. So I'd say don't worry too much about getting it perfect, but push to get it as far as you can. And just trust that in the end, our eyes and our brains are so good at figuring out what colors are relative to one another in the lighting scheme. And once you've got the whole scene together, everything will feel right. Let's move on now to exposure. We talked about exposure with how it affects value last time. We're going to talk a little bit about how it affects value, but also color this time. So our eyes and cameras as well have a very limited range that they can see. So let's say you've all probably seen a histogram before. If we were to graph out this scene in terms of brightness, this is white and not white and black, but this is the highest value that is even possible to see, and this is the darkest thing. This is absolutely no photons, and this is the maximum number of photons. That over the value range in our scene, with both our eyes and with cameras, we only can see a portion of this spectrum at a time. So with a camera, you can expose for that portion of the spectrum, or you can expose for that portion of the spectrum, but it's very difficult, and with a lot of cameras impossible, to expose for even a wide range in that. Our eyes have a wider range than the camera, but we still have a hard time catching it all. And this is just because of the trillions and, well, I don't even know the number of photons that are just streaming, bouncing off of objects and flying into our eyes with a bright light like the sun. There's just so much that it's difficult for our optic nerves, brains, whatever, to handle all that. So essentially what happens in a camera is anything above the threshold, anything outside of that range is going to flatten out in white, and anything under that range is going to flatten out as black. And our eyes do similar things, but because the one thing that it's different with our eyes is our eyes are moving around, and our brains are kind of compensating for what we're seeing. It's bouncing around from this wall to there and into the shadow and up to there, and of course our brains are kind of making these calculations like a complex computer would, and constantly adjusting to whatever the exposure level is in that area. Our irises are dilating and contracting to compensate for the amount of light that's coming in, and we put together a picture that is more complete than a single camera image would be. So when the light source and shadows have the same exposure, what this means, this is an unnatural thing that it's kind of become popular lately, HDR imaging. That's high dynamic range. So this entire spectrum, that's an HDR, high dynamic range. This smaller spectrum, or whatever those smaller ones that I drew for the camera, that's a low dynamic range. And so when people talk about high dynamic range imaging, they're trying to take data that's from a larger part of the spectrum and trying to squish it into the kind of lower dynamic range that a camera or a film can actually display. And a lot of the ways that they'll do that is they'll actually, brighten up the shadows and darken the sky or whatever so that everything kind of fits together. But this is very unnatural. I mean, we're looking at the sun here, and the sky should be much brighter than what we're seeing in the shadows here. It just looks wrong. This is one that I picked up off the internet. Hopefully none of you made this picture. If so, I don't apologize for making fun of it. but I just hope you're not too mad about it. So even if I just do this, just darken that down a little bit and lighten up the sky a little bit. And it doesn't have to be much, even just a little bit, and it starts to look normal, more normal again, where it's getting more true to our experience. So keep that in mind. General rule, when exposed for the sky, shadows become dark and underexposed. And that's, especially, this is an evening picture, and so the sky towards the horizon is much brighter than normal. And when we expose for the shadow areas, and this is on a camera of course, but you want to keep this in mind when you're painting your pictures. You don't want to be painting stuff in your shadow areas. You don't want to be drawing in trees that are just as bright as your sky. You need a distance there for things to look right. So here we see that the sky is blown out, but now we're starting to see the data in the shadow areas, whereas here it's basically just black noise. Another thing that you'll notice here, and this is the other thing we need to talk about, is what happens with the colors. You see that? Look at the color wheel there. Now look at the color wheel there. Same trees. So we've got a value difference, but we've also got a hue difference, and we've also got a saturation difference. In the overexposed image, we actually are pulling back a little bit in the saturation. We're losing a little bit of saturation. It's rolling towards the yellow. And so I use that term rolling because of the shape of the color wheel being a circle. Essentially what it means is that as we're changing in value, we're also changing saturation, but we're also rolling one direction or the other with our color. So let's just paint a quick little example here. If I were to draw, let's do a red sphere. Then commit that. Preserve transparency, and so here we got a ball. And I want the top of it to have a stronger exposure than the bottom. So what I need to do is go up in value and towards white in saturation. So when things expose, when things get overexposed, they trend up towards the white. That's the way to go. Not towards gray, but towards white. So they're going up in value and over at the same time. And then you'll get a little bit of movement in the color spectrum. Remember how I talked about before, this is darker, this is darker, this is darker, but the magenta, yellow, and cyan are lighter. So when the colors roll on the color wheel, they usually roll towards the closest neighbor there. So in this case, it's closer to the yellow, it's going to roll that direction. And if I really want it to look overexposed, then I'll actually blow it out all the way to white or somewhere really close to it. Now, if I didn't have this red edge in there, well, let's just show you what happens if you do a red sphere, but you just do like bright overexposure, it doesn't look like a red sphere anymore. So you need that saturated edge transition in there for the exposure to work. And you often need to get it in there pretty strong before it starts to look right. Because what's happening is, here, tons and tons of photons are hitting our eyes or hitting the camera sensor, and it just can't handle the data, so it blows out towards white. Whereas here, we're getting fewer and fewer photons, but the area is still lit, so we're getting a lot closer to what that local color is. And then, of course, on the shadow side, we're losing that information, and it's going to trend towards whatever the shadow color is, or, if we've got a light source back there, it's going to go that color. So even if you're painting an image, let's go back to our original red. Even if you're just painting a sphere that's in regular lighting, it often helps and adds a little bit of, I don't know, interest and realism to just add a little bit of extra exposure to it. Doesn't have to be a lot. But that little bit just really makes that surface look interesting and round. Now, there's a boomerang curve that happens with the painter wheel that you'll notice. You'll see it in photos. I don't know if it, none of these are rounded enough in the surfaces, but maybe you can see it in some of these places. Yeah, you can see it there. So watch right there as I roll across here. Oops. There we go. There's so many colors going on in the hair because of the lens artifacts, but see how even though we have jumps there because of the overexposure in the hue, we actually have a curve going on right here. At work, we call this the Fordian curve because one of my previous co-workers, Adam Ford, kind of came up with this idea that as light bends around a form in exposure, it actually follows a curve. It tends towards white, rolls to more saturated, and then back this way. So, and I've seen all sorts of curves. I've seen them like that. I've seen them curve all the way back towards where they're desaturated again, or of course just curve down to where it's a dark saturated color. All of those work, and all of those you will find examples of it working in real life. But the Fordian curve, it's kind of that boomerang shape. And usually what's happening is you actually get a slight roll off in the hue as well when that happens. So generally speaking, underexposed, you get more saturated colors, and you get things kind of rolling towards what they are. Just a quick note with this picture, in both of these you can see how yellowish orange. I mean, that's not even green anymore. These are green trees. I mean, even if they're this color, this kind of yellowish color, that's nothing like what they look like now, and it's because of the light color, and this is what we talked about before. So the original leaf color was probably some lighter green. Doubt it was probably a little bit darker than that, but as we got a reddish orange light on it, then we roll from that green towards the orange and then go down in value. And in this case it went down in saturation a little bit too. And so that's what we ended up with. So this is what I was just talking about before up here with this sphere, is that it's a very common occurrence that our light source is going to blow things out just a little bit. It doesn't always have to go towards white to be overexposed, just because the sun is very bright, and you know, if you walk outside on a hot day, you'll notice this type of thing happening where everything is very desaturated in the lit areas and doesn't get saturated till the shadow areas, just because of the amount of overexposure of the light there. So there's a bunch of different ways you can adjust for exposure in your painting. One is just kind of creating a little bit of distance. You know, I showed that HDR image up before. In this case, you can see our values are kind of roaming around in the middle of the spectrum down to there, but all of those are much brighter than the values that we have on the ship here. And so that works with the exposure, even though both of these are, nothing is actually overexposing in this scene. We get a feeling that seems true to experience. In this picture, we see the overexposure on that edge. We see the Fordian curve as it rolls off the surface. This, by the way, was a painting by a student that I painted over. I didn't do this one. And So we have that Fortean curve, and then you'll also notice how the sky is so much brighter. We've got the shadow areas in the rock, and then the sky. See that how high the value jumps up from about down there to up there, and then it rolls up towards white, goes right to white, right at that edge, and then watch what happens there. Actually imitating an overexposure effect that happens on our retinas, just making that sun, that very bright thing, go a little bit farther past the point. This is something that I noticed in Warcraft 2 many years ago, and Dave McClellan pointed it out as a thing to use in painting, when it just kind of imitates the way that our retinas kind of create a burn-in effect after we've looked at a very bright light source, and it goes to the complementary color of what the light source that we were looking at. So since the sun is kind of a bright, very yellowish thing, then the after image that we get is kind of a bluish one. So, and in this case, this is kind of similar to that other one, except I actually flattened out the highlight areas so you can see how close they all are in value, and then you can see how close the shadow areas all are in value, and that just kind of makes this feel like a highly exposed sunlit area, and this feel like a shadow area. It just keeps them nice and distant from each other, but they're able to have all of the detail. You don't actually have to blow things out to white to make things feel overexposed. I'd also like to point out that in the evening sun, these trees, which are green, or probably their true color is probably more in this range, the colors of the leaves maybe a little bit darker than that. Look how much yellower they are in comparison to it. And this is what we were talking about before, the combination of the light color and the color of the local color to create that apparent color of sort of this greenish yellow, which actually, when I look at it, it's quite orange. I think the light that's hitting it is even oranger, and so we're getting a little bit of a trend towards that. Okay, so this is what I talked about earlier, that even with the light source out of view, cameras still have a hard time with bright light. And that's true for our eyes also. We just have, you can see how the bright side of this rock, there's just everything. Look at the color wheel bounce around as I do this. It's bouncing all over in the highlights, but see how desaturated it is? The local color of this rock is probably about there. It's pretty, it's pretty saturated. It's pretty red rock, but in fact it might even be there. But because of the light color, it's really desaturating the whole thing. Again, we're not losing all of that information, but everything is trending towards white, as I talked about before. And this happens with things that we see. If you go outside in full sunlight at noon, you'll see similar things like this. Just everything kind of loses a little bit of saturation because of that light. There are other things going on with specularity and reflection also that causes that, or causes even more of that effect to happen in certain cases, but we'll talk about that in the next lesson. So these are various images that I painted or helped paint. This one was actually painted by an artist, and I was giving a critique and paint over. So there's basically multiple ways to deal with exposure issues. In this case, we have a scene that's exposed for the rocks here, and I brought up the values here, so this is maybe like more similar to what you'd see in the HDR image, but I made sure that there's enough distance between the light and the shadow areas so that it still felt true to life. Then it didn't feel right that we should be able to see the sun in this scene and not have any kind of exposure issues. So I made the sky very bright. See how close to white it is? And as things trend towards the sun, gets all the way up to white right there. And then as we move across onto the disk of the sun, watch what happens to the color. See how it went down again? Now what's happening here, it's kind of a tricky way of dealing with things. This was taught to me by Dave McClellan. Actually, I noticed it before, but he taught me to use it in painting. I noticed it as something that was used by the in Warcraft 2 to make their fires look very hot. Essentially, what they're doing is they're imitating the effect of, I guess, like burn-in on our retinas, not like screen burn, but when we get an after image. When you look at the sun, there's an after image of green, and so sometimes you get this flickery green effect in your eyes. So similar type of thing here. We have a white disk around the edge of the sun, so it gets very, very bright, and then by dipping down a little bit and heading to the opposite color in the spectrum, which is going to be kind of a blue-green, we get something that looks like it's been overexposed. And I can actually push this a bit further, and it still kind of works. It's starting to push maybe a little bit too far, but even if I go halfway on that, you know, if you take a step back and look at that sun reads as being very bright. Well, I think I still took it too far, but that sun reads as being very bright, being even brighter than white because of that. Or hopefully it does to you. It does to me, especially when it's like that. So another example, this is just one of those cases where there's just not enough light at night to create this kind of exposure. Everything is dropped into shadow, but we wanted to see the details on the ship, and so I just put a little bit more light into there, even though against the sky it would be a lot darker. Again though, I'm being careful to preserve at least some distance between the stuff that should take a higher exposure and the stuff that takes a lower exposure. And again, this is that same idea, but what's different maybe in this case than from the others is in this case there's a wide range of color and value, if you look at the color wheel again, across this sky in the background. Whereas in this one, I wanted to create an effect that was giving the sense of things being blown out a little bit by the light, something similar to an overexposure effect, but I didn't actually want to lose the detail. So I painted all the details in, but I just put all those colors very close to each other. See how as the thing bounces around in the color wheel, it stays in a pretty narrow range of value, even though the colors and hue is changing. Then the same thing happens in the shadows. Values stay pretty low here. So that's another technique. In fact, I could have even pushed this idea further if I really wanted the stuff to look overexposed. I'd darken this whole area in the shadows a bit. I'm coloring it all black for now, but I'm going to actually pull this back just a little bit. So we're still getting all the detail in the shadow area, but there's a big difference now between those two things, so that it feels like this is very overexposed and this is underexposed, even though we're not losing detail. So there's other ways to handle exposure, but it's something that you need to keep in mind as you're working on your images. And remember that when you underexpose things should tend to be a little bit more saturated, and when you overexpose them, they should be they should trend towards the white on the color wheel. Now let's look at I'm going to talk about lighting schemes. So I guess I should talk a little bit about what we had last time real quick. So let's look at this image that we are all familiar with. So I talked about placing a single light in the scene, a single key light, and I didn't talk about rim lights on this page and the benefits of those, but we'll talk a little bit about that today. So we talked about simple lighting schemes, throwing in a fill light, maybe a key light, maybe a maybe a rim light. But more complex lighting schemes, they're not that much more complex, especially when you build up towards them. So if you start off with just a simple lighting scheme like this, you've got a fill light, you've got a key light, and maybe you've got a rim light. You know, that's the 3 light scheme that seems pretty common, at least for beginners. Then that's actually a pretty good basis. Now if I wanted to do a more complex lighting scheme, like for example, if I wanted to have, we'll go back to this one. If I wanted to have a rim light as well, I just kind of layer that additional light on top of the other stuff that I've already done. And I'm not going to paint this all terribly carefully, but you can see that when I can almost kind of create a lighting studio in my mind. Just say, what if I threw a light behind him? And what if I put in a different fill light and I filled in this area? Now the nice thing is that last time we were just talking about value, now we've got color. So let's say that this light source up here, let's say that we did this color originally as, or this light as being blue. So the fill light is blue. It can even be a very faint blue to colorize instead. So now if I want to, I can actually have, maybe let's say the ground is a light source now. So we talked a little bit about bounce light last time. I can actually use a light that's almost the same value as my original light, but because I'm using a different color, I can separate it on the lighting scheme. So just like I talked about last time, where you want to kind of create like light dominance, one light being more important than the other, you can do that with color as well. That's an additional tool in your toolbox. Probably won't take this too much farther, but so all of these different basic lighting directions that I've talked about, when you're creating a more complex lighting scheme, you want to consider how each light fits to one of these different ideas. So for example, you can have a character that is rim lit. Maybe they're standing in the doorway. So that we get that kind of sense of drama, and there's always appeal to a rim light. Just kind of, it's just really appealing. In fact, I seem to remember somebody telling a story about how Pixar they made it a rule in one of their films, I don't know if it was in Incredibles or what, to put a rim light in every single scene because it just added appeal and interest to the characters for it. And rim lights, of course, don't always have to be this strong. You can do a very a dimmer, less prominent rim light. But so then, if I wanted to make this character dramatic in a evil or scary way, rather than just being, you know, kind of a nice standing in the sunset thing, then I can pick a color. We could even do a green. Well, frogs are green, so we'll go back to the reds or yellows. So it might be kind of unnatural. And I'm going to put an underlighting on that character. And the combined effect of both of those lights and how they relate to the character give our character a new dimension. It adds complexity to our scene, and all that we've done is change the lighting. Works especially with the underlighting. If I put heavy shadows in, it starts to look really unnatural to, well, unnatural in a good way, not unnatural in the way that I've talked about before. I'm not going to worry about how all this is lit, but so we end up with a dramatic and kind of, I guess, evil or scarier looking frog than we would have if we just had the more neutral light with the rim like we had before. So what you want to think about when you're doing lighting schemes is you want to start simple and then build up, use your colors to add interest, and then what we're going to do, talk a little bit more about, is how you're going to use bounce light to create a more interesting lighting scheme. So we'll talk about that towards the end as we're painting a little bit more. Let's go back to this scheme scene here. So the reason why you want to do fairly simple lighting schemes is because it's natural to us. We're used to seeing things in nature, and nature uses fairly simple lighting schemes, at least on the surface. And we'll talk a little bit about global illumination next time. But usually you've just got a few things. The sky acts as a fill light, and the sun acts as a directional light, like we talked about, and occasionally as a rim light. And those two things, basically, it's just two lights that are working together. Occasionally you have other things like a cloud that is bouncing light back onto you, and that's more like the more complex lighting schemes that we talked about earlier. You would throw in something like that as a fill light on the backside of your character, or you know, in the shadow area of your character. So this is talking about outdoor lighting and just kind of familiar things that we see out there. So at dawn, things tend to be a lot bluer because we have the blue lights in the sky, and especially just before dawn, things are we don't have the direct sunlight yet, so for the most part everything is blue. But there's something kind of interesting and different about dawn and any of the early or late time periods of day. Let's just paint right on top of this. That is, if we have, let's make a dark object. If we just were thinking about a single fill light, we'd probably say, whoa, the sky's blue, so let's paint blue up ahead. Right? Then it's a soft blue because it's a big light, just like we talked about area lights. So the thing that's interesting about dawn, dusk, and really any of the time of day where the sun is on one side of the sky or the other is that we get a gradient in the sky. So the gradient of the sky becomes a specialized area light source. This is something that is really handy to think in terms of. So on one side of the sky, we've actually got I'm just going to create a transition that matches the gradient in the sky. So we get like this sort of brighter pinkish purples. Maybe we'll get even kind of towards the yellows on one side. So this would be our fill light of the sky. So once the sun rises, and let's change this, so because after the sun rises we get a little bit different lighting than this. Everything might trend a little bit more towards blue, but even after the sun has risen we still get a gradient in the lighting, but we suddenly get another light source. Let's just duplicate this real quick. So the sun starts to dominate a little bit more once it comes up. And it's got a slightly yellow cast to it, especially in the morning, yellow to orange cast. And we'll just erase. Oops. So we'll start to see a little bit of what I was talking about with the gradient of the sky in the shadows. But where you'll especially see it is like if you've got a cast shadow across your surface. So something, you know, a lamppost or whatever. Well, actually I liked that direction so that you can see the whole gradient. So something is there, you know, a fence post or something like that, and it'll cast a shadow across your surface, and you'll actually see the gradient underneath it. And because the sun is bright, we're just going to paint in that saturated edge where the light becomes overexposed. And like I was talking about before, you can see immediately it starts to look like the sunlight is a lot brighter than it is. And it's only because I painted in that edge that it looks better, or that it looks like that. Hopefully that makes sense. So that's more like what we'd get at early sunrise. In late morning, we still have a gradient effect. You can even see it in the sky here. See, lighter on this side, darker, 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 towards that side. So in the shadows, you'll see stuff like this that's lighter, and then on that side, it's a little bit darker. Same thing here. On the back side of this building, it's darker than on that side. And the sun is coming in at an angle still, and it's kind of got that yellowish, orangish tint to it. Then towards noon in the afternoon, this is more in the afternoon, but the sun becomes a little bit more white. Everything gets a little bit more blown out just right at noon, and then in the afternoon you have similar types of things. Actually, this could work for morning just before noon as well. It's just kind of around that time of day where the light is just a little bit more neutral and everything just gets a little bit more blown out. And the blue in shadows, here is the blue from the sky is very pronounced. Whereas here, the blue from the sky is not quite so pronounced. You can see it here in the shadows on the curb. It's there, but it's not as strong as it was before. And that's especially true at noon. So even though there will be blue at noon, it's just not as strong because of the direction of the sun and how much dominance the blue of the sky comes in. In fact, maybe I should explain a little bit why that happens. Let's take the same and paint it like we would at noon. So at noon we've got probably a pretty bright sky still, which probably shouldn't paint quite that bright just because we're going to have exposure to deal with in a second, but it gets quite bright. Then on top of that we have what's going to be basically really bright light that just blasts out everything. And again, it'll have that little bit of yellowishness to it. Let's say this is a white sphere, so we're not going to get a whole lot of that yellow on that edge. Just put in a little bit more just for effect though. Checking for my terminus again. Remember, it's going to go from that point to that point. So that's where my fall off is going to end. And probably because of exposure things again, that's just going to drop off a little bit. And that's more like what we're going to get at noon. So we'll see that there is some blue there, and especially as the two things mix together, that saturated warmish edge that I painted in is mixing now with the blues because I made that transparent, and so it's actually drawing over that stuff underneath. So you get kind of a combination of the two effects. of the lighting from the big sky overhead, the overexposure, and then of course the directional lighting kind of covering up the brightest parts of the blue. See, that's where our brightest parts on the blue lighting from the sky are. But we don't even see that because the sky is blasting that out. Golden hour is where the sun starts to come in at an angle, and it's a really good time for photographers. And I don't know why, but for some reason the early sunrise, everything feels a little bit more blue. Even though the sunlight is still just as yellow, you just get a lot more blue in the shadows. And it seems like at golden hour you don't get quite as much. Maybe that's not really even true, but when I've painted it that way, it seems to work. And this type of lighting looks like it's evening, whereas this type of lighting looks like it's morning with more blue in it. Like I said, I don't know why. I'll let you know when I find out. Then sunset, we start to get the longer shadows. They're starting to get blue again. Part of the reason why the shadows are getting blue is because of what I was talking about, where you've got the sky, the brightest point's going to be towards the top and everything. But it's also because the sunlight is getting darker as the sun gets lower in the sky. It's having to get through more atmosphere. It's getting more reddish, and we'll talk about why that happens in a later session. But because it's getting darker, all of those blues are getting, relatively speaking, much brighter. The sky becomes a more significant light source, and you can see that that's even more pronounced here, where you get the very light blues in comparison to, even though the sunlight is still brighter, it's not as much brighter as it was at noon. Of course, there's atmospheric effects there too, which are kind of messing a little bit with how we're seeing things, but it's true what I said. Okay, dusk is when the sun is just setting beyond the horizon. Now the difference between dusk and twilight is usually about 15 minutes to 30 minutes maybe. The two are pretty close to each other in time, but you get pretty different effects. At dusk you still get quite a bit of warmth, especially if there are clouds on that side of the sky, where it just lights up the clouds and they become this very diffuse, soft light source. And this, again, the blues are very prominent, but the light of the sky is still a little bit brighter than that, so you can see a gradient from one side to the other. But now you see the shadows are very soft because you don't have direct sunlight. Twilight, on the other hand, you can see now that directional light of the sun, it's still there, but it's it's reduced a lot. And you can see now the shadow is mostly concentrated under the ball. The light source of the sky becomes the most important part at twilight. Then at night, things are basically dark unless you've got the moon. And the moon tends to have a white light to it that has a little bit of a blue tint to it. And of course the sky, when it has the moon in it, the sky does get lighter and it gets a little bit bluer. And so you'll get a little bit of blue in the shadows. But this photo was exposed for quite a while. So a lot of this stuff wouldn't even show up very well in a night photo. Movies, though, they usually fake night lighting. And they'll do it by filming in the day or towards the evening or something like that. And then they just use filters, or they'll can their lighting, meaning they'll just bring in lights on a studio, and then using the filters or using blue lights, they just kind of fake their lighting. They tend to make things more blue than they really are, but we're so used to seeing that kind of lighting that I think it's probably okay to paint it like that now. And the reason why they do that is because there is a little bit of a blue tint. They're just overemphasizing the idea. Couple other things about lighting. With shade, you've got the blue light from overhead of the sun, but you've also got the sunlight that sometimes it'll be coming through leaves. In this case, it's actually coming over the wall. And those parts will be, when you're exposing for the shadows, everything will have a blue cast, and those parts will be blown out. And usually those parts become a light source in themselves. So you can see all of these umbrellas here and the wall there have a slightly warmer cast than these things here, which are just being lit mostly by the light in the sky above. So same type of thing you can see on these leaves. They're being lit from underneath by the ground, and on the top side they're being lit by the sky, so they're a lot bluer there. Overcast lighting tends to be more neutral, and it's very soft, so you're basically just have a big white or grayish sky. This is a darker overcast, but again, it tends to be neutral, and so colors tend to pop out a little bit in overcast light. It depends on the overcast lighting. If it gets very dark, then you do start to lose color a little bit. With bright overcast, what bright overcast means is that the sun is kind of peeking through the clouds and it's diffusing in the clouds on one part of the sky. So it's similar to what we talked about here, or not there, I guess, with dusk, where the sun is kind of spreading its light through the clouds, except in this case the sun is actually behind the clouds still. And so all of your shadows will become a lot softer, all of your forms become a little bit rounder, all of your shadows become soft, but you still get a definite direction. In this photo, there's actually enough sun coming through still that you do get some slightly harder edge shadows, but bright overcast can give you bright direction, or can give you directional light without necessarily the hard edge. It can also be spread. It just depends on the attributes of the clouds. So all of those are lighting schemes that you should be familiar with and be used to painting, because they're very natural. They're the types of light. It's the basics of how light works. I also threw in this image because there are plenty of exceptions. I could probably talk about them all day, how weather affects things, but knowing the basics should handle most things. Another thing just to remember is that the seasons will affect the direction and color of the light throughout the day. This is around noon in the winter, and you can see how much different it is from what I painted here, which made it be that I'm not a very good painter, but I think in this case what we're getting is the sun is at a very low angle in the sky because of it being winter. And so that's another thing just to keep in mind, is to where the angle of the sun is going to be, and also how the weather is affected. You tend to lose a lot of saturation because the skies in winter tend to be, at least here anyway, they tend to be very hazy and overcast, so you just lose a lot of color through that haze. It just makes things the sun gets very bright and just blows everything out. Okay, next image. I'm going to talk about man-made or indoor lighting. Talk a little bit about both. So I define mostly by radiosity and occlusion. Radiosity just meaning, that's not even really the right term, but bouncing light is another word for that. So you need to learn and practice and work on occlusion and bounce light if you're going to be painting indoor scenes, because it's so important in the definition of things. You can see even in this photo right here how much that edge is defined, and even these edges around that are defined by what is essentially just occlusion and bounce light. So everything, when you've got an enclosed room, all of the surfaces become light sources for your scene, and that's why. So windows tend to be a little bit cooler than your average indoor lights. So this is just going to be, like a tungsten bulb or or halogen and things like that. They tend to be a little bit warmer. When you have that type of light mixed with a window, the window tends to be very cool, and the two contrast kind of interestingly with each other. You get a warm, cool relationship going on. So, and when you're creating a lighting scheme, it's always good to think in terms of warms and cools. You can set off two light sources from each other. Like, let's say you're using two fill lights in the shadows, or using a gradiented fill light. You can actually have it go from warm to cool across the gradient, or use a warm and a cool fill light. And it's good when you're setting up those schemes, or your lighting schemes, to think that. Of course, when you're indoors, any areas that are lit, because it's so much darker inside than it is outside, even when the lights are on, if you have the sunlight coming into the window, it becomes a light source for the room, and a pretty bright one at that. And this is just showing how the light from windows is kind of blue again. Okay, I put tungsten, but this is almost any light bulb, just regular light bulb, is going to give off kind of an orange cast light. Whereas fluorescent lights, you can see a comparison here. This is the tungsten bulb on this side, that's the fluorescent light, has a greenish blue cast to it. And that ball is almost lit evenly across it. So the values aren't that much different, but you can tell where one light is and where the other light, where one light begins and ends and the other light begins and ends, because of the colors and how they cross each other. And then candle or firelight tends to be very red-orange. Again, this is just giving typical examples of light so that you know some basic rules to work off of. And I talked a little bit about this above, but when you're mixing lighting from cool light sources and warm light sources, or man-made sources and natural sources, you tend to get some really interesting combinations. And warms and cools are very handy in kind of moving the eye across the piece and keeping things interesting, so keep that in mind. Even when I also talked last time about light dominance. So if you're setting up your lighting scheme, oops, commit that, and let's say that we're using a blue light. Oh, one other thing. Occlusion tends to lean towards warm colors. There are exceptions to this, but in a lot of cases, it just looks right if you paint with like a deep, warmer color rather than a deep, cooler color, or just a black or gray. So, of course, if you're painting a scene that's blue, gray is going to be warmer, but this isn't really about warms and cools, so I'm not going to talk too much about that. But so we've got kind of a rudimentary lighting scheme here. Let's throw in another fill light just to kind of keep things interesting. So then we've got the key light, which let's make a warm light. So what I'm going to do is I'm going to make it so that I'm not going to make the key light be this same light but brighter. In fact, I'm not even going to make it the same saturation as either of these other lights. I'm probably going to take something that's even a little bit more saturated, or kind of in between, and I'm going to, of course, be changing the value as I go. But in the end, that was a bad way to paint it, because you can't see the original light anymore. Paint it so that the light's coming from a little bit behind the object. So now you can see I've got warmer, cooler, cooler. I'm kind of keeping everything in different color, and so you can see how much as you move from one light source to another, it's changing hue and value and saturation. So that's going to help if you think in those terms. It's going to make your paintings more appealing. If you just think every time I change value, I need to change my color and I need to change my saturation. Now, you're not just going to be doing that arbitrarily. You're going to be wanting to think in terms of, okay, how is this light exposed? But you can see, because I have this light slightly overexposed, it changes saturation as I roll towards up in the gradient, and as I go back down, see that little curve again we're used to? In this case, we're also getting a roll in the hue as I go from one side to the other. And if you do that, then your pictures are going to end up feeling very rich color-wise. And it'll be, again, like I said, true to experience, what people are used to, or what, even if it may be idealized for the circumstances that you're painting it in, it's going to look right to people. It's going to look good to people. Let's talk just quickly about how do you mix light and surface colors when you're actually painting. So what if I did that same lighting scheme here, only now I'm doing it with a red sphere. How do I decide what color goes where? So there's a couple of different ways of mixing your light and your surface color. So this light, it's kind of a warmish light, kind of like a sunlight, and my local surface color, I was thinking mostly red. So if I'm doing a bright, slightly yellowish light, I'm going to just roll the light slightly that direction towards the yellows, and I'm also going to go up in saturation just a little bit. And I think I went a little bit too far, because that light isn't that yellow. It's mostly reddish. But I'm going to want to make sure that I get that red in, or it's going to look strange. On the shadow side, how do I decide what that color is going to do to the red? Well, there's a couple ways of doing this. One is I can figure out, okay, what color is that going to be if I just have like a neutral light, a gray light. Where's that value going to be? Probably somewhere in this range. If I take the blue light, I'm just going to mix it in a little bit and just kind of grab the 50% between those two lights. Now, because it's a red being hit by a blue light, I'm also going to bring it down in value a little bit. So again, I need to bring in red for this to really feel right. And I might have gone a little bit too far with where the blues are affecting things. Might be a little bit more impure of light, so that we will be getting a little bit of that red and showing up. But then on this side, I can just go ahead and go a lot darker with it. In fact, it can get quite a bit darker overall on the shadow side because of the colors of light. So that's maybe not a perfect, but a pretty good representation of what's going to happen. So that mixing that I did, where I'm painting in the light and then kind of grabbing the 50%, that's very similar to what you would do if you're painting traditionally. You would pick a color and pick another color and mix them together. I'm just doing it on the canvas because it's very convenient when it's digital. I can undo right after I mix it there. It's just very convenient. There are other things, like there's a function in Painter where you can put up a mixer on the side, but no reason to. Just do it on the canvas. It's fine. So there's another way to mix these lights and figure out how they would fit together. Actually, there's a couple different ways, and I'll show you a couple. And then you can kind of pick what your favorite is. So one of them is, I can actually use a white painted version. I can just, you know, figure out what would this surface be lit like if it was white. I'm just going to line it up here. And then I'm just going to take the surface, or the red one that I had before, and I'm just going to paint it the local color, whatever I want that to be. And then I'm going to take that other surface that I painted, which I can do that separately, I can do it first, you can do it in any order that you want, and I'm going to do either a multiply pass or a gel on it. Now you'll notice it doesn't work perfectly, and one of the reasons why is because I used a pure red, and in this case I actually was imagining that it wasn't a pure red ball. So you can see it works a little bit better. We're starting to get a little bit more color the farther away we get from it. Now this is where you'll start to see some of the limitations that I was talking about with the gel and multiply layers. They're not perfect. Like, it's no matter how well you render this, and you know, whatever the colors are that you want it to mix and be, it's not going to be perfect. It's going to be okay. It'll work. It's passable. And obviously this version isn't perfect. There's probably lots of things that I can still do with it as far as how the exposure fall off works and everything like that, but we're going to get a little bit better accuracy with that type of scene, with that type of thing. There's another way, so let's look at that now. Just duplicate it again. And this time I'm just going to create kind of a dark, mid-dark red, maybe even a little bit deeper than that. Well, actually, let's just go pretty dark with it. And if I put a layer on top of that, I'm going to fill it with black, and I'm going to throw in that blue light, and the blue-green light, with this sort of yellowishness to it. And I'm going to turn those into screen layers. And sometimes this will work with lighting, but I do screen. And then just turn it down a little bit till it looks about right. Because obviously it's not gonna, your lights aren't gonna be so bright, especially because I'm separating the lights. If I would, by the way, if this was like a purple and that was a green, I would separate these into two separate layers and do screens for each one of those layers. But in this case, I kind of knew what I wanted, so I just did this. Then I duplicate that layer again, fill it again with black, and this time now what's going to happen if I just paint a white there? It's going to make it that color. So there's another layer type that I can use here, and that is overlay. Oops. And if I just put that right over the bottom layer there, overlay, kind of expected that to work better than it is. Maybe it's because I need to duplicate it a few times. Okay, never mind. It's not overlay. Probably what I need to do is I need to do a screen layer in this case also. We'll start with the black again, and then I'll do the red. I can just use black to make it fall off the way I want to and be the shape I want it to. But I'm just using the red with the screen. Then I'm going to do a separate layer. And I can actually do that again and again if I want. And keep duplicating it. But it's never going to, I mean, I think it'll eventually get towards white, but it's not going to work as quickly as I want it to. So I'm going to throw in another screen layer. And this time, I'm going to make it white. And this one I am going to do full brightness. At first, of course. Then I'm just going to pull it down a little bit. Oh yeah, I don't want to do white, I want to do yellow because that's, we had a slightly yellowish cast to our light. So that's actually a pretty good technique. You can just layer things on top of each other. And you can do the same type of thing. You know, what happens now if I want to do the same thing, but now I want to have a blue light shining on this thing from the side. Well, I can do that using this method. Again, it's going to have its limitations, like I had to break out the two colors there. But that's fine. That's the thing that's nice about doing it in layers. So some of it is going to have to take a little bit of brain work, the stuff that I've talked about already, where you'll need to take something like a blue light, you'll need to trend it towards the red and pull it down in saturation and value. Do that instead. And that'll give you a more accurate look as to what the light color would be as it mixed. But it's nice to have this much control, because if that blue still seems like too much, I can just pull the opacity down in that layer. So that's not looking much like a red sphere anymore, but you can always go back in after the fact and pull things towards, you know, sometimes things that are accurate don't necessarily look right, and it's like I said last time, if it looks right, it's right. So you can kind of eyeball stuff like this, and you know, it was not looking like a red sphere anymore, so I am pushing it a little bit towards red. Of course, we'll need that red edge for the upper edge as well to make it really feel like a red object, because when something is overexposed like that, it doesn't fall off from white to gray. So that's starting to work. I think we could do a bit more work with that, especially on this edge. And I'm kind of doing that mixing on canvas thing again, just to make sure I've got all the colors that I like or that are going to work. Okay, well, that's the general idea. Oh, and of course you can just go into this, because this one doesn't look too bad, especially if it was supposed to be a purely colored red sphere. Just kind of pull in some of the stuff that you think it might be missing. I like using fade. It's kind of the lazy man's way out. The brush stroke didn't work, so I'll just cheat. I can push that just a little bit towards white, and it'll look overexposed. So this is maybe a good example of what I would get if I had a pure red ball under this lighting scheme, and this is more an example of what I had if I had kind of a pinkish red ball in that lighting scheme. Alright. Now let's talk a little bit about texture. So I made this ball, and I've got this texture that I painted for it, which if you look at it, whoops, not that one. I just took it off of a picture of a rhinoceros and just kind of touched it up a little bit. If I was really trying to make this work, I would try to paint the edges of it so that it looked like it was wrapping around the ball, but for the purpose of this demonstration, just pretend that I did that already. So there's a couple of different things you need to think about color-wise when it comes to texture and surfaces. Now there's a few different things that can affect the color of a surface. Obviously, like things like paint. Oh, that's not the brush that I thought it was. There we go. So if we have an old paint job on this thing, which that's a bad texture, but you know, that's going to show up as a different color, obviously. That's the simple, easy one. But there's other stuff like grime or dirt, and it can be, you know, a variety of different colors, but that'll change the color of your surface. You've also got stuff like bleaching that happens because of the light. You know, if this has been out in the sun for forever, then the side towards the sun is going to tend to be a little bit less saturated, and it's going to lose a lot of its whatever the distinctive color and surface qualities it had. Then let's see, grime, light discoloration. Oh, and of course material variation. So, you know, if this was a rock, then we could actually have, you know, little bits of other rock in it, which is a more hard material variation. But you can have, like in a plastic, you can have something transition from, you know, a red plastic to a soft, you know, a shiny red plastic to kind of a softish green or blue plastic that's more matte. That type of thing can be manufactured, and there's plenty of examples of it in life too. When we learn about skin, we're going to talk a lot about that, how there's variations in material properties across the surface. Then there's the texture itself is going to affect the properties of it. So we had this texture before, and I just ripped a few versions of it out and did some things with it. So if we were having this texture, let's say if it was a skin, there's a variety of things that can happen. Of course, we can get grime and dirt in the cracks. Oops. And that's going to kind of push things one direction. Or, of course, the cracks can be colored something else, like maybe the cracks, each place where it's cracked, you know, you're seeing like the pink, soft, sensitive skin underneath. Oops, that's not one. And then, of course, there's what happens on the peaks of a texture. You know, with this texture we've got those parts that stand out. So with these, I just made them white. So like if this skin was, you know, brushing across dusty things all day, it could get in the cracks if it had been brushed off on the outside. But if it was just, you know, the rhinoceros just sat down in something dusty or whatever, then it wouldn't be in the cracks yet, and you'd get it on the outside. Or you get stuff like calluses or whatever else that just change color because towards the outside because they're a different kind of skin. Or you've got other things like just the material itself changes. Like if it was a frog texture, you might actually, or a toad, you'd actually get a different color at the end. That's just because of the nature of the thing. That's how it grows. So when we put those two things together, we get kind of this weird looking texture, which looks a lot better. Oops, that's not the one. Looks a lot better when you build it into the texture a little bit. There's a couple different ways I can mix this together. So I could spend a bit more time touching up this texture, but it can get really complicated with texture and surface, and sometimes it helps to deal with this stuff separately. Like sometimes I'll paint all of this stuff first, and then I'll throw the lighting in as layers, you know, using multiply layers or lighten layers or screen layers. And other times it's good to do this stuff afterwards, but it always helps to add interest and variety to a character to have, even if it's very subtle texture and color variations across the surface. Hi, welcome to lesson 3. In this lesson we're going to talk about specular reflection, global illumination, and basically anything that is going on off of the camera or behind the viewer. When you're looking at an image, you essentially have the camera or the viewer. Usually there's stuff going on back here that isn't showing up in the image, but it does affect how your image turns out. So first of all, let's talk about a different kind of reflection than the Lambertian reflection that we talked about before. What specular reflection is it's basically a mirror reflection. When I use the word specular reflection, I'm referring to something where all of the light that comes and bounces off of the thing that has the reflection is going to be duplicated perfectly, or at least somewhat perfectly, for the viewer. So one thing that I would like to kind of emphasize up front, because I think this is important, is that in any reflection you're going to lose light. Just like with Lambertian reflection, you lose a certain amount of light, you lose certain parts of the spectrum, or whatever is absorbed doesn't come back to the viewer. In the same type of thing you can see in this mirror, we actually have a change from here where it's kind of a grayish white ball to what is kind of a greenish, slightly darker ball. But it's still pretty good. Obviously, in this case, we're going to have the glass, which is affecting the color. But even if we didn't have the glass there, we would be losing a little bit of value because of the reflection. Most reflections, however, aren't going to be mirror reflections. Even when you've got really tight, strong-edged specular reflections, you're going to have quite a bit of light lost. And so, like with this ball, you can see reflecting. You can see the silhouette of the ball against that light in the background. You can see the upper edge of the ball, just the texture on it and everything is kind of showing up there. And you can see the light. You can see some stuff that's going on behind in the background. Maybe a towel that's hanging up in the kitchen or something like that. So with this, even though it's got a Lambertian reflection in the countertop, it's a granite countertop, it's polished well, and so we're getting some reflection, but a lot of that light is lost. And that's usually the most common case we're going to see specular reflection in. So one of the major laws or rules of specular reflection is the law of reflection. So what the law of reflection is it says that the angle of incident is equal to the angle of reflection. What that means is light is going to be coming from, somewhere off in our scene we've got the sun or whatever the light source is. It's coming in, it's bouncing off of whatever is in that scene, and then it is bouncing off of our object that we're seeing, and then it is bouncing back to the eye. What determines where we see each object in that mirror reflection is that law of reflection. So what it is if you were to put in a tangent to this ball, meaning that something that is the plane, if we were to take what is that plane, what is the angle of that plane, that's what the tangent is. If we draw a line that is 90 degrees or perpendicular to that line, essentially we should be able to see, if I were to draw that the right angle, this angle and that angle, they're both the same. And that's always true with a specular reflection. So in this case, the tree, that angle and that angle are the same. That angle and that angle are the same. Remember that this is with respect to that tangent, the angle of that plane that it's hitting it. So what that does is it makes it so that that reflection happens at a different location for each object. We would see the cloud in one position in that mirror reflection, we would see the sun in a different position, we see the tree at a different position, and we would see the person standing there at a totally different one. What's different about the Lambertian reflection as opposed to specular reflection is with a Lambertian reflection we see the same thing no matter where we go. If the light source causes there to be a terminus right there on the object, then if I'm standing here or if I'm standing here, I will see that terminus in the exact same spot. And I will see the diffuse highlight in the exact same spot. Even though my angle as a viewer, I may not be able to see that spot there. It will be in the exact same place. With specular reflection, on the other hand, you'll see the sun right there on the ball, or the sphere, if my eye is there. But what happens if my eye is here instead? That angle is going to happen in a different place. Essentially, if I were to draw a line between the ball and between the sun and find that tangent again, I should be able to find a place where that angle is equal, and I'll know then that that's where the sun is. So this is something where it's good to know a little bit of the trigonometry behind it, but mostly you just get a feel for it over time as you're working on, as you do more and more, get more experience. You just kind of get a feel for where the lights can move. But it is good to know if I've got an object here and my eye is here, then I need to find the place that's halfway in between those two as far as that plane is concerned, and right there, that's going to be where I see that object reflected. Same type of thing if I have an object there. I just need to find the place where, if I were to draw an equal angle on both, find that tangent, that those two angles are equal. It doesn't have to be exact. You can be approximate when you're painting, and it'll sell itself well enough. You don't need to have it perfectly accurate. But what's good to remember about that is what that means is, well, actually, let's go back to here. Clear out some of these lines so you can see my diagram again. Oh, can't back up that far. What that means is, when I'm looking at let's move this eye to here instead. When I'm looking at this ball straight on, I'm going to be seeing right here objects that are behind me. Right here, I'm going to be seeing objects that are generally that direction. At the 45-degree angle of that object, 45 degree meaning halfway in between the 0 degree and 90 degree point on that ball, that 45 degree angle, the light's going to be bouncing off of the object from my eye, and we're going to be seeing what is basically exactly to the side of the ball. We're not going to be seeing it on the edge of the ball, we're going to be seeing it right there. Now that angle got a little bit messed up because of how close the eye is to the ball, which is also going to be a factor. In fact, let's back up one more time, and we'll pretend that the eye is out there so that we can draw that one more time. So we find that 45-degree point, and it's going to bounce us. It's going to bounce that light so that we're seeing what is exactly to the side of the ball. And when we're looking here on the ball, we're going to be actually seeing reflected stuff that is way behind the ball, things that are back here. Of course, they're going to get really squished because of the angle of the planes and the way that we're seeing it all. So what that means is, if I'm trying to work out a scene and I have a tree that's right next to, or not right next to, but to the side of the ball, I'm not going to do the reflection of the tree right here along the edge of the ball, because that's indicating that there's something off here in the distance that's reflecting into it. If I want some tree that's exactly to the side of the ball, exactly that angle, I don't know how to really indicate with just the pen, I'm going to have to find around that 45-degree angle. So that's where I want my tree on the ball in order to indicate that it's exactly to the side. So because of that, let's change our brush here. The top part of the sky is going to be about right there. So here we're going to be starting to see stuff that's off in the horizon this direction. But there we're going to be seeing what's directly above us, directly above the viewer. Same type of thing here. If I was painting this ball so that it would be able to see what's going on the ground right below. And so forth. And then all of this stuff would be images of what's going on behind the ball in that direction. So I talked a little bit about the sphere test. Let's back up just a little bit. In one of the previous lessons where we did, you may remember, painted a ball, and then when I was painting another object that had kind of a weird, funny shape to it, I just worked out in my mind what the angle of those planes were and used that ball to figure out where those colors should be, how bright they are, and so forth. We called that the sphere test because it's testing, it's kind of a way of testing beforehand where our light is going to be, and we're using it later. And the sphere test is pretty handy, especially for very complicated lighting situations. With a specular light, or with a specular reflection, it's also nice to have a sphere test. In fact, it becomes crucial because when you have a specular reflection, it becomes, unless you've got something fairly small and not very reflective or something that's very diffused, you're going to need to have a crystal clear reflection if you're doing something that's chrome or is a clear specular reflection. And you usually need to know what is going on behind the viewer. Now, if you're doing a painting, you don't actually need to do the, whoever it is, the viewer standing in the reflection like you would with a photograph. You can get away with leaving that stuff out if you want to. But you need to know what's going on in every part of your scene. But once you've done that, once you've created that sphere test, it becomes pretty easy to apply that idea to other objects. All I did for this cylinder is I just kind of figured out, alright, this part of that cylinder is basically about that angle on the ball. So in fact, in this case, I just kind of picked up that section and scaled it up and plopped it down right there. Kind of picked up some of the other colors and got it till it looked like it was about the right thing. Then same type of thing up here. I just kind of picked colors out of here and stretched it across the side of that cylinder. Now, if I'm being really technical about it, I'm probably going to find, oh, this tree is actually going to be going across this thing also. And I don't need to necessarily worry about even seeing the edge of that tree. I'll just be seeing the parts of the tree that stretch around that cylinder. So this becomes really handy when you've worked out a sphere beforehand. You can do pretty accurate reflections. I don't have to get it perfect, but close enough, and it'll fit into my scene. I'm realizing now that I may need to explain a little bit better the angle of incidence and angle of reflection that I described earlier. When you're dealing with Lambertian reflection, like we talked about, you want to think about where your light location is and where your different light sources are. When you're dealing with specular reflection, don't worry about your light sources. I described earlier about how, you know, the sun is somewhere up in the scene and that's bouncing off the object and so forth. Don't worry about that step. Just worry about the object's location and where that relates to the eye and the planes on the object. That's all you need to worry about. Don't worry about the light source when you're doing specular reflection. And again, this is one of those cases where it's good to separate these things in rendering passes. If you do a Lambertian reflection, do that. If you're doing a specular reflection, do that separately, and then worry about blending them together in the end. Alright, let's move on. Okay, a couple other properties of specular light. First of all, you've got specular color. Specular color, just like with Lambertian reflection, you've got white light coming in. The white light, parts of the spectrum are being absorbed and part of them are being reflected. The stuff that's being reflected again is the stuff that's in the color of that object, whereas all the other parts of the spectrum are absorbed. So there's lots of different reasons for specular color. Of course, there's stuff like this where you've got a silver wrapping paper with kind of a purplish film over it. But then there's also objects that have kind of an innate color to them. Gold is a good example of that. You can see we've got kind of cooler lights come over here, and just like we talked about before, it's attempting to, some of the spectrum is being absorbed and some of it is being reflected again. It's not perfect, and so you are getting some trending towards the cooler color that it started off as. But then you've got warmer objects in here and cooler objects. But overall, the trend of the reflection leans toward something that is golden. Same type of thing here. You've got cooler colors and warmer colors, but for the most part, this whole thing just fits into that purple end of the spectrum. And you can use the same tricks we talked about in the last lesson with gel layers, multiply layers, combining things together to achieve that effect. So then you've got variable reflectivity. Variable reflectivity just is some objects or some types of attributes on objects cause them to not be uniformly reflective, such as you've got rust, you've got dust and dirt that builds into the cracks. A good example of that with the gold here, you have these little parts that are carved, and see how dark it is down in those cracks. You can see the lettering really well. It would be a little bit harder to read that if it was just pure reflection. Just like you can see up here, there's not any build up between the details and it gets kind of muddy, whereas this stuff is really clear because you get stuff building up in those cracks that's hard to polish out. And then of course you've got objects that have some kind of specular attribute to them, you know, maybe gloss on a billiard ball or something like that, and it just kind of gets less shiny in parts, and that causes it to be variably reflective. Most metals, most things that are manufactured have some level of variable reflectivity. It's very hard to get something that is perfectly chrome. So it's good to think in terms of this stuff. And then of course you've got stuff like this where it's mostly a Lambert, where you've got essentially all rust and then little glints of light that are showing up on the metal in between the cracks. So let's talk a little bit about specular highlights, and I guess another term you may hear if you're doing 3D rendering types of thing is specular level. So what this means is you can have a chrome-like reflection, something that's crisp and clear, but it'll still be pulled back. You know, you can actually see both the Lambert properties of the object and the specular attributes of the object all at once. So we talked a little bit about high dynamic range, how in your scene you've got this distribution of lighting, you know, the dark objects, the middle bright objects, the stuff that are highlights will kind of go up a little bit, and then suddenly you've got your light source, especially with the sun, if this is a graph of how bright the stuff is. So basically what that means, like we were talking about before, is that all of that information is going to be the first to drop out in a specular reflection. So the light sources are going to be the last things to drop out here on this sphere. And you can see I put both versions together here so you can see what it looked like beforehand. I took this object, or took this, well, I'll just do it right now. I put it on top of the other one, and I turned the opacity way down. Something like that. But the problem is when you do that, it does a pretty good job with most things, but you've still got the high dynamic range of the lighting in that scene. So stuff like, you know, the light bouncing off of the green stuff down there is not going to be anywhere near the same as the value of the light in the sky, and same type of thing with the light source. So what you're going to need to do is just kind of boost some of that stuff, which I would have erased out some of that darker stuff before I did this. And then of course putting in the brighter specular highlight. It's going to make it look a little bit more shiny. This one's a little bit more shiny than that sphere is. You can also do this, in this case I actually took the reflection, turned it way down as a layer, and then just painted in, or I didn't turn it down actually, sorry, I turned the brightness way down. So I just used, you know, one of these tools, brightness and contrast or something like that. Turned it way down, and then I painted in the brighter highlight again, just like you would have with the sun. And then overlaid it on top. I think I did a screen layer type there. So specular highlights are basically just reflections, and because of that, just like we talked about with the diffuse reflection, the brightest spot on the diffuse reflection is going to be right there, right? We've got the terminus or terminator, and then we've got the natural fall off to that point, and then the brightest point in it. Obviously the biggest light source in this scene is going to be the sun. That's what's causing that lighting scheme for the Lambert part of the material. But then the specular highlight, you'll notice, is not in the same location, and that's because it's a mirror reflection. It's that same thing we talked about before. The sun is up this direction and in front or behind us if we're the viewer looking at this. So even though it's lighting up the sphere almost from the side, we'll see it in reflection shifted a little bit down. And that's generally the rule. Just if you're painting a terminus anywhere, if your diffuse highlight is there, it's your specular reflection is going to be shifted from that. But how much it's shifted is going to depend on the angle of the light. If we're looking at it straight on and the light is straight on, then the specular highlight and the diffuse highlight will line up exactly. But if we're even looking at it a little bit on an angle, there will be a slight offset between the specular highlight and the diffuse highlight. And if the light is behind, you know, say we've got the sun right here, then the specular highlight will, there's kind of a point where they're very different from each other, and then they start to kind of merge together again. So if the sun is right there, the specular highlight and the diffuse highlight is actually way out of the camera. You're not even going to be able to see it anymore. But the brightest spot on the object will be along that edge. Another thing I've noticed, I don't necessarily have an explanation for this, is that as the light source goes farther behind, it actually spreads out. So the closer it is to that edge, the broader it becomes, depending on how far behind the object the light source is. I'd say don't worry about that unless you're painting a light source that is really, really close to the edge. It's probably not going to start spreading here, but it probably will start spreading as it gets really close to that edge. Okay, diffused reflection. Let's say we take our chrome sphere again and we start kind of cutting scars into it. You can see this big kind of gash in it, and then these little chinks, or I don't know what you call them, just little places where it's indented. You'll see that they're reflecting stuff that is different from, of course, the surrounding area, because the angle of those planes are different. You know, these planes are facing that way, whereas these planes are facing that way. And these ones are facing outward and backwards a little bit more, whereas these are facing forward and towards us. And so you'll be getting a place there where it's reflecting all of this stuff, you know, maybe right there in the core of this thing. I guess it would probably be along that edge. And then this part is going to be reflecting what's above us on the sky. And you can figure all this out if you ever do need to cut in a little detail like this, with the same type of way as I described before with the sphere test. But you'll notice, you know, we're getting the sky in all of these, and, you know, little bits of the sun in them. But down here we're not getting the sun, and we're getting very little, if any, of the sky. And that's because of the overall plane change of that and its location on the ball. This part of the ball, the surrounding part of it, is actually occluding the sky and the sun. There's no way for the sun to reach that part and reflect off of it. So because of that, all of these little things, these little scratches and nicks and things like that, will create kind of a texture on your surface if you get a lot of them. So on this granite countertop, there's just tons of little tiny scratches and blemishes and whatever things in between the grains that are reflecting the light differently. And what it does is, instead of having a perfectly crisp mirror reflection of that highlight, we actually have a slightly spread or diffuse highlight, something that actually spreads pretty far, even though there's kind of a bright white center of it. When you get tons and tons of these and they're very, very tiny, then what you end up with is a very diffused reflection. This is what happens if you use that spray-on silver paint. It creates a very diffused reflection. You get kind of a general reflective look to it, but it just kind of looks really soft. In fact, it's probably even more diffused than this. And just like we have variable reflectivity in the level of the reflectivity, the specular level, we also have variable reflectivity in diffuse. So it's possible to have a sphere that has a little bit of both on it. Stuff like smudges and things like that are gonna, maybe somebody's been getting their fingers on this ball and it's just kind of been spreading the highlights around a little bit, just getting a little bit cloudier look at things. So you can actually have, in fact, it's pretty common that a chrome ball will have just a little bit of that also, just a little bit more of that spreading. And what I did in this case is I just took that, I took the original sphere and I softened it just using one of the focus tools, soften. Did it pretty soft, but it got quite a bit darker around the edge, so if you ever want to do something like that, you need to make sure you compensate for the darkening. It gets darker around the edge because when you've got it on a layer, there's black on the layer underneath, and it just kind of blends it into that black. You don't see the black until you start blending, and you start wondering where it all came from. Alright, this one, anisotropic reflection, is similar to diffused reflection, but what's happening is instead of random directional scratches and nicks and blemishes, you've got a single direction. Oh. So if we were to draw this as a diagram, oops, that's not the brush I meant. Then if we were looking at this kind of as a cross section, a regular, this surface is smooth and this surface is bumpy, but it's all bumpy along an axis. It's kind of like what you'd see with brushed metal. So what happens? I don't know why that keeps happening. What happens when you've got brushed metal or an anisotropic reflection is it spreads the reflection along the opposite axis of the direction of the grain. So this grain is going that direction. You'll notice the reflection is actually spreading that direction instead. And it's just because of the direction of our reflection. We're getting light coming from over here, we're getting light coming from over here, we're getting light coming from over here, but the up and down is unaffected. All of this stuff is still smooth and reflecting just the way it ought to. So we're just getting spreading along that axis. So remember this. This is an important type of reflection because it shows up a lot in nature. And of course it shows up a lot in manufacturing. Brushed metal is kind of a popular thing these days, and it's actually easier to make something that's kind of got a brushed or directional texture to it than it is to make something that's smooth and clean like this. And actually you can see examples of multiple types of reflection in this painting, or in this photograph. You can see the brushed metal in here, there's kind of a brushed metal in there. You can see a mirror reflection, something similar to what we saw at first, here. And then here you see the specular highlight type of reflection where the specular level is a lot lower. And then both on this here and also on this phone, you see a diffused reflection where the reflection is kind of spread a little bit. Moving on. So, we talked a little bit about diffuse reflections, and we've talked about Lambertian reflection versus specular reflection. Realistically, or in reality, there isn't any real difference between Lambertian and specular reflection as far as like the atom and the interaction of light with regard to an atom or a molecule is as far as they're concerned. But there is a difference, and that is in the texture and the properties of the specific atoms and molecules and the structure of them as they make up the object. So, as you have no texture, you get these really crisp, clean reflections. As you get more texture, you get kind of spread out reflections. It gets more and more diffused, and of course more and more spread out. So what's happening as you move from this stage to this stage, and of course onto that stage, is your highlights, the lights in the highlights, remembering that light is additive, meaning that if your value is at this level and you bounce light off of that, or you add an additional light source, it's going to make that light be not that color plus the other color and make it actually much brighter than that. That'll be the final color that you see. So because of that, when you've got reflection spreading, the highlight actually starts to kind of overtake everything else. And then eventually it spreads out so completely that the original reflective effect of it, that angle of reflection thing that we talked about, becomes overtaken by what the texture is doing and how the more random probability, or not probability, just random, really just random reflection affects things. That becomes more important as the texture becomes stronger and stronger than the original laws of reflectivity, and that's why we have that. If that still doesn't make sense, just imagine as though if you were to take this same chrome ball and just create like this giant ball of balls and just increase the density, more and more balls in it, eventually you would start to get something that looks more and more like our original. See, now you can see there's a terminus starting to appear. There's going to be a diffuse highlight emerging eventually. We're going to see the other light sources, and it's going to look just like our Lambertian reflection. This is important to remember, that these are the same types of phenomenon, because that affects there are other things that we see that are common between those two things. And I just drew this in also just to show that it works with colors also. You know, the reason why you have a blue ball, same phenomenon again, but because of the textural properties of it, it starts to resemble something completely different that behaves differently. The Fresnel effect. Fresnel was a physicist who came up with a series of equations that solved a lot of things in how physicists think about light and how it works, and it's quite complex, and we're gonna learn about more of the things that Fresnel did. Usually if you talk to a physicist, they won't say anything about the Fresnel effect. They'll talk about the Fresnel equations, but the Fresnel effect is something that you hear in 3D rendering quite a bit. It's just kind of a simple thing that helps people deal with reflection when you're talking about just reflection. The idea behind the Fresnel effect is when you get any type of real-world reflection, you're not going to get a perfect reproduction of that image. You're going to be losing light. But you don't lose light uniformly. And I'm sure there's probably multiple explanations for this. The way of thinking about it that helps me is that you've got all these atoms, and the reason why I say this is the one that helps me is because this may not necessarily be accurate, but it may help. Out here you've got atoms that are kind of evenly spaced, or just generally uniformly spaced, but they're a little bit more spread out. But as you get closer and closer to the edge, according to the viewer, they're getting closer and closer together, just referring to the surface, of course. So they get closer and closer together until they reach this kind of critical density along that outside edge. And because of that, there's actually a change in properties of how it reflects as you go around a form. I'm not going to bother to erase that. So what the Fresnel effect is as the angle increases, so I guess a good way to put this is maybe if you're seeing an object that is bouncing from in front of you, that object is going to be darker than an object that is bouncing from behind you. And what that means is that as that angle change from the angle of incidence to the angle of reflection increases, then you actually get more and more reflective. So this stuff here is going to be reflecting much more strongly than stuff here. One of the things that, or one of the places where it's most easy to see this is on water. And different materials have different levels of how the Fresnel effect interacts with them. Water is one of the stronger ones where you can really see it. If you stand on the side of a lake or a clear pond, you'll see that in the distance it becomes just a mirror. You can't see through it anymore, or you can't see the color of the water anymore. If you have really muddy brown water, then you'll actually, eventually just see like a pure reflection. As we get further and further, as that angle becomes more and more extreme, or as we get lower and lower to the surface. Whereas if you're looking down into the water, in fact, if we walked up to this water edge and looked straight down into it, there would be very little reflection. But you can see right here, we can see quite a bit down into that surface. And even here we can see. But we start getting more and more of the sky and more of the sky until back here it's almost just a mirror reflection. And that is the Fresnel effect. So, easy way to remember it. If you're drawing a sphere, the center of the ball is going to be the least reflective, and the outside edges of the ball will be most reflective. And the fall off is going to be generally, if this is the curve, where this is the most reflective and this is the least reflective. We'll do a hollow thing. And then this is the planes that are facing us versus this is the planes that are parallel to our line of sight. It's actually going to curve upwards pretty quickly there, and that's just because of the way that the density of atoms increases and so forth. Because of the Fresnel effect, we will see this object on both chrome or even just mostly chrome, or just any type of specular surface, billiard ball or whatever. But we'll also see it, if you remember up here, that there's no difference between Lambertian and specular reflection. You'll see a small degree or a small level of specular reflection on most surfaces. So you'll actually get a slight amount of reflection just right on that edge. Remembering, of course, that light is additive. So what's going on this edge is going to be a mixture of the color of the surface at that point and the color of the sky or whatever else is reflecting off of it. And of course it's going to be stronger for some objects and weaker for others. Remember that. The Fresnel effect can be really handy. So, talking now just about global illumination. In 3D rendering, global illumination refers to a way of dealing with light that allows us to see light from every angle, so that we're seeing the light that's coming from every angle onto an object. And I think that's a pretty good explanation that works for 3D rendering. But there's another type of global illumination, and that's what I'm going to talk about. So I'm not talking about the 3D rendering form of global illumination, where they're using actually a sphere to light whatever the object is. A sphere with like a map of the environment on it is usually how they do it in 3D. What we're going to talk about, though, is global illumination, meaning that the light of everything around us. And I guess they're related, but the way that we're treating the term is different. So we talked about simple lighting schemes. We've got kind of a ambient color that's kind of this desaturated reddish from underneath. Then we've got the very cool light, fill light of the sky coming in. We've got the key light. That's a simple lighting scheme. We've talked a bit about that. Global illumination, on the other hand, is going to be looking at what is going on in the environment, what's behind me, what's lighting this thing, what's on the opposite side of this object. And so it's going to become more complex. We're going to start dealing with, what's the color of maybe there's some of this, grass or whatever that is lighting up the the ground on this part, and we've got the sky lighting things up a little bit here. If we've got a big yellow cloud in the sky, or a pink cloud, the pink or yellow cloud is going to be lighting up what's going on here on the sphere. Then, of course, you're going to be getting reflections that are from stuff around the sides or from behind. And then, of course, you've got the Fresnel effect, which is also going to be illuminating the stuff around the edges. So you can see the difference between these two spheres. You know, that one looks like a sphere in a dark room. Not bad. This looks like a sphere that's actually in an environment. And when you learn to deal with global illumination and Fresnel effects, you're going to have a much easier time making objects feel like they fit into a scene. So how do you do global illumination? Well, let's paint something else that would go into this environment. Let's say, what happens if we do a really desaturated grayish purple sphere instead? So, first of all, let's deal with what's the ambient light in this thing. If the environment is kind of this generally dark, warmish yellow environment, I might actually start with that as my base. Let's get a different pen. And we'll brighten it just a little bit since it's kind of grayish. And then we'll get the sky color above, which I'm probably just going to mix the two ideas. Pick a color in between just like I would picking colors on something else, and I'm going to bring the value way down because the sky is producing some light but not a ton. So there's multiple ways to do this. I'll show you kind of a simple or a similar method to something we talked about last time. So first I'm going to deal with stuff like, you know, what if we've got a patch of that greenish yellow grass here? It's going to be generally lighting it up, just thinking in terms of area lights or diffused lights. We're going to be getting from this side of the sky kind of a warmer trend. This is similar to the more complex lighting scheme thing that we talked about last time. And then of course we'll be getting blues, and you know, maybe there's a pink cloud over on this side. Sometimes you can just kind of make this stuff up as you go. As long as you're consistent with your scene, it works pretty well. And we'll just bring the overall value of this thing down. Strengthen the blues on that side. And now, I'm going to duplicate it. This time, I'm just going to deal with the Fresnel and other effects that are reflecting just around the outside edges of this thing. Pick colors from around in my sky just to make sure I've got a bit of variation. And of course, when I'm doing this picking, I'm probably going to want to do sampling from the stuff around the backdrop. The things that are behind the object are going to be affecting all that. And now we're going to erase out the center of that object and make it so that it's most dense, or so those colors are most bright right on the edges. And I'm going to switch this to a screen layer. Paint it a little bit more so that it's just that outside edge. And we'll turn it down just a little bit. See, that's already starting to look pretty good. It's starting to look like something that we might actually see in nature. And now I'm going to duplicate my original sphere again, and this time I'm just going to worry about the key light on it. I'm going to fill this with black. And we'll find kind of the combination between my original color and the color of the sphere. Now, just looking at this scene, that light has got to be behind us, so I don't think I painted these scenes very consistently, so this would actually be mostly behind that light from the sun. And we'll do a screen layer on this also. Probably need to pull this one down just a bit. That might have been too far. So there's the Fresnel effect stuff. And there's my diffuse highlight. So you can see how good that looks already. You know, I'd probably want to be a little bit more careful that I have a stronger terminus and everything like that, but not bad for painting for a few minutes. So just to reiterate, the similarities between a specular reflection and the global illumination is this sort of awareness of the environment. Of course, that awareness of what your environment is becomes much more specific with a very tight specular highlight or specular reflection, but in both cases you need to be aware of it. And also in both cases you need to be aware of exposure. So when I was painting this sphere, I needed to think in terms of, okay, how bright is the ambient light versus how bright is the key light? You know, the key light's going to be probably quite a bit stronger than those others. And, you know, I might be able to push the Fresnel effect either more or less depending on how things are working. But for the most part, if you're just looking at it in terms of, you know, how bright is this part really versus how bright is that part? And of course you're still dealing with in both with absorption of the wavelengths depending on what color things are. The last thing I want to talk about is shadows and how they affect things. You know, if I was to cast a shadow across one of these spheres, you know, what am I going to show if, say, I've got a low-level specular reflection? How do I make that low-level specular reflection show that this thing is in shadow? And the key is, if there's a shadow, it means that there's something off of your camera that is causing that shadow. And in this case, I actually have the sun showing through the tree, but let's say I was having that tree cast a shadow. I would just paint it differently, paint that reflection differently in the shadow area so it's not quite spreading around so much and we're just getting what the reflection is without the sun, because that's what we would be seeing if we were that object looking in that direction. And the other question that people often will have is, how does being in shadow affect the reflection? Well, and whether it's a form shadow or a cast shadow, I think the answer is kind of the same. Just going to line this up real quick. That's probably close enough for now. So if we turn that specular reflection way down, it's actually probably in most cases the highlights or whatever from that low level specular reflection, it's going to show up better in the shadows than it is in the highlight sides, because with most objects they're going to be blown out enough on the highlight side that you'll see the reflection, but for the most part what you're going to be seeing on the highlight side, at least with a low level reflection, you're going to be seeing the light source. So wherever the sun is. Oops, that's why it wasn't showing up. That becomes kind of the most important part of the reflection on the highlight side. And on the shadow side you can actually show more. Hopefully that makes sense. But if it's a very low level reflection, then even in the shadows, unless you've got a really bright light, you'll see mostly just the sun. But you might get little traces of something. So it's always good to be aware of what's going on in your scene, even if you've got a low level reflection. Well, let's demonstrate how we would deal with this in a scene. So, starting with kind of a darker background. Let's move this in a little bit so you can see it again. We've got our sphere. Let's just... We'll start in this case with the reflection, because that's gonna dictate the lighting in the scene and how everything else works. So there's a couple different ways of putting in a reflection, and a couple things to consider when you're doing that. So first of all, I would attack it as kind of a layered approach. So if you're going to be doing sky, for example, I'd maybe start with that first. And if you're going to have ground, maybe mountains in the distance. Usually, unless you're like seeing one of these up close, you can get away with a lot in the reflection. It doesn't have to be terribly accurate. Even if you're doing a fairly chrome texture. We'll do reflection of the sun in the sky. Of course, I'm going pretty all-out chrome with this right now. And now let's put in a tree. When you're doing a sphere like this, let's make it a palm tree. Your reflections are going to bend around the surface. If you've got like a vertical thing, it's going to bend around the surface this way. If you've got a horizontal thing, it's going to bend around the surface that way, unless you're getting close to the center of the ball, and then things are going to be perfectly straight again. So same type of thing if you've got a perspective line, maybe there's power lines going off in the distance. Those power lines are actually going to curve depending on how they relate to to what's going on in the scene, of course. I'm not actually going to put those in my reflection, but it's not a bad demonstration. just going to pull that back a little bit. Alright, that's probably good enough. Doesn't need to be terribly accurate for this, except let me just throw in a quick shadow on the side of this mountain. And we'll put in something kind of dark down here on the ground. In fact, let's make that dark all the way around there. Just because, again, we're looking straight down at the ground. Maybe we're sitting in a flying saucer as we look at this thing. And we'll want to put in stuff on the highlight side of the tree. You can see how tedious this is going to get pretty quickly already. It's just there's no easy way to deal with this. You basically just have to paint everything that you don't see. Of course, if you've got other trees off in the distance, they're going to have to be there too, but they're, you know, say they're off to the, you know, this tree is close to off to the side of the ball, whereas all of these trees would be back here. We'd actually see these in camera. And I'd usually have the scene in mind that I'm painting also. I wouldn't just start painting like this. We'll stretch some more of this stuff around just because it's kind of fun to do. Alright, I'm not going to get too technical in all the details of this. It just needs to be enough that it'll hold together when I start messing with it a little bit more. But let's go ahead and put in something and really liven that tree up. It still doesn't work. Put in some of the parts where the light is coming through the leaves in the tree. Alright, well, that's good enough for now. Alright, so the first thing you want to deal with, if you're doing, let's stretch that sun just a little bit more too, actually, first. Just to match the contours of the ball. Alright, so first thing I need to consider here is exposure. Because if I was painting the scene, you know, those values would probably be fine. But realistically, even with a fairly glossy reflection, most of the sky is going to be quite a bit darker than that sun. So we'll just kind of pull everything back a little bit. Oh, that brush isn't working. Let's try it with a different one. Almost everything will be darker. And same type of thing with the ground. It'll be quite a bit darker. Unless the sun is shining really brightly on parts of it, then it'll stay quite bright in those spots. So we'll leave it bright right there. And we'll pull it down in value on these trees again. So that's not bad. Now, we're also going to have Fresnel effect stuff where, you know, we're actually getting better reflection right around the edges, which I should have done this before I darken it down, but that's fine. Because the Fresnel effect, usually even with the chrome sphere, you can get away with quite a bit. You know, you can make it pretty soft on those edges and it still looks pretty good. Doesn't have to be a mirror reflection, even though that may be more accurate in some cases. Alright. I don't really like the way the colors are turning out, so I'm just going to adjust them really quick. That didn't do anything much, but that's fine. I don't worry too much about it. But let's darken down this stuff in comparison to the sun and the sky. Oh, getting a lot of artifacts today. Alright, that's probably going to be a good enough basis for my scene. Now, let's duplicate it, and we'll make a version that looks like it's got Lambertian reflection to it. I'm guessing, based on where that is, that's probably pretty close to a sun straight up into the side of us. So we might just call it good with that. Okay, there's my simple lighting scheme version of it. Now I'm going to take a look at my sphere and adjust the lighting in my scene based on kind of what I imagine going on. Now the global illumination is also going to be affected by the stuff that we see in the foreground. I mean that we would see behind the image. But when I'm doing this, when I'm throwing in these colors, I'm doing it slightly different from the last version that I drew. I'm going to use fairly bright colors to throw these lights in, and I can either put them in very softly like this, or I can pull them back like I do with the fade function. Same type of idea with the sky. I'll just kind of use a bright color, just lay it in over the top, pull it back a little bit. And looking at that scene again, I don't know, there's not much to this scene. I don't know if I need to do that much more with the global illumination in it to make it really work. Suppose I could bring up something a little bit warmer from underneath just to really make it feel fun. And you know, sometimes I'll fake something like that in lighting. It's not really in the scene, but I like, you know, the idea of, like, you know, this being a cooler light, this being a warmer light, and so forth. Now, I'm going to create a duplicate of this one, and I'm going to show you how I did it with the soften again. So start to get an idea of what you get with the diffuse reflection. Let's turn that up even more. So, and of course I'll have to clean up those edges. Or, if I wanted to do a motion blur, I can actually get a pretty good idea of what I'd get, well, with a very cheap anisotropic reflection. I would probably want to take that idea even further. So if it's stretching along that axis, that means the grain is going that direction, right? So it might be good in that case to use a brush that has a little bit of direction to it and just diffuse that thing along that edge. So one thing that I didn't talk about a little bit, well, I talked about it but I didn't demonstrate it yet, is if you do something like this with the just with the soften, or same type of thing with the anisotropic reflection, the other problem that you're going to get is you're going to average out your light source, but like I was talking about before, your light source is actually going to be spreading. It'll retain its brightness and it's going to get bigger. So we should actually be getting more of the skylight with a diffused reflection rather than it just softening down the light source. So you want to make sure that you do that type of thing. If you have any other light sources, you may want to spread them a little bit more also to make it really work. You can get a diffused reflection pretty easily that way. So now, if I want to do, say, a chrome with the, and I didn't do this also. Let's just quickly, because I did the Fresnel effect a little bit, but I didn't do it in the center. And you want to just darken things down at least a bit in the center where those planes are facing towards us. It just makes it work a little bit better. It just looks unnatural even with a chrome ball to have it be too reflective right at the center. And so now if I want to do something, I can of course use both of these spheres as sphere tests if I wanted to do different shapes, and if I wanted to have something that was half chrome or was kind of fading out or something like that, I can do that. Sometimes you'll end up with weird effects and it just doesn't look right. Say like if I dim that down a bit and we're seeing the other thing through it, I might need to actually darken the sphere underneath to really make it look good, or I may need to make it so that this is a screen layer, just like we were talking about it being additive with light. So most specular reflections are going to have less, the shadows are going to affect things less. The screen layer isn't exactly right, because if it does have reflectivity with it, it might actually be darkening it down a little bit in the shadows. But it's going to look pretty good if you do a screen layer where it's just adding. So what do I do if I don't want to paint in that reflection? That was quite a bit of work. I probably sat here painting for 5-10 minutes doing something that doesn't actually look that good of a background. Well, there's a couple things you can do. You can take a photo or another painting and you can actually use that as your reflection. You want to make sure that it's consistent with your scene, and you're going to have an easier time dealing with this if you're using Painter instead of Photoshop, but there is a way to do it in Photoshop if you're using the, I think it's under the filters menu under distort, spherize, and that works okay. It's not ideal. Of course the Painter one isn't ideal either, but it works just a little bit better. So if I want to use this image, first of all, if I'm doing it for a sphere test, which is obviously going to be the only real use for it, I could, if I had a more complex object, probably distort this thing and spend a bit of time with it, but I think it's probably not worth that. Probably better just to create the sphere test and then just to paint the rest. And if it helps, you can you know, soften the whole thing so that you're not feeling like you have to paint every stroke in to get it to look like the photo. But it's okay if when you're doing a sphere test, you're not necessarily expecting the sphere to end up in your scene anyway. Let's fade that soften a little bit. We can get one of those kind of cheesy looking photos. Alright, then the other thing you're going to want to do is scale your image so that it's a square, because otherwise it'll make an oval rather than a circle. Then go to Surface Control, Image Warp. Or not Image Warp, sorry, Quick Warp. The first thing you want to do with most images, unless you actually took a photo with a fisheye lens, which is, you know, that's going to work great. What you do first is do Valley on here and just pull the stuff in the background back a little bit. And that just kind of sets things up for you, creating a sphere out of it. Then go into Surface Control, Quick Warp, and do Sphere this time. Leaving the settings at 2 on each is probably fine. You can mess around with that stuff, but you'll get fine results with this. Alright, I don't know why it picked up so much stuff on the outsides. It usually doesn't do that. Let's try something a little bit smaller. Oh, I know what it's doing. It's picking up all the softened parts, so let's cut out the edges so it doesn't have anything to pick up weird soft edges with. Okay, let's try that again. Do a sphere again. Alright, that's not too bad. Except I scaled it too small. We'll select layer transparency. And if Painter hasn't crashed yet, I'll invert that selection and cut everything out. Okay. Alright, well, what you see here is pretty good, but it's not perfect. Because what's happening is, the way that Painter deals with this, it takes, I think they did this just because they figured out through trial and error that if they try and wrap your image all the way around the sphere, it looks strange, and that's actually what Photoshop does with sphere eyes, and so you have to, in that case, you may actually want a fisheye lens photo. In this one, on the other hand, you can get away with having this, but what it's trying to do is it wraps your photo only to that 45-degree point, the one that we talked about, where you would be seeing stuff directly to the side of you, and then it flips the photo and stretches itself again. So you're probably going to have to do a little bit of cleanup if you have straight edges and stuff like that in your picture. It's not the brush I meant. So now I can take, can't. Alright, there we go. So I can kind of fix the stuff that's going on with this surface. And basically all you need to do here is just think about what's going on off of the camera, or what's going on your scene. Well, okay, so I guess all of the stuff that's going on here is off the camera. Everything past that point where it's starting to stretch is stuff that would be in your scene or off camera, just outside of your scene. And so What would help in this case is, I could actually take my scene if it was wide enough, and I could do another sphere using the warp, just do the exact same thing again, and then erase that edge from the one. But in most likely, it's not going to line up exactly. So probably the best thing to do is just kind of fake it the best you can. In some photos, it's going to work better than others. Like, for example, this one. If I do the exact same thing again. Just surface control, quick warp, valley, pull the stuff in the background back a little bit. That just kind of gives me a little bit more of that fisheye lens look and allows me to do this. That this photo is going to have a lot less to touch up. Basically I have to clean up that edge because it's really obvious that stuff is stretching along it, but might even, if it's small enough, I might not even need to do that part. So I think you just need to use your own judgment with it. How much of this type of thing do I need to do? Keep in mind, as I'm looking back at this, you need to keep in mind how the light or how the sphere is warping things. That's going to be important, because if you're going to be using this as a sphere test later and you want to have some other bent surface, you're going to need to think in terms of, if that's my surface edge and I've got this same house here, it's going to be reflected up here and it's going to be reflected out here, and in between there it's going to kind of bend accordingly as it moves along that surface. Which actually, this one's getting closer to that outside edge as I go, so it would probably be something more like that. But anyway, within a matter of a few minutes of touch up, you could get that picture to work. Make sure this tree is being wrapped around correctly instead. For most purposes, you don't need to be that careful with this, because you're going to be using it to do stuff that isn't necessarily high precision. If you're painting chrome a whole lot, you probably need to find a different job. Or, I don't know, I guess I should be nice. If you're painting chrome a lot, you're cool. And you probably want to kill yourself because it's really hard to do. I know that I would. Anyway, so I could use that. I could run with that, even though there's still some weirdness in there. So now that I've got this, it should be pretty easy. If I could use this now as a sphere test, paint up objects that have a different shape, a different form to them, or I can do both sphere tests. I can paint an object using that form, and I can paint an object using that way of describing form, and then kind of erase between the two to create, maybe you've got a marble ball that has parts scraped off of it or whatever. It's really, what you can do with it now is really just up to what does my object need to be. Does it need to have a diffuse light source? Okay, I'll create a diffuse version of this and spread that on. That's what's nice about the render passes method of things. And of course, if I wanted to, I could deal with like the exposure issues and stuff like that, or I would need to deal with the exposure issues also if I was going to be doing all those things. But for the most part, with a photo like this where you don't have the light source in it, you're going to get pretty much what you started with. And I think that's basically all. I think I showed you everything else. So let's talk really quickly about oops. So the assignment is going to be this. You've got 3 objects here. This object, I would say, make it be a chrome ball. You know, do all the details, everything that you can. I put a background in here so that you know what to put in. Then, I think this object should be also reflective. It could be a diffuse reflective, it could be whatever, you can decide. Then this object needs to have variable reflectivity to it. In fact, what I'd like to see is maybe at some point along this object it becomes more, you know, well, actually what I'd recommend, let me paint this in so that you can see. I would probably have the upper part of this object be reflective and have the lower part of this object be non-reflective, have it be a diffuse material, and then come up with some interesting transition between the two. I don't care really what it is. You can think of something that's natural, or it can be interesting, maybe weird scales or something like that. Probably work fine either way. And I don't know that this part up here needs to be like super reflective. It could actually be mostly diffuse with a very soft reflective thing on it. I think you can decide what level of reflectivity. Make sure that this one is chrome and that everything else kind of follows that idea. But the reason why you want to make this be chrome and this not be chrome is because otherwise what's going to happen is you're going to have to deal with what happens when this ball reflects off of that thing, and what happens when that thing reflects off of the ball. And it starts to get really complicated really fast, and your brain will probably explode. So I'd strongly recommend that you don't do reflective material for the bottom one, or do something that's a very soft reflective, you know, not something that's going to be really specific or chrome-like. And I also included an image that is basically what we would see on the opposite side of this same scene. So if we hide these shapes, you can see this is from another painting that I did. I want to see how this environment, both this one and this one, imagining if you just turned the camera around 180 degrees, you'd see the sun up high in the sky. This is, I'd say, don't worry about this lining up exactly like the other. I actually extended the canvas upward quite a bit so that I could include the sun, because if we just made it a panoramic scene and this went clear around, the sun would be off the page. So just because it's fairly high, it's not terribly high, it's still kind of an you know, later mid-evening sun, but that will give you an idea. If you would rather kind of come up with your own opposite side of the world, opposite side of the camera thing, then you can and do that instead. But if you'd rather just get to painting and not have to worry about that stuff, then you can use this one. Now notice that on this background stuff, the light source is coming from the upper left, and on this side it's coming from the upper right. Remember that a mirror reverses things, so what you would be seeing in this scene is the sun would be on the upper left because what you're seeing, what's behind you, when the sun is behind you, it's on the upper left, but behind you. So if you turn around backwards facing the other way, you would see the sun on your upper right instead. And we're seeing essentially the mirror image of that looking this direction. So one more time, the assignment to be absolutely clear. Use this background and this background, or your own background if you wanted to do your own thing on this other side. I kind of kept it simple for just making things a little bit easier. And you could actually use that sphere distortion thing, the warp that I showed you, the quick warp. So this ball should be chrome, this one should be reflective, this area should probably be diffuse or mostly not too reflective, and this area needs to be reflective. And deal with the transition between the two there. I want to see global illumination in the scene. I want to see just how I want these objects to feel like they actually fit in this environment. I want to believe that I'm here. And I look forward to see what you turn out. Thank you. Hi, welcome to Lesson 4. In this lesson, we're going to talk about translucent properties, or basically any property of matter or material, surface, whatever, where light is actually passing through the surface. And there are a variety of ways that this happens. Obviously, we've talked a little bit about reflection, where we've got light coming in, hitting the particles in whatever the surface is, and being deflected by it in some way. But most of the cases that we've talked about so far, we've just kind of assumed that there's a solid surface that we're dealing with. And so it's easy to think in terms of bouncing when that happens. But in reality, almost all of matter is not these densely packed atoms that are so close together that it forms a solid surface. In reality, the atoms are very loosely spaced. There's a lot of space in between. In fact, this isn't even representative of how much space there is in between atoms. It's just this enormous, vast space between atoms. So the possibility of light passing through any particular medium is actually pretty high. It gets, there's certain things like metals and very dense materials and things with very large atoms, things like that, where it becomes very unlikely for the light to pass through. But for most surfaces, if it's under normal circumstances, there's a possibility that light will pass through just because of this large space between atoms. So even if you've got reflection, there's the possibility of transparency where the light passes through, especially when you've got even less dense things like liquids and gases, because with solids, the atoms do tend to be a little bit more densely spaced. With liquids, they're moving around a little bit more, they're a little bit more loosely spaced, and then of course with a gas, they're just really spread out. Okay, something that we haven't talked about so far, and that is scattering. I may have used the word scattering to refer to diffuse lighting and this type of reflection, but scattering in physics refers to some different things. In fact, there are two cases in which we'll refer to it today. One is a type of scattering which it's a little bit hard to describe because it has to do with the quantum properties of light and how it interacts with atoms, but essentially what it is the atom and the light wave have a variety of ways that they can interact. First of all, just by passing close to it with certain types of atoms, certain type of really reactive atoms, it can actually affect the light. When you look at an atom, let's look at the traditional model of an atom where we've got the nucleus and we've got the electrons zipping around, which isn't necessarily the real way that an atom is structured, but it's a good way to visualize it still. So what happens with an atom when light comes in and hits it? Light is traveling very quickly. I think it's 186,000 miles per second or something like that. That might be miles per hour, I'm not 100% sure. But anyway, it's traveling incredibly fast. And when it hits an atom, when it strikes an atom or a molecule, these electrons absorb the energy from that impact, and it pushes them out to a higher energy level. They become more agitated. Now, with a reflection, what happens is the higher energy levels are unsustainable by the atom, and so the atom, it will absorb some of the wavelength, just like we talked about. It'll absorb a little bit of that light, and the atom will actually vibrate. But for the rest of it, all of these electrons jump down to a lower energy level and shoot that light back out again. And for all intents and purposes, the light just basically bounced off of the atom with the exception of the lost light. So there are other things that can happen though. You've got the electron levels. There are certain atoms that are more stable than others. And these ones are not really, the way that the electrons are positioned around it, they're not really prone to react to light. So if light comes in and hits these atoms, it may even bounce them up to a higher energy level, but the net result is that the light continues on without any effect. And there are some other interactions, like the electrons will capture the energy and keep it and store it and release it later, and some other stuff like that, but we're not as interested in those things. But there are a variety of interactions that happen, and they're all based on quantum physics. So we're going to learn about some of the simpler ones today. We're not going to necessarily learn all of the physics, but we'll learn some of the results of the things that are happening at the quantum level. Okay, back to scattering. Another kind of scattering is just similar to the scattering that I talked about before, that I might have referred to, where it's just light bouncing off and going in random directions, except the light may be actually bouncing off of multiple atoms or multiple molecules. Okay, transparent surfaces. They've got a variety of things going on here. Some of them we're familiar with, such as the Lambertian surface, the specular surface, but we've also got what's going on underneath there. For one thing, there are a number of ways that the surface, the Lambertian surface, shows up in a transparent solid or a transparent thing. Let's say that this is just a plastic ball and it's hollow. So you may actually get the traditional shading model with the highlight in the terminus, or you may actually get the light just passing right through that, or just getting a very, very weak Lambertian highlight on that side, and instead it lights up the back side of the object. And so that's why you get this sort of reverse effect where it's dark on this side and light on that side. Sometimes you'll get a little bit of both, and it'll just kind of end up being this uniform color throughout. But you can get a variety of things just happening with transparency that changes the way that it's shaded, even if you don't have any other effects going on. Then there's another thing, which I'll describe a little bit here, which you see quite a bit, where if you have, let's say, just like a ball, and all of the atoms scattered around it that make up the surface of that ball. Whoops. They're all spaced out. But as you go around the curve relative to the light's position, or relative to the viewer's position, it actually gets more and more dense. There's a greater thickness to pass through, for light to pass through as it goes around that ball. And there's an exponential growth there as it goes around the curve. So this light is more likely to pass through. It's good to go. This light, it's a little bit less likely to get through. But this light right here is very unlikely to make it through. If it, or you may get some beams coming through, but for the most part it's going to be a lot darker. So what this results in is a darkening that happens around the outside edges of the object. So you can see how that pass, I actually did this on a separate layer and applied it to that object, applied it on top of this. Then there's the specular highlights, which go on top. the reason why I put that on there is just to show that if you are going to be dealing with transparent objects, it's usually good to deal with things in layers rather than trying to paint it all at once until you've become very experienced anyway. So you would want to do maybe this pass first, then add this one, then add that one, and there might even be additional passes that you throw in there as well. It helps to work things, make things work out a little bit. Another reason why that's a good idea is because all of these things, this darkening around the edges, that's maybe like a 50% brightness or 50% layer, and this one is even dimmer overall. To get the highlight that bright, I had to turn the layer down to 50% and then collapse it and paint it in a bright highlight again. But the reason why that's important is because even though these are both dim, both of those attributes will show up at different times depending on what's going on in the background. For example, if you look at this, against a dark background, you see more easily the lightning effects, the things that are going on with the transparent surface, whereas on the bright surface, it's much easier to see the darker things that are going on. If I moved this cup up here, then you'd actually tend to see a lot more of this light stuff. And if I moved it down more, then up here you would see more of the darkening effects. So that's just a good thing to keep in mind. If you're handling layers this way, this type of thing will show up almost naturally. But you also have to, even if you're trying to do shorthand, consider that, is this a dark background, is a light background? Okay, if it's a dark background, I'm going to tend to work on the additive effects. If it's a light background, I'm going to tend to work on the subtractive. Because this background isn't that dark though, or because it isn't that light, we get a few spots of really, really bright light where the sun is reflecting and being bounced around inside this glass. So let's just go quickly and demonstrate how I'd attack a problem like this. Maybe we should use something from the last lecture. And let's kind of get these two things to line up as much as I can. Alright, let's duplicate this layer and paint kind of that reverse image thing that I was talking about before. Turn on preserve transparency. I don't know why that's orange. Red might be a little bit better. Okay. Move that over some other stuff so we can see what's going on in the transparency. Alright. Now, let's turn the reflection way down. And let's duplicate it, and this time just do something that's more of a lighten, because again we're dealing with exposure issues where the darks are going to bottom out a lot faster than the lights, and so we're going to keep the brighter side of things a little bit more. And let's go ahead and duplicate that one more time, and this time we'll just erase everything except the highlight. Oops. And I'll turn this a lot darker. So those reflections should really be pretty soft, except for the specular reflection. Unless, of course, it just depends on the surface. Some surfaces are going to be more reflective than others. And I probably should have painted in or erased away some stuff in the middle just to get the Fresnel effect. Well, let's just do it now. And let's do much. Whoa. That's not the one I meant. Oops. That's not the one I thought. Let's duplicate that one instead and make it much brighter and just erase away the outside. Again, this is just attempting to get the Fresnel reflection around the outside edge a little bit stronger because it's going to be exponential towards that outside. You have to have a lot of patience for stuff like this. Just, don't feel like you got to rush it, or you're going to get frustrated really quickly. I find myself all the time wanting to do things like this quickly, and sometimes it works okay to just kind of do a shorthand version of whatever I'm doing, but it's better to not try and push it. Okay, so in this case I'm just gonna, instead of having that reverse image version of the ball, I'm gonna do something that's like a little bit in between the two. And let's see, what else do we need? Now I need to collapse those two together. Oh. And let's duplicate it one more time, actually. And we'll do that darkening that we see around the edges. Oops. On a separate layer. See, I'm doing this underneath the reflection now. If I was really smart, I'd erase those other layers so that I could see what I'm doing, but I'm not, so I won't. Alright, I'll turn that down a bit. And now, same type of thing here. We've got a little bit more density around the edges. And so it's going to be most transparent right in the center. That's the place where the eye is going to, or where the light is having the easiest time passing through. Probably went too far with that. Let's back up a little bit. So, it's starting to look pretty good, except we're missing something. There's still something strange about it. And we'll talk about what needs to be going on a little bit more to make it really look good later. Let's move on to the next section. Talk a little bit about subsurface scattering. So, you can see here this fish near the surface of the water is pretty clear. You can see very clearly right at the head. Gets a little bit less clear as it's going down deeper, and then it gets very, very fuzzy pretty quickly. This fish here is pretty fuzzy, and that one's just kind of a orange blob in the water. This is called subsurface scattering, and it happens in a lot of ways in a lot of cases. What subsurface scattering is it's a type of transparency where the light comes into the object but is scattered by the molecules or atoms in the object, so that what comes out the opposite end is not an image of what you saw coming into the object, but is just kind of a general approximation of the light that came in the other end. And generally speaking, the denser an object is, the more atoms there are, the less subsurface scattering there is, and the of course, less dense that it is. When everything's all spaced out, it's going to have a much easier time for the light to pass through. There are other things that allow subsurface scattering. Actually, this is true of subsurface scattering and transparency, and that's the stuff that we talked about before, where, oops, wrong pen, where you've got the low energy or the low reactivity type of atoms that just let the light pass through. So you can get stuff that'll allow light to pass through that that is still kind of dense, but generally speaking, those are exceptions. So let's compare this to, there's a sphere with Lambertian reflection with the light coming in, and we've got the specular reflection, we've got the exposure effects where it's kind of desaturated and brighter up here, and as it goes down we actually go around that curve. Remember the Fortean curve, so it curves around that surface. We get that kind of movement out into the saturation. That's just kind of a natural response of, this is maybe the true color of the object, and that's the exposed version of that color. In this case, we get the same type of curve with subsurface scattering, and I overdid it in these examples just to really show that it can happen. Actually, wax does work in this way if you get the right kind of light on it. But you can see we follow the same curve in this case, but it maybe goes a little bit deeper in the saturation, and the curve actually goes past the terminus, or the light that's coming out will go past the terminus. Usually it doesn't go this far, as I was saying. Let's see, where's the example? So in most cases you'll just have a little tiny bit of subsurface scattering right on the edges, but for the most part you're not getting subsurface scattering. Hopefully this will make you hungry. Again, a little bit of subsurface scattering there, but for the most part not a whole lot going on here. And of course different surfaces are going to respond differently. You know, this chocolate on top is getting just only a tiny bit of subsurface scattering right along that edge, but the caramel just underneath, actually quite a bit of light scattering through it, and actually quite a bit through the cookie also, although I think that's just that corner. It's not, well, actually there is a bit coming through there also, but you can see how deep those colors, the light is coming through there. Oh yeah, here's the candle. So this is hard to tell with this photo, but that entire section is lit up by subsurface scattering. Probably should have put a wide object here so that you could really see it. You can especially see it up top here, but you can also see, like I was talking about, that extra thing that goes past the terminus. We've got the terminus of light here. We've actually got a pretty strong saturation of the colors there. Whoops. Saturation of the colors there from the light as it goes into the shadow. We'll come back to this example in a second. Let's talk about one other thing that happens with subsurface scattering. That is, the light changes color for multiple reasons as it passes through a solid. Of course, you've got whatever the color the molecules and things like that are underneath the surface, that's going to color the light as it comes through, just naturally. That's should go without saying. But there's another thing going on here, because that light is quite blue, and the light that's coming out underneath it is kind of more of a yellowish green, and I don't know that these leaves are necessarily that yellowish green. And I believe there's another phenomenon going on here, which, going back to our quantum principles of light and how it relates to the wavelengths. So blue is short wavelength, right? I've talked about that before. On the blue end of the spectrum, short wavelength. On the red end of the spectrum, long wavelength. That's probably not a good area to draw from, because you can't really tell the difference here. Oh, it's because they're shorter here. I must have been using a bad brush for that part. They do actually seem wider there. So from that peak to that peak, quite long. From that peak to that peak, quite short. So the way that things tend to work is the shorter the wavelength, the higher the probability that it's going to interact with the atoms. So a good way to remember this is if you try and shoot X-rays through something, X-rays have a very, very high wavelength, and they tend to pass through the skin just because they're such high energy things, but as soon as they reach the bone, they stop. And that's why we're able to have X-rays work, because it shows your bone on there. But the light is passing through for the sake of, or passing right through your skin. Whereas radio waves and X-rays and radio waves are all, they're actually just colors of light that we can't see. So we've got on the rainbow, blue, and I guess this is the red end of the spectrum, and then we've got the violet end of the spectrum with blue next to it. So ultraviolet light, X-rays are all on this part of the spectrum, and radio waves and infrared are all on this side of the spectrum. So with radio waves, they tend to be very long wavelength, and because of that, they're able to pass through the walls of your house, through their car, everything like that, and get you the signal that you need. So with light passing through a solid like that, that increased probability of interaction means that we lose the cooler end of the spectrum, or I guess I shouldn't say cooler end of the spectrum. We tend to lose stuff towards this end of the spectrum. And so everything that comes out tends to be skewed this direction towards the red. So if that's the blue end of the spectrum, everything is going to be trending this way around the color wheel as it passes through a solid. Hopefully that's clear enough. Show a couple of quick examples. So this one we talked about, we have the cooler upper side of the leaves. This is pretty cool light. We have an overcast sky here, and what's coming out underneath is quite a bit warmer. See how it rolls that direction? So we're here on the spectrum, then on the underside of the leaf, we're on that part of the spectrum. It doesn't have to be extreme to be accurate. Same type of thing going on here for the ice cream. We've got fairly cool light coming in from a window still. Tends to be pretty cool, pretty white, kind of roaming around this end of the spectrum. And then you'll see even on the shadow side, it's a little bit warmer, and we tend to be on this part of the spectrum, but look how much more saturated and warm it is right here in the place where the light is passing through. So kind of cooler. I'm also looking, by the way, if you don't see the rolling here, there's a change in saturation that you're seeing. It jumps up in saturation, and that also makes it warmer because it's a warm color. If you're using warm colors, going desaturated tends to look very cool, and if you're using cool colors, then desaturated colors tend to look warm, just as a general rule. So remember that, probably need to be useful. And you can kind of see it in these examples too, how you've got the caramel color, and then the light that's passing through is quite a bit warmer than that. You've got the cookie color, then the light that's passing through is quite a bit warmer. A little bit harder to tell with the water. Alright. And one last thing before we go on to paint examples. You can have density variations in your solid, like, you know, we've got the little veins here tend to be a little bit thicker, and that allows the light to pass through the centers but not as much around these things. that tends to be a good trick for describing subsurface scattering. Is you know, your form's going to tend to have like little bumps. You know, if you're doing an ear or something like that, there's areas that are thicker and areas that are thinner where the light passes through more easily. And if you have an object that's very transparent with subsurface scattering, you can actually have the light pass through into the shadows. So see how colorful this shadow is? That's the light from the sky, but all of this light is from that ball. That ball kind of becomes a light source for the shadows because of the subsurface scattering. So how do I paint in subsurface scattering? If I was going to paint a candle next to this one, and we'll kind of pick a color that doesn't have as much subsurface scattering going on in it. I'll start with something that has kind of soft edges, or I'm not going to worry too much about my edges on this one. So, create a new layer, and we'll get that highlight color. Generally speaking, when I pick a color, I'll modify it, because if you just are picking colors up from a photo or from other parts of your piece, you're gonna end up with very dead colors. They're not, and especially this is important when you're painting surfaces in light, because things tend to gray out as you're painting. The colors kind of mix together again, so you just kind of want to push things back a little bit more towards the color that you want. You'll get, as you get more experience, you'll get a better idea of how that works. So right now I'm just painting the diffuse reflection on the candle. I'm not worrying about subsurface scattering. I'm just worried about where's the terminus, what's the rate of fall off, and really I could paint in the specular stuff on top of this if I want. Paint in exposure effects, stuff like that. But you can see already, I mean, even if I brighten up this shadow, it still doesn't look like that candle. And a lot of that is going to be, you know, even if I painted in some kind of natural looking exposure effects here, it's still not going to do the trick. So what I'm going to do is I'm going to paint underneath this surface. I'm going to create a new layer, and this time I'm going to paint that candle in all the areas where the light is hitting. Same type of thing as before, but now I'm going to make it so that there's kind of the soft fall off from that light source. Generally speaking, with subsurface scattering, you lose a lot of light once you get out of the lit area. So all of this light is passing through the surface, even though you can't see it because the diffuse reflection is on top of it. But see how already with that underneath the surface, it kind of makes that thing glow. It looks like the light is really passing through. In fact, this almost looks more like a candle than that does because of the way the light passes through. Must be an especially dense candle. Probably gone a little bit too far with this, but I think the idea and the principle holds true. And generally speaking, the light coming from subsurface scattering is a lot darker than the light that's coming from any other part of the object. So I'm going to dim that down quite a bit. So it's pretty simple painting in subsurface scattering, and you can fake a lot of things and have it look pretty good. But again, I'm trending everything towards the warms in the shadows where the subsurface scattering is affecting things. hopefully that sells my idea. And we'll move on. Actually, before I do, let's just talk a little bit about those density variations. So let's make a veiny candle. It's kind of odd. All right. And depending on, you know, if it was blood in those veins, I'd probably put a little bit of red in there, but I don't know. That's kind of weird. I'll do about half that. And of course, the deeper into the surface those veins go, the softer they're going to get. So you're going to end up with close to the surface stuff that tends to be a little bit more, a little bit stronger, a little bit easier to read, and then it's just going to fade out as it goes deeper into the candle. Okay, moving on. Okay, let's see. All right, what we're going to talk about next is refraction and caustics. Refraction is kind of a difficult thing to understand. In fact, the explanation of why it works or why it happens might not necessarily make a lot of sense, but I'd say don't worry about that. Just worry about the behavior and what you should be seeing, and everything will make sense just fine. So what refraction is refraction is actually similar. It works on the same principle as, or it works as part of the Fresnel equations that we talked about, where depending on the angle that the light hits the surface, you get more reflectivity versus less reflectivity, right? So if you've got that same surface, you've also got an interaction of what happens as the light passes through the surface. So depending on what the angle of the light is coming into it, you actually get more bending depending, or based on the angle of the light. So trying to think of a better way to describe that. So let's say this is the boundary between air and water. If you've got light coming in from straight up and down, then it tends to go straight up and down through the water. But if you change that angle at all, even just a little bit, you get a little bit of bending in that. And the bending tends to be, you tend to get more of an angle in the air than you do in the water. And that's because the light is slowing down. So think, this is a good way to remember. If the medium is more dense, then it makes that, oops, that doesn't read very well. That's supposed to be an equal sign. If the medium is dense, then the light goes slow. And if it's not dense, then it tends to go fast. So if this is air and this is water, the light goes very fast through air and it slows down in water. And that slowing causes it to bend. I'm not going to bother to explain why that happens because it's kind of complicated, but it's just trust me that that's what happens. And the higher that angle is, the greater the difference. So in this case, the angles are fairly close to each other. You know, it's similar to the angle it came in as, whereas as this angle becomes greater and greater, or as this angle becomes lesser and lesser, then this angle actually, it gets even, what's a good way to describe it? Like, there's a bigger difference between this angle and this angle than there was here. So that your original trajectory here, that's probably a better way of describing it. So in this case, there's very little change in angle, whereas in this case there's a lot more of a change in angle. And when the light is really coming in at this angle, then you get quite a big change in angle compared to where it should be going. That's probably a better way of describing it. Let's erase all those diagrams so you can read this other one. So because of that bending, you can get all sorts of crazy effects that happen with it, such as if you have a circular surface or a lens surface, depending on the distance from the viewer, you can actually reverse the image that you're seeing. So if this one is a ball and that's a block, then what the viewer will see in this ball or in this sphere, in the reflection, they're going to see the block on top and the ball on bottom. It's going to be a reversal of that image because of the way that the light is bouncing through. Now that reversal isn't always going to happen, but that's the extreme case. You can kind of see that type of thing going on here, where those flowers that you see right there, there they are. It's bouncing through that medium. Same type of thing going on here. There's the top of the label on the other side of the bottle. The label is probably right there, but where do you see it? Right there. And it ends down there. Again, going off of that same principle that we had before, where because of the angle of light that we're looking at here, that we're getting some bending, which I guess I won't bother to explain the angle because it's kind of hard to tell from this angle anyway. But just remember, general rule, the more extreme the angle is of the light going into the surface, or the more extreme your viewing angle is of that thing, the more affected that the angle change will be. I feel like I'm being redundant, but I think I need to be, because it really needs to, in order to remember it, you really need to hear it again and again. Alright, so here's another example. There's glass distortion filters and stuff like that in both Painter and Photoshop that kind of simulate this idea, but they're not going to deal with the form issue, or the factor of the form here. So we've got a denser, more curved glass on this side, so we get more distortion in that area. And even though there's a texture all the way around, you get more distortion there and less distortion there. Okay, caustics. Caustics is basically, if we were to replace this icon here, with instead a light source here. So this is the sun. What happens is the sun's light comes into this sphere, it gets refocused down to a smaller or single point. So if you've got the light source on the other side, you can expect to see, as the light comes down, it's actually going to focus the light through the sphere down to a single point, or not necessarily to a single point. The light's going to be all like bending different ways, but there'll be a focal point where that becomes a very dense bit of light, and then the rest of it will be kind of a dark shadow cast by it. And as you take that ball farther and farther away from that surface, like if it's out here, you'll still get the dark shadow, but the caustics will be kind of this bigger, larger thing. So caustics, exact same phenomenon as refraction. You can see an example of it here. The sunlight is coming into the bottle full of water, and it's being focused down to that small point. And you can see what I described here. This actually, oh, and another thing is the density of that medium, or how, so in this case it's full of water. This cup is not full of water. So this is going to tend to bend the light more because of that than this will. The light is being bent by the glass here, but it's only being bent a little bit. Whereas here the light is really being bent by that whole medium that the light has to pass through. So you can see in this case the caustics are a little bit more spread out. You can see caustic effect there, little faint ones there and there, just coming through the light, or coming through that glass. You can see a stronger one here though. It's kind of interesting. You can see a lot of light passing through there. That's just natural transparency of the glass. But down here, you don't see much light passing through because it's so thick there. But you are getting a lot of that light focused down to a very small area. And this works even with subsurface scattering if you've got a very, well, I guess subsurface scattering isn't a good way to describe it. Even if you've got a very diffused light passing through, like you would have with subsurface scattering, if your material is, I guess, what's the opposite of dense? Not dense enough, then the light will do the exact same thing. So even though this ball, you can't really see through it, it's not a transparent ball in the same way, you still have a caustic effect. But instead of being a focused kind of, I don't know, the light kind of flaring out everywhere because of the lines in that thing, it ends up being this kind of general softer effect. I put in these multiple images here so you could see a little bit of what we talked about on the other thing, where here you actually see some lightning on that lower end. That's a combination of the caustic effect and a combination of the fact that, you know, we have our terminus on this ball here, but it's really soft. You have a hard time even seeing it. The lit side of things, you mostly just see the specular effect. But the light is passing through the ball and lighting that opposite side. But then in addition, you're getting that caustic effect. And so the overall impression that you get of the ball is that it's darker up here and lighter down here. You'll see a lot of people kind of use that cheat a lot. You know, they'll put a little highlight there and then they'll kind of lighten the bottom of the ball to make something look transparent. In this case, you've actually got a combination of effects. So if you really want it to look real, you can actually layer that stuff on top of each other, like we were talking about before. And in this case, it's more like a combination of the two effects, kind of like I demonstrated here, where it ends up being more of a flat thing with the light coming in from the side. So the ball doesn't have as strong of an effect like this one does. But you do have a little bit of lighting that end, and because of the way that the light scatters through this ball, you can't see that as easily anymore, even though it's still there. Then of course, you've got a larger, in this case, it's a larger light source. This is a window with light kind of coming in from lots of spaces. So in that case, we still get that caustic effect, but notice how this one's kind of focused down. This one is very general and broad. You can still see the blue light kind of shining all around in that fur. So caustics are really handy for making glass. Both caustics and refraction are very handy for making glass. And again, this is something that I would deal with in layers. So let's go back to our example that we were painting here. Whoops, not there. And in this case, I just wanted the sphere. I don't necessarily need it. I'm just going to select the layer transparency, go down to the canvas, pick up what's there, and actually realistically I shouldn't even pick up what's there. What I should do, because again it's focusing all of the light into our eye from kind of a larger area, so I'm going to grab the light from a larger area, or the stuff that's going on from a larger area, and we're going to scale that down. And we'll flip it horizontal, and flip it vertical because of the reversal image, the reversal of the image thing that we talked about before. And now I'm just going to use a quick warp, but you can actually, paint this in or do whatever you want for how the surface is distorting the ball. I mean, how the ball's surface is distorting what's going on in the background. Let's see, where was that? Quick warp. And I'm not sure which one of these will work. Probably any of them, really. Let's just see what happens with each of them. With caustics, or with refraction, I wouldn't worry too much about getting perfect accuracy with stuff, just because it's too difficult to predict in every case. I've been encouraging you through these lectures to think about what's going on in the three-dimensional space and how things are bouncing around, but with refraction it just gets very, very complicated too quickly. And that wasn't quite right. But if you want to learn, all the power to you, go for it. Since we can't really see what's going on around the edges of this, anyway. That's not too bad. I actually think that's looking alright. Alright. Actually, just to clarify, I said that it's too complicated to worry too much about it, but I'm only talking about in cases where it's very difficult to plan exactly what's going to be happen with your scene, with when you've got something that's reversed and stuff. But if it's a simpler case like this, where you've got a single line in the background, don't just fake it in that case, actually try and figure it out, because it's pretty simple. It's going to look better if you do it right. It's only in cases where there's too much planning to actually get it right. And I'm still not sure that that's working exactly the way that I want it to. But I think you can get away with something like that better than you could in the case of like the glass. I'm just going to do one more quick warp. Yeah, for some reason, something a little bit more warped seems better to me. It seems like it's stretching around the sphere a little bit better. Select the layer transparency, invert it, and cut out what's going on there. Alright, so there we got it. And moving on. Alright, we talked about everything here. Alright. Color shifts. Painter's starting to chug here. Alright. So there are a couple of things that cause color changes with transparency. One of them is called chromatic aberrations, or chromatic aberration. Basically what it is when you have white light, well, really this would happen with any light, but white light is the easy case to look at. So as you have white light come in, the lens or whatever the medium is that it's going through is going to, in certain cases, depending on what the medium is, it's going to split apart the colors of light just slightly. So I just did red and blue here so that you could see the splitting. And usually it's not a huge effect, but you can see it in a lot of things. You know, if you have like the energy efficient windows, you can see it, a slight amount of chromatic aberration through them, especially in reflections. You can see it through water, like we see in this case. So we have a slight amount of a blue edge here and a slight amount of a red edge here, or not red, but slightly trended towards that end of the spectrum. And that's true all over the piece, and that's because of the angle that I took this picture looking down into the water. The angle through those mediums caused that color split to happen. And just like with Fresnel refraction, as the light, as the angle of light or the angle of view increases, that split between the red and the blue, or whatever the colors are in the spectrum, is going to increase. So what this results in, if you take it far enough, is what we are familiar with as a rainbow. With a rainbow, it's a little bit different because it's individual water droplets that are scattering out a field of color, and what we see forms itself into a rainbow based on all of those many droplets. But the principle is the same, that the individual droplets are actually splitting up the spectrum of light, and this happens all the time. And it also happens in mirrors. So if you're trying to paint a room and somebody's looking in a mirror at an angle and you really want to sell that that's a mirror, put a little bit of chromatic aberration in that mirror, splitting along the axis of the view. So in this case, if we're looking at the camera, or if we're looking in on the scene like that, then the red and blue split is going to be that way. All right, last thing. Let's talk about iridescence. Iridescence is a bit different from chromatic aberration. In fact, it's completely different. So light as a wave, let's go to this example here. There we go. So light has a wave, or light is a wave. So it's got peaks, it's got troughs. Just like any other wave, like if you were in the ocean and you sent one wave going one direction and you sent a wave going another, if those two waves lined up, well, doing just exactly the opposite of what I want. So what's going to happen is the waves are going to tend to work together. So if this trough and this trough line up, then you're going to have an extra low trough, and if these two peaks line up, then you have an extra high peak. But conversely, if you've got two waves together, so in that case I was grouping these two waves together, if you have these two waves together, then what's going to happen is this trough and this peak, they're going to cancel themselves out. So those two peaks, or since this is a peak and this is a trough, sorry, since this is a trough here and that's a peak there and that's a peak there and that's a trough there, they're going to cancel each other out, and it's just going to become a flat line. Or in other words, it's going to become, if it was a sound wave, it would cancel it out. This is how sound canceling headphones work. With light, it cancels the light out, but it only cancels out the specific frequencies or the specific wavelengths of light that are being phased. That's when it gets shifted, it's called phased. It's called phasing. Well, I don't know if it's called phasing, but we'll pretend that it is. So what happens when you've got a thin film of liquid, or I guess just a thin film of any transparent thing, if it's the right thickness and it's reflective on the backside, then what's going to happen is you're going to have cases in which the wavelength of the light matches up with itself as it bounces in and back out again. So here's the light coming in, and here's what happens when the light comes in and goes out. See how we have that canceling issue again? But it's only going to happen as long as that surface is the right wavelength to cancel out that light. As soon as it goes a little bit further, then you're going to need light of a different wavelength to cancel out along that edge. So again, remember, thin films, and it could be a thin film floating in air like a bubble. So you'll notice how there's the purples and the yellows and the blues and then the greens here. And it's basically just the reflection. You know, this is reflecting the trees in the background and other stuff like that, and the sky, but you're getting a lot of color shifts in that because of the iridescent quality of it. So when you're painting this, what I did is I started with a standard reflection, and I did the same type of things you'd do to create that Fresnel effect, with the brighter on the edges and darker or less opaque in the center. In this case, it would be opacity because it's a transparent bubble. And then I just, well, let's just do it real quick. I won't even worry about getting the sphere exactly right. So I think what I did in this case is I did a selection based on the value. And then if we fill it with white, you can kind of get a feel for that, which looks like my selection needs to be reversed. Okay, guess I need to pick it up again. So I did something wrong there. Let's do auto select inverted this time. That should be better. That looks more correct. And now I fill it with white first. And we'll keep the colors on it just so that we can use those to shift things in the end. And now it almost doesn't matter what order you put them in, although it should probably with a soap bubble anyway, because what's happening with a soap bubble is you're getting different thicknesses of film just throughout the bubble. So it's not a single layer or a single thickness in film all the way across. Like this part of the bubble is maybe a little bit thicker, this part's a little bit thinner, and so because of that it's just a little bit more random. I'm probably not going to get perfect results right now because I spent a bit of time on it before getting everything to work, but doesn't hurt to try anyway. And I'm going around the center, but you don't, with a soap bubble, you wouldn't necessarily need to do that. You would want to probably shift to a consistent or a more consistent color around the outside edges. I'm just going to fade it so we kind of get a combination of the two. So you can see I'm already on the path to where I was going. I didn't get the Fresnel effect stuff going on here, but you can kind of see where we went with that. And it has various applications. Basically, anytime you want to make something look slimy, and part of this is just because of the way that water versus like slime tends to, if you get something wet, it tends to, let's draw this, it tends to beat up on the surface if it's water, because water has a specific surface tension, whereas if the water is mixed in with something else like soap, or if it's some other slimier material, then it may actually be able to create a very thin film, a much thinner film, and hold together. And so because of that, there's a lot of cases where you'll want something to look either slimy or look like it's got a bit of opalescence or something like that. And even if it's just a subdued version of it, in this case you've just got green and red, it'll look nice. So the thing about iridescence is that it's going to change based on the viewer angle. So if we looked at these beetles from the side, the planes faced towards us would be red. And if we were looking at it from the side, the back would probably be green, just like this stuff here. It's going to change because same type of thing as what we've talked about here, except now you've got a viewer in the mix. So light's going in, it's bouncing off that surface and coming back to the viewer, and it's because of the wavelength as it goes through that is what's causing it to cancel out as it goes through that angle. And I think that's all there is about iridescence. Let's talk about the assignment now. So here's the assignment. It's going to be a layered file again. What I want is to see, using a fairly typical light scene, so this should be daylight type of thing, blue fill light or semi-blue fill light or cooler fill light, and then a quite warm, very bright sunlight in the background. So this should be your key light, it should be very bright, and then maybe a very soft, cooler light, just kind of generally overhead like you'd have with the sky. And then I want you to deal with these things each with differing levels of, with the different attributes of transparency or the translucency that we talked about today. So this one should be transparent, mostly, with maybe a little bit of, a tiny bit of refractive qualities. This should be glass. Try to make it as accurate as possible. This should be a liquid in the glass. We should see caustic effects from at least these two, probably. And then I want this to look like a bunch of grapes. I didn't put anything in like to make it look more like grapes, like a vine or anything. If you want to add in a leaf there and do subsurface scattering on that as well, that would be nice. It would probably make the image look nice, but it's not necessary. So subsurface scattering, glass, liquid, caustics, and transparency. And I think this should be a really fun assignment, and I look forward to seeing what you do with it. Thanks. Welcome to Lesson 5. This lesson is going to be on hair, different types of hair, and other deep textures. We've been talking in most of the lessons about general types of material, general principles of material and light. We're going to start moving into some more specifics, and obviously we're not going to be able to cover every type of material, but with the things that we were talking about, plus the general principles that we talked about in previous lessons, we should cover anything, so that if you ever run into a new material, you should be able to mix these things together to create the types of effects and appearance that you want. So going back to Lesson 1, this will be familiar. We talked about Lambertian reflection and how texture affects it just a little bit. We didn't talk very much about deep texture. Deep texture is a little bit different than just any standard texture, because when you get really deep texture, you start to have stuff like occlusion effects, the way that the light is bouncing off of the edge can actually spread your texture or spread your highlight, your diffuse highlight, along that edge. So as the texture gets deeper and deeper, the material starts to look more and more flat overall. And of course, you're going to get other things like if you have individual things poking out, they're going to cast shadows and other things like that. A lot of that you can just figure out as you go, but some general principles in how those things work are going to be important for this lesson, because hair is really just a deep texture. So you can see one of the things that I talked about already on this unripe apricot. So you can see how as the light hits this thing, it's glinting off of these little tiny hairs on it, and it's actually catching on hairs that are past the edge of the diffuse highlight. You can see how that's where the terminator is, but you actually have light catching on stuff that's further away from it. You can see the exact same thing here on the giraffe. And of course on both of these you're going to have occlusion effects, but in both of these cases, occlusion and shadow casting effects within the texture. So it's a little bit hard to tell in these pictures, but there is some shadow casting of the hairs casting on each other, but the biggest thing is how the texture is interacting at this point. So all of hair, whether it's fur, hair, fuzz, stuff like that, is going to all be based on some basic things. So this is all of these 7 things here are the types of things that you want to have decided or have in mind when you're painting something that has hair or fur of any type. Obviously, the length of it, whether it's long or short, the thickness of it, whether you've got thin hairs, are going to behave differently than thick hairs. The shape of the hairs, this is on a microscopic level, whether they're smooth or whether they have barbs or other things like that. There's all sorts of different kinds of shapes. And of course, all of these things apply to not just hairs, but other types of deep texture. So specularity, so I talked about with this, the little like light glinting off of these things, there's a specular property to those hairs. Most hairs, there is some kind of specular property to them. Hair is made out of the same type of protein, keratin, that fingernails are, and you can see if you kind of move your fingers around, your fingernails will be more reflective than your hand is in most cases, and so that's the same type of thing that your hair is made out of, except usually it's a little bit shinier. Then translucency, that's just the hair itself. If we were to look at it up close, light will go into the hair, and sometimes it'll actually bounce out of the hair, other times it'll just pass through. Shadow, we've got 2 types of shadow, of course, that we've talked about. We've got hairs here. There's cast shadow if light source is here, and then you've got occlusion shadow where it's getting deeper and darker, where it's deep down to the base of the hairs. Then color, and we'll talk more about that in a second. Okay, first type of hair is fuzziness. So here's those apricots again, and you can see the hairs, because I'm up really close, you can see the individual hairs, but most of the time when you're painting something that's got a little bit of fuzz to it, you're not actually going to see the individual hairs. You're just going to be seeing the effect that it has from a distance. So the dominant factor on fuzziness is going to be the distance and density of the hairs, the distance of each hair, or the hairs from each other, basically. So here's an eye here looking at a surface that has some fuzz on it, and you can see where the planes of the surface are facing towards the eye, there's a lot of space between those little individual hairs. And usually with fuzz, this is just referring to very short hairs, and this is where I'll get this phenomenon. But as you're looking more and more towards the edge of this thing, as the surface turns away, those individual hairs, even though they're spaced about the same distance apart, will start to look like they're closer together as they curve around that surface until they become very dense. So you can see here we can see the green very easily on that apricot, and then around the outside edges, see how it starts to turn white or turn to a lighter color. See how it's lighter right around those edges, and it's kind of a soft gradient to the center, but it's actually an exponential increase in density. It'll be very flat and open for a while, and then suddenly you get very dense. And this is true whether you're looking at it in light or in shadow. So here we've got the light coming from behind, so we see that same effect going on the light side, but also here in the shadow, same type of idea. This idea of having features spaced along the curve of a surface, but because of the surface being curved, they appear to get more dense. This is an important phenomenon. It's going to apply to other things, so remember this. There's all sorts of different things. You know, I used examples of fruit, but obviously all sorts of, you know, babies, and actually any person, not just a baby, although it's easiest to see it on a baby. Everybody has little tiny hairs like this all over their skin. Even somebody who's balding, they have the little tiny fluff. They actually haven't lost the hairs up there. The hairs have been replaced by this little tiny fuzz. So even though the hairs are much, much smaller, so much so that you can't really see the individual hairs anymore, you can see the same phenomenon on these raspberries. So it gets lighter right around those outside edges, and yet really clear and easy to see into the center where all the nice, pretty subsurface scattering is going on, giving the berries that kind of jewel-like look. If you're going to paint fuzz like this, usually what you're going to want to do, actually let's get from another one of our images. Just pick up a surface that already has something on it. Oops. Okay, we won't worry too much about the specific edges on that. Alright, so if I wanted to paint this, what I'm going to do is, in this case, I'm just going to duplicate the odd object. Well, actually, let's do it a different way. Let's create a new object. Sorry, not an object, a new selection. Just immediately surrounding this thing. Alright, close enough. And I'll create a new layer, and I'm going to pick a brush that's just got a little bit of texture and a little bit of dot to it. Again, my favorite brush, that captured bristle acrylic. And it almost doesn't matter what color I'm going to use here. In fact, I'm going to use a green just so it's really easy to see what I'm doing. Turn off preserve transparency, and I'm just going to start putting in some just kind of dots for this fuzz, and it can be, I can make it as dense as I want. We'll start off just by making it kind of even all over the whole thing, or I guess we'll make it a little bit uneven, as most things are like that. And then we're going to make it a lot more dense right around that outside edge. I'm just kind of lightly touching the stylus here so that it's creating dots instead of streaks. Now, what I'm going to do is I'm going to erase away what's in the center. And do the shadow side now. I'm going to turn on the preserve transparency now. Switch to different layer type, or to a different brush here. And we'll just turn it back a little bit. And you can see how it's already starting to work, just with what little I've done. And again, I can do this with just about any color that I want. If I want to make it a blue fuzz or something, same idea works. So that's how fuzziness works. Okay, now we're going to talk about short fur. And I put our examples here. Here's a Lambertian reflection sphere. There's one with some fuzz to it. You can see I did that same type of technique to create that. Now you can see I did this one, this painting for short fur. So a new element that's introduced with short fur is that it's going to hang in different directions. Fuzz just kind of generally pokes out all together uniformly, whereas short fur can actually be, and a lot of this will have to do with the thickness of the hairs, and of course how like if a cat has its hackles up, its fur is going to stick out a little bit more, stuff like that. So you can have the hair poking out, or you can have the fur laying down completely, and those are both going to have completely different appearances to them. Another thing that's introduced is clumping. So hairs, even with fairly short fur, will tend to group together, and so instead of getting this uniform soft body, you'll get these kind of like areas where stuff will show up in between, and in those areas you're going to get occlusion shadows to separate and define the separate clumps from each other. So another thing, and this is really similar to what we talked about with fuzz, is when you're looking into the hairs, so let's say that they're standing up, like with this cat, those hairs are going to tend to, when we're looking at them from this distance, or on this angle, we're going to be looking into, or at the shafts of the hair poking out at us, so we're going to be seeing into the depths of in between the hairs, and so it's going to be darker in the center, and then as it curves around the edge of the cat, it's actually going to get more and more dense, and we're not going to see into the hairs so much, and we're going to start seeing a little bit of that fuzz effect right around that outside edge. See that? These images I got off of Wikimedia, if you ever want to get a better look at them. This is an example of what I talked about earlier in full sunlight with this fur. It's just basically that whole highlight, that whole lit side just becomes this big flat shape because of that deep texture effect that I talked about, where it just kind of spreads the highlights a little bit. So whenever you've got a highlight shining on fur, just kind of remember to take your terminator just a little bit further past to the point where you'd normally have it. And of course, pull things down and flatten them out in the highlight area. Another thing, and this is related to that fuzz effect that we talked about, is the color on the hairs themselves may change. So at the base of the hairs it may be white, in the middle of the hair it may be gray, and at the tip of the hair it may be black. And what that's going to do is it's going to create, in fact you can see here on this cat, so see how the tips of those hairs are white and the tips of those hairs are black, but in between you can see it's kind of brown in the centers, or in the middle part of the shaft all the way across the cat, maybe getting a little bit darker in back. But so when you have to paint this, remember our fuzz effect here. So here we're going to be able to see, let's pick a different color. Here we're going to be able to probably be able to see more of both colors, you know, the green and the orange colors. But as you get closer and closer to the edge, you're going to be seeing more and more of the green, because that's what's close to the edge, that increasing density as it curves around the surface. So that's how you illustrate that. If you want to show that there's different colors on the hairs and you don't want to paint the individual hairs, which you can do, it's just a pain. It's a lot of painting. Then you can kind of mix the colors together in the center, and then towards the edges make it so that they show up more of the outside color. So looking at hairs that are laying down. Well, actually, okay, let's go back just really quickly. Something that I didn't talk about. Because of the way that the hairs hang, what we talked about with being able to see into the depths of the hair, that's not always going to happen right at where the planes are facing towards you. So you can see on this example that I painted here, the darkest part on the ball, or the places where we're able to see the best into the heart of the thing, is actually slightly above the center where the planes are tilted up a little bit. And that's because I was imagining this hair is kind of hanging down a little bit. So we're going to be able to see best into those occlusion shadow parts a little bit above where our eye level is. And this is all going to depend on how much the hair is hanging down. So, okay, so for fur that's laying down, you're actually going to get that kind of darkened area that I was talking about earlier, where your eye is looking into the depths of the fur, only it's going to be shifted a little bit higher. And you're also going to get, because of the specular properties of fur or hairs, you're going to get something that we are familiar with. Remember the anisotropic reflection, where if you have a texture that has a direction to it, what it does is it spreads the highlight along perpendicular to the texture, or to the grain of the texture. If you're ever confused about that, just look around your house. There's probably something that's brushed metal there in your kitchen, a pot or pan or doorknobs or something like that, and you'll notice that the texture will go that way and the spreading of the reflection will go the opposite way. So this happens when you have short fur that's flattened down, is you get that because the fur basically becomes a linear texture along that surface. So it's a little bit harder to see on the horse here. You can see a little bit of edges there, but you can really see it here on this dog. See how that specular highlight just spreads all the way up the leg? Same type of thing here. Spreads around the body and down that part of the arm, and then again on the head. And then here, you see the darkening there and there. That's the result of what we talked about, where the hairs are poking out towards us, and so we're seeing down into those hairs and getting a slightly different effect to it. But other than the anisotropic reflection, most of the other lighting effects are going to be really similar to what we have. Not quite as much spreading in the diffuse highlight, just because it's a flatter texture, but you will get a little bit of it. All right, next up, we're going to talk about long fur. So going back to our examples here, here's short fur, here's long fur. Got a couple things going on with long fur. One is the clumping becomes a lot more obvious at this point. So big groups of fur that hang together. Another thing is that the direction or the way that the hair reacts, whether it's from brushing or just moving around or whatever, becomes a lot more pronounced. So, and likewise, all of the effects with the darkening, where you're looking into the depths of the fur, becomes a lot more pronounced. So you can see right here where that fur is parted, we're seeing down into the depths here, it gets really, really dark there. And there are all sorts of different types of fur. It can have a little bit of waviness to it. It can be really ratty. It can still be fairly well kept, or it can lay flat. Oh yeah, and it can be bushy. That's what I was going to say about that one. Or it can be flat. This is a longer hair that is not like the hairs are spread out. Actually, they're little tiny clumps. This is a warthog. So you get like these little clumps of hair that are spread out a little bit. So if I was trying to paint something like this, and this is the same type of thing like with a guy's arm, he'll have hair that's kind of like this too. It's this loose, longer hair. It'll have a direction to it. If you're drawing like the shape of the body, you'd want to think about that density effect as it approaches the curve on the edge, and it would spread more in the centers. So, and of course, you're going to have to think about which direction the hairs are going and stuff like that in that case. But that's something I forgot to talk about earlier, but I think this is really important. With any type of texture, the actual surface, the way that you're handling the lighting and everything is really important, but just equally as important is the silhouette. So you can see even on this low level texture that I put in, I added little chinks and stuff that was just kind of cut out around the edges to make it seem like this sphere. If I just put that effect, that textured effect, on a perfectly smooth sphere, it wouldn't be believable. Same type of thing here. I had to cut into it to get that silhouette to match what we're doing. With something like fuzz, the silhouette is maybe a little bit less important. If you're doing a highly detailed painting, you might have little suggestions of texture around the edges. But as soon as you're getting into short fur, that silhouette becomes essential, getting that fuzzy silhouette. And then with longer fur, you're going to be looking at basically the silhouette is going to give you the character of the fur. And with longer textures like this, the silhouette is actually more important than how you render the fur inside the masses. Just another type of fur. So we'll demonstrate how to paint this in just a minute. Let's move on now. Oh, and I didn't talk about the color of the hairs, but I think it follows the same principles as before, where the colors that are closer to the outside edges are going to show up more around the edges of the forms. So let's move on to human hair. One of the dominant attributes of human hair, especially in long straight hair, is going to be its structure. So there are two things that are going on here. And obviously hair is going to be similar to the long fur that we talked about before as far as what's going on with the textural properties of it. But for the specular highlight, we've got two things. So we've got the shape of the hairs, or the texture caused by the hairs hanging all in a direction. Because humans, they like to brush their hair, generally speaking, and they'll kind of be well kept. What you're going to have is that anisotropic reflection where it spreads along perpendicular to the texture, or the grain of the texture. But you also get a little bit of spreading because of the microscopic texture. It's going to spread a little bit vertically. That's going to be a much less that'll be a less pronounced effect. But then the microscopic structure of the hair is going to cause some interesting things to happen with the highlights, because you've got the light bouncing off of the outside of the hair is going to be bouncing off at a different location because of these little scales in the hair. It's going to be bouncing off lower or farther away from the root of the hair. This direction is the root. When you hear me talk about the root, it's that way. Somewhere back here, it's attaching with the head. So it's going to, that specular highlight is going to be lower. But then, and just to illustrate here, this is where the specular highlight would normally, off of a surface like this, it's going to bounce somewhere about right there, or maybe a little bit higher than that. Let's do... it's going to bounce off somewhere like right there back towards the eye. So you've got two things going on. You've got the highlight that's bouncing off the outside of the hair, then you'll have a highlight that's bouncing off the inside of the hair. The light is actually passing into the hair, bouncing off the back side of the hair, and reaching the eye. Except because the texture now is reversed on the back side of the hair, you're going to have the light bouncing at a different angle. So all of these planes are angled upwards, and that's why it shifts the highlight down, because we've got to wait for longer as we follow the form down before we get to that right angle where it bounces down to the eye. It's the opposite on the inside of the hair, because that angle is so far in that way that it's actually going to bounce closer to the root. So you can see I painted it here. We have a cooler reflection here, or something that's maybe closer to a standard specular reflection, and probably where our regular specular reflection would be, if this is just a ball, it's probably somewhere about right there, about halfway in between, I don't know, somewhere around there. But then that's the regular specular reflection. Then you've got the internal specular reflection right there, and see how it's shifted up. So anytime that you're painting human hair, you want to have away from the root be the true the truer specular reflection, and then you have the internal specular reflection higher than it, or closer to the root. Here's a photo example of it. Maybe a little bit harder to see in this case. Let's move to this one. So see how closer to the root it's warmer, and farther away from the root it's cooler. The sun is coming from behind her back here. And this is going to be true anytime that the sunlight is coming from anywhere that's towards the upper side, it's going to shift this way. If you've got light coming from the underside, it's going to do possibly or potentially something different, except in this case where the hair is actually pulled back. But if the hair is hanging down, you're going to have to light it differently anyway. So under most lighting circumstances, this is how it works. Warmer highlight, cooler highlight, and they're just offset from each other slightly. You can see the same thing there, warmer highlight and cooler highlight. And again, this is going towards the root and not necessarily towards the, any specific direction for the lighting. So even though you can see it here where we have that slightly warmer highlight and the slightly cooler highlight, then we have the slightly cooler highlight and the slightly warmer highlight there, always going back towards the root. With hair that's shorter, you'll have the same effect, but it's happening on a much smaller scale. It's, the individual highlights are kind of spread over a larger area, and so what you'll get is a combination of the warmer and cooler highlights mixed in. And as you'd have with longer fur, the longer hair is going to tend to clump together a little bit, even when it's brushed in most cases, and you'll get these deep occlusion shadows in between. With very light hair, you're going to get, obviously there's less pigment, there's less color in the hair, so you're going to get a lot less of that effect that we talked about with the highlight colors. And also with diffused lighting, where this light is coming from the sky, you just see a lot less of that. You'll get some of those warmer colors coming through the hair, but for the most part you're just getting what the lighting color is averaged over the hair. And with white hair, there's no pigment in the hair, so you don't get any of this effect, other than maybe just a little bit of spreading on the, where a regular highlight would be pretty tight. You're going to have the highlight spread vertically along the hair. Another thing that we haven't talked about with any of the hair yet is that, or any of the fur yet, but is also true for the fur, is subsurface scattering. So we have subsurface scattering that we talked about with the specular reflection, but also if you've just got a light source coming from behind, you're going to get light passing through that hair. With darker hair, Actually, that warm-cool relationship is going to be more pronounced with darker hair. But again, the light of the scene is going to affect how things work. Here you can see the warms are on the underside, because with darker hair, especially if it's shiny, because there's less color in the hair itself, it's going to tend to reflect what's in the environment a lot better. So here we're just getting basically a spread out reflection of what's in the scene mixed with what the hair color is. Obviously how the hair is brushed is going to affect how the lighting interacts with it, especially with how shiny it is. You can see that hair is quite shiny. With different ethnicities, you're going to get slightly different hair types and shapes. Mostly it's all working on the same principles though, and it's just kind of spreading throughout. With all of these though, something that we have to deal with a lot more with hair that you usually don't need to with fur is the transition to the skin. Generally speaking, hair doesn't just end suddenly. It tends to kind of fade out and get thinner as it gets closer to the edges. And this is true even for people who have thick hair. There's kind of a transition area. Unless, of course, that hair is hanging over everything, hanging over what's there. Yeah, again, you can see the transition area. Individual hair colors may be varied, especially for someone who's got graying hair. You can see here we have the darker hair intermingled with the lighter strands of hair. And generally speaking, when you're painting hair, you don't want to paint individual hairs. What you want to do is you want to paint the overall shape of it, the larger mass of it, and then when you're done with that, maybe throw in some suggestions of hairs. And you can always use a brush that's got some texture and direction to it as you're painting it that will help give a little bit more suggestion, but we'll show more of that in a minute. I don't remember why I put this guy's hair in there other than that his hair is awesome. Okay, we'll talk a little bit about feathers, because feathers are going to have some similarities to hairs, and they're also going to have some differences. Birds, well, let's go down to the structure of a feather first. First of all, feathers tend to be very rigid. They've got this shaft that goes right down the center that tends to make them very, even though they have some flexibility to them, their overall behavior tends to be pretty rigid. They also have, towards the end, this much cleaner, flatter appearance, and then towards the base you start to get this sort of downy, softer type of, I don't know what you call them, fronds. So because the feathers are so rigid, they're going to tend to reflect a lot of what's going on with the bird underneath. So if the bird's moving or hunching its shoulders, or and they also have control over, they can make their feathers poke out, or they can pull them in so that they're flat, and they can do it in variable ways. Like this parrot here is making the feathers around its neck kind of jut out, but all the feathers on its wings are kind of laying flat and down towards the lower part of its body. But it can control these so that they poke out also if it wants to. I'm not sure how much control or how they control it, but the thing about hairs, though, or about feathers as opposed to hairs, though, is because they have this sort of scale-like shape to them. Instead of dealing with the clumps of hair, what you want to deal with when you're doing your occlusion shadows and stuff is you're dealing with that overall shape of the hair. You're catching those occlusion shadows down in the base of those things. Obviously, if the hairs are laying flat, if the feathers are laying flat, you don't need to worry about that. But if they're standing up, all of the same principles we've talked about before. See how these feathers are poking out towards us, and because of that we can see down into the deep parts of them. And then towards these edges, the outer edges, we can't see down into the depths of them, so it tends to look very, a lot flatter, more similar to the rest of the bird. But all of the details of it are kind of made into these larger scale-like shapes, but with a little bit of softness to the edges to them. The type of coloring that feathers can have can be pretty wild in comparison to fur. Animals will have like interesting colors to their fur and stuff, but feathers for some reason just are all over the place. And you get different types of sheen. You get soft, downy, fluffy feathers, and then you get these really shiny ones that have iridescent reflection on them. But the other thing that's important to note with feathers is look at how many different shapes of feather there are just on this one bird. We have these rounder ended feathers. We have these kind of fluffier, long, thin ones. We have these smaller, kind of interesting ones. We have these softer, they're almost like hairy feathers. And then, of course, these long plumes that are kind of rattier looking. And then these kind of triangular ones. So shape is going to be a big thing. Also, the color on the individual shapes of the feathers is going to be important. So here the shaft of the feather is that sort of white, and then it's brown in the center, and then towards the outside of the feather it gets white again. And because of that, we end up with this pattern all around the bird. If you're going to do something like this, you can actually do it by creating a pattern. It just depends on how much you care about the specifics of things. You can probably paint something generally and just get an average of that effect, and most people will be okay with it. But if you really want to give the effect of kind of the vibrancy and interest that feathers have, you may want to actually create a pattern, or even use a photo overlay to create your feathers, or at least as a base to create your feathers. These are ostrich feathers. You can see how different than they are from the others. They are just really separated, almost hair-like, more like fur. And then these ones just look like scales with kind of light ends to them. I talked a little bit about that downy part on the end, and different types of feathers on different parts of the body will have like a longer shaft, and some will have a shorter, and so that down may actually be a higher percentage of the feather, like it is here on the face of this bird, where you can actually see that white down kind of poking through where his feathers are jutting out. This is another example of how wild the coloring can get. I think this is a type of peacock, but you have those little tiny speckles, and then on the end of each feather. And because feathers tend to be a little bit more spread out over the body, they can actually get away with stuff like this, where you can see individual dots on the end of each feather. With something like fur, that type of color change wouldn't be as obvious on the individual hairs. So then the last thing with feathers is the specular reflectivity of it. They tend to be very reflective, at least on the ends towards this part. And also, a lot of feathers tend to have that iridescent quality to them. Remember, with iridescence, we have anytime you've got a thin film where it's like, whether it's a greasy film or whatever, it doesn't usually happen with water. But anytime you have something that's a greasier type of finish or a slimier type of finish, or if it's like a gloss, like some type of like glossy paint or material, or I don't know what it is on the feathers, but something that causes the light to cancel out certain colors as it bounces back to the eye. That's what's happening here. So we're getting some reds up here, we're getting some greens down here, all sorts of interesting colors just on that turkey. And look at how different these feathers are. They're all kind of square on this bird. So this is the type of thing where you want to study a lot from life, or if you don't have access to a lot of things, you can study a lot from photos and gathering reference from the internet, because this is the type of thing where before I'd seen this picture of this turkey, there's no way that I would try and do a square feather, and I don't think I would have thought to do iridescent reflections on the feather, and I don't know if I would have even thought of all these different patterns and textures in it. But once you see it, it's in your head, especially if you've studied it, you've tried to paint it, it's going to drill itself deep into your brain, and it's going to come out sometime. Maybe you have to draw some type of mythological bird or something like that, and suddenly all of this knowledge that you've got in your brain about feathers is going to come out, and it's going to become really valuable to you. Okay, so I think that's all about the deep textures. There are other types of deep texture, but these are probably the most common ones that you're going to run into. When you're, if you're doing like toys or something that has a type of synthetic fur on it, it's going to behave a lot the same. They generally tend to be a lot cleaner in the way that the fur or hairs come out, and we don't have some of these effects. Like the hairs tend to be very uniform. They're not going to have the reflection stuff that we talked about, and sometimes they won't even have very much internal reflection or internal subsurface scattering, so it'll actually be like a pretty the light won't pass through it very much. So let's talk a little bit about the assignment. I'm going to give you kind of a Muppet monster to paint hairs on, and if you want to do part of this with feathers instead of fur, that's fine with me. I'm giving you something that's got a color scheme already to it, but feel free if you want to change that color scheme if you want. But realistically, if you're just trying to get the assignment done, this color scheme should be fine. Just go for it. Lighting scheme, it'd be nice if you picked a light source that was coming from behind, and then find a softer, a little bit less strong highlight or light source coming from the front, maybe from the top left or top right, and of course have an ambient light in there. But this is going to be your monster. Now we're going to move on to a demonstration of how I'd attack a problem like this. I'm going to demonstrate how to do your assignment on a different kind of creature. Same type of idea, as you can see, comparing the two. Yours is maybe a little bit more Muppet-like, and mine is just a little bit less Muppet-like, but they both have similar features. So, first thing we'll talk about is when you're doing something like this, having the right kind of brush is going to help a lot. I like to use a brush when I'm doing hair and feathers and stuff like that has a little bit of direction to it, so that when you paint it creates streaks of color. So this one's a good example of that, but there are other brushes, and we'll take a look at a couple of them. One example being, if you go to the loaded palette knife, and then this is of course assuming that you're using Painter. Photoshop is fine, and you can do the same types of thing in Photoshop, but I'm not going to show the specifics on that. So in the under window brush controls, just go to any one of those tabs there and scroll down to angle, and by default this brush is set to none, and I just switch it to bearing, and that means as you tilt and move your brush around, it's going to adjust the rotation, and you can see there's kind of a direction to that also. So you can use this one for doing hair pretty well. This is also a good one for feathers because it's got that kind of like soft, choppy look to it. And some others that I like, if you're using, where is it? There it is. Any of the camel hair brushes, at their default state, they're going to be a little bit hard to use because they tighten down to that little point. But when they spread apart, you can see how, oh, and this is in oils, by the way. See, when they spread apart, you can see those bristles. The thing about the camel brush in Painter is that it uses a special type of dab that scales up as you increase the pressure. So first of all, let's just increase the size so that we can see that a little bit better. See how that spreads. Then what I'm going to do is I'm going to go to the bristle. No, not the bristle. Sorry, that's what you would be doing if you're using the acrylic brush and you wanted to adjust the distance that the hairs are apart. Now what I want to go to is the feature right here. So if I turn the feature up, it's going to have fewer hairs, and if I turn the feature down, it's going to have more hair. So let's turn that up so that we have the hairs a little bit more spread out. Open down, and then we want to keep this on pressure probably. If I do none, it's just going to stay. Oh, actually it does no matter what. Alright, I guess that's just the way it works. So what's nice about this brush is if you're trying to create hair that has different kind of thicknesses, where the groups are kind of spreading apart and stuff like that, it works pretty well for that. In fact, I'm going to spread it apart just a little bit more. So that's going to be good for like drawing the hairs on top of things. But for now, I'm just going to go back to my captured bristle. And first order of business is going to be deciding what my lighting scheme is going to be. Like I said, I want a light from behind, I want a light from in front, and then kind of an ambient light. What I'm going to do for my ambient lighting, let's do this first. So I'm going to do a warmer light. Let's do more of an airbrush, going back to my cover pencil here. And we'll turn this to a gel layer. I'm just kind of bring everything down a little bit with that. And then I'll do a cool color coming from above. This is just my fill light layer, so don't worry too much if what I'm doing right now. If you don't want to go that complex with it, you can do a much simpler lighting scheme with it. But I'm not going terribly complex here. I'm just setting up a nice underlighting layer. So, all right, there we go. And I'm just kind of creating some variation in the color up here as well. Now I'm going to create a new layer, and this one's going to be an overlay layer. And I haven't decided yet whether I'm going to make that a warm or a cool color. Probably a bright cool color is what I'll start with. And I'm going to think in big to small. So start with the larger shapes, defining them, and then we'll worry about details after that. I'm switching over to the eraser now. I'm just going to erase away this layer to cast some of those shadows again. And because I'm going to be doing a lot with the hair here, I'm not going to worry about being terribly accurate yet, because I'm going to be basically painting over this whole thing in the end anyway. This is just giving me a nice foundation to paint from. Okay. That's not too bad. Oh, getting a lot of artifacts right now. Okay. And let's throw in another layer just to darken everything down a little bit. Except not something that has so much color to it. There, that's a little better. I'll turn this down a little bit. I'm going to go a little bit stronger with my lighting once I've got the hair in, but this is probably a good start. Alright. Let's start first of all with any fuzz that there may be on the surface. And to do this, I'm going to create a new layer. I'm going to use just kind of a brush that has a little bit of something to it. And maybe I'll use even something that has a different color to start with. So I'll put some of that just kind of generalized color down. Just trying to keep the fuzziness of it in the way that I put the strokes down. And I'm doing this all on a layer because that's going to be a lot easier to clean up after the fact. That's probably enough for now. So just put a couple more on this nose. Now, because it's on a layer, I'm going to do what's the darker version of that. And let's shift this color a little bit also. We'll trend a little bit towards that blue. And now all we have to do is just erase away the edges. And just like other things we've talked about, we're just going to kind of build up layers one at a time. And like I've also talked about before, don't worry too much if at first it doesn't start to work out. Just keep putting down the layers, and eventually things will come together, assuming that you're doing it right. And I'm going to drop that. And what I'm going to do is I'm just going to put in a little bit more shading in for these teeth. And by the way, what your lighting scheme is, that's going to be up to you. Put in the lights in the positions that I told you, but don't necessarily, it doesn't matter what's warm and what's cool. If you want to make your key light here be a warm light and the shadows be a cool light, I'm doing the opposite in this case, but you do whatever you want. Your rim light, I'd say for just about anything, don't put in your rim light until you've got mostly everything else done. It's just going to be a lot easier to deal with later. It's going to be easier to put in later. Just kind of keep in mind that you're going to have it there so that you don't spend a whole lot of time painting along the back edges and places where that's going to be. All right. I'm not going to spend a whole lot of time with that part, But let's emphasize that kind of fuzz idea here by making it so that you're seeing through a little bit more to the skin underneath in this muzzle area. Now I'm going to start working on the heavier fur that I want kind of surrounding the face and here in the chin. So this is just going to be a little bit, this is going to be like the short fur that we talked about before. So I'm going to start off by creating a new layer, and I'm going to start defining what those clumps are going to be shaped like. And right now I'm just kind of drawing in the clumps. I'm not going to do a whole lot more than drawing just for the moment. And as I draw in these clumps, I'm thinking about just, you know, where is this fur hanging? Where is it hanging from on the flesh underneath? Things like that. So now that I've got something kind of drawn in, well, let's draw it in here too. All right. Turn that down a little bit. So that I've drawn that in, I'm going to start painting in the occlusion shadows, that what we're going to see when we look into the depths between those clumps of fur. And I'm doing this on a separate layer now. And right now I'm not thinking about where I can see into the depths necessarily based on my camera angle. I'm just kind of painting it all in right now, and then I'm going to erase it away so that we can, after I've got it all painted in, I'm going to erase it away so that we can see a little bit better. And we'll probably have a little bit just up here on the brow as well. And I'm also going to do occlusion just around this outside edge. Just to define that muzzle shape again, or the jaw. We'll put just a little bit definition right there too, which I'm going to pull back now that I'm using the eraser. And I'm going to erase the occlusion more on these outside edges because you're going to see more of the hair, and then a little bit less on the inside edges where we're going to be able to see into the depths of the fur. And I may actually just kind of darken that area in general. And this, because we're doing all of this lighting from the front, it's going to look a little bit flat at first. Don't worry about that, because we're going to put in our secondary light source in just a little while. So I'm erasing this stuff so that it gets darkest right where it goes up into the fur and then fades out towards that outside edge. So we basically have a sharper edge on the upper side and a softer edge on the underside. At least as far as the shadow is concerned, it's sharper. As far as the hair is concerned, you want it to be sharper on the underside. And I'm just going to pull that back a little bit. Now I'm going to create a new layer where I just find the very deepest spots and paint occlusion into those, just to really pop those places and make them look like they're really going kind of deep in the fur. You don't want too many of these, because it's going to, you know, these become kind of dark accents. They're like highlights. They're going to draw attention. People are going to want to look at these spots because they become slightly higher contrast. So I'm starting off with maybe more than I want here. And we'll erase them in just a second. Again, I'm doing this on a layer so that it's easy to pull it back in a second. And like I said, I probably painted in too many, so I'm just going to pull a couple of these back. Okay. This is kind of a shaggy monster the way I'm painting it right now. Let's go ahead and drop everything. Alright, now I'm going to paint in that key lighting. I painted in where I wanted the key lighting to be earlier, but I pulled the layer back a little bit so that it would be easy to kind of push a little bit further later. So I'm just going to start with the uniform color, but I'm going to do it on a layer right now, a new layer. I'm just going to catch light on the edges of that fur, those layers of fur. And remember, I'm thinking in terms of clumps here. That's why I'm painting the way that I am. And don't worry too much about color variations. I can always paint that in later if I want to. And with anything, you want to think not just in terms of the texture, you know, making it look accurate, but you want to think in terms of design. You want to look at big, medium, small shapes. You don't want all of these shapes here to be uniform in size, because when they become uniform in size, they become kind of noisy, or, you know, it just kind of becomes distracting to look at. So I want to make some of these shapes be a little bit sharper and larger. I want some of them to be fuzzier. I want some of them to be a lot smaller. So I'm going to break them up so that there's a bit of variation there. And I'm going to erase away so that our cast shadow looks good. And now add a little bit of color variation in there. Something like that. And you can see it's starting to become a little bit distracting in that area. So what I'm going to do is I'm just going to pull that back just a little bit. And there's a couple different ways of doing this. One is just to throw in a lighten layer. So just kind of pick a color that's in the middle of our spectrum here. And I'm going to pull up all those values. And the light layer actually is a pretty good way of dealing with this, because what it's going to simulate is the way that light is hitting that fur and bouncing up onto the other clusters or clumps of fur. Of course, I'm taking that too far so that we're losing the occlusion, but I can always erase away little bits of it here and there to get some of that back. Something like that. Now I'm going to do the same sort of thing down here, but I'm going to show you a different way to do it, which you may be familiar with this already because I've used it before. And just create a new layer, and this time I'm going to use an overlay layer type. But what I'm going to start with is probably something that's a little bit more just lit up generally first. Now I'll switch it to an overlay layer type, and you can see I'm able to light the area up just as well that way. It's maybe not quite as good for a color control type of way of viewing things, but for most intents and purposes, maybe not all, it's pretty much the same. I'm going to turn it down just a little bit. And again, we have some of that problem with the darkening in the highlight areas, creating some kind of distracting stuff, which we can clean up a little bit just as we go. And it's okay to overlap a little bit on the stuff that we've drawn already, just because hairs do tend to overlap. And by the way, I may have said this before, but if you want to do this assignment with half feathers, part of the reason why I went with a kind of Muppet-like creature is so that it would look good whether you did hair or feathers on it. I'd say don't do all feathers, just so that we can be sure that you're learning all of the principles, but should be fine if you want to do at least part with feathers. Alright. Let's darken down the shadow side of this. And you can see I'm taking the terminus, or the terminator, just a little bit farther than I would if this was just a diffuse surface. I'm catching on individual hairs and stuff like that. Let's do another overlay layer, this time just with full bright, just to add some lighting to this lip. And like we talked about the transition to hair earlier, I'm going to do the same type of thing from the lip to the fur. I'm just going to make it so that we're getting a little bit of that skin tone underneath. I'm going to say that it's kind of a purplish black, kind of like you'd have with, ever notice that certain dogs, when they open their mouths, their skin underneath by their lip and by their tongue and stuff like that can sometimes be black. Okay, that's good enough. This is a Muppet. We're not going to worry about getting that perfect as far as making it feel like flesh, because we're going to talk about flesh in the next lesson. We'll get a little bit of shadow in that upper lip there. Okay. And we'll just catch a little bit of a specular highlight here. Just for fun, even though that's not really part of the assignment. All right. Do the same type of thing with the hair or the eyes. We'll start with shorter hairs and kind of put in some longer ones as it goes out. Same type of thing down here. We can actually do longer for hanging down here. I think my clumps here of hair are just getting a little bit too separated. I'm going to have more overlap as it curves around the forearm here, so that we're seeing into the depths of the clumps a little bit more up here, and as you get a little bit farther away, we're going to see more of just how the clumps lay over each other. Okay, that's good enough. Trying to get some of that suggestion and occlusion shadow in there. Get that transition in place. It's a little bit too speckled still, but we'll worry about that more in a second. Okay, there's another way to do this, which we've talked about before, where we're dealing with a photo or something else like that for an overlay. Let's do even smaller than that. And I can flip this back and forth just because the lighting on it isn't uniform. It's not from a single direction, it's more of an ambient light source on the fur itself. I'm going to turn the saturation down so that it works with the photo overlay, and it looks like I don't need to do a whole lot with the values. Maybe bring it down just a little bit. And let's turn it back. We can erase away here. And you can always use a combination of these things if you want. All over your image. And this is really just going to be up to you. What do you want to do? You're probably going to learn more trying to paint it from scratch, but this industry is all about results, so it's okay if the entertainment industry, that is. I guess if you're going into fine arts, then maybe things are different, but in my industry, things are all about results, so it's okay if you take a few shortcuts like this. So we establish some fur there on him, but usually just straight overlay doesn't look that good, or it doesn't blend in well with what's going on elsewhere in your painting, so it's usually a good idea to go in and give it just that careful touch with your brush. Now I'm going to be using the texture as my guide for where I've got clumps of hair, stuff like that. So I'm just going to kind of catch along some of these edges to create some more clumps like what we had up above.